Unlock the power of data with the Google Cloud Data Analytics course. In this comprehensive program developed by Google Cloud, you will learn the skills to analyze, visualize, and communicate insights from complex data sets, transforming raw numbers into actionable strategies. Through expert instruction and hands-on challenges, you'll build a portfolio of industry-relevant projects that demonstrate your expertise. This complete course can be watched alongside the Google Cloud Skills Boost platform, where you will find interactive labs and hands-on practice environments. You get 35 credits free per month for labs, but for faster completion, you can pay for unlimited access. At the end, you can earn a certificate. So let's begin your journey into cloud data analytics with the foundational concepts you'll need to start or advance your career in this field. And thanks to Google for providing a grant to make this course possible.
There's something happening right now everywhere in the world that's changing all of our lives in every way. It's cloud computing. How can cloud computing make that much change? By connecting us, people, with data, quickly, easily, and anywhere at any time. It affects how we communicate, work, shop, plan, and even how we relax and have fun. The cloud is changing people's lives, and it's also completely reshaping and improving business. These days, data is the cornerstone of all kinds of organizations. They depend on nonstop information about sales transactions, consumer feedback, inventory and purchase orders, customer service interactions, market research statistics, and so much more. Uninterrupted access to business data is a must for organizations, which creates another must: people who can assess that data and put it to work. And this is why the demand for cloud data analytics professionals keeps growing and growing. We need people like you to help organizations understand their customers, collaborate with partners, strategize for the future, mitigate risk, and become more flexible and resilient. The content in this program will equip you with the knowledge and skills required of entry-level roles in the field of cloud data analytics. Hi, I'm Joey. Here at Google, I am an analytics manager. This means that I lead a team of business analysts whose job is to provide data-backed insights to inform key business decisions. I'm so happy to welcome you to the program. I'm your Course 1 instructor, and I'll be by your side the whole way through this course. I grew up in a single-parent household in the Los Angeles area with strong roots in my Mexican-American heritage. Living in a big, diverse, complicated city like LA, while challenging at times, definitely instilled in me a passion for connecting with diverse groups and helped me build interpersonal skills that have been super valuable in life and in my career. My career path wasn't linear or planned, but through an internship and an early career rotational program, I discovered a passion for data analytics and specifically using data to help people make better decisions or gain knowledge they wouldn't otherwise have. As an analyst, I want to show folks that data is for everyone and make technical work less intimidating and more approachable to all. The program is divided into courses based on different cloud data analytics processes. The course topics include an introduction to cloud computing in data analytics, cloud storage and data management, data processing and analysis in the cloud, and visualization of data in the cloud. I encourage you to complete the courses in order as each topic builds on what you've learned before. The final course is the capstone. It's a great opportunity to demonstrate the knowledge and skills you gain throughout your academic journey. We've got videos and readings to teach you cloud data analytics concepts and skills. Then, interactive activities and labs will let you practice those concepts and skills. You can take the labs more than once, so if you hit some trouble spots, just keep at it. You'll also have quizzes to confirm your understanding, and glossaries to help you prepare to do your very best. And career resources, including resume and interview prep, will help you prepare to apply for jobs and impress hiring managers. You'll hear from Googlers like me working in cloud computing. We'll give you an inside perspective at what it's like in our industry and share personal stories of how we got into the field. Some of these Googlers are going to join me in guiding you through the courses. Let's take a second to meet them now.
Hello, I'm Eric and I'm a product analyst at Google. In Course 2, you'll explore how data is structured and organized. You'll gain experience with data lakehouse architecture and cloud components like BigQuery, Google Cloud Storage, and Dataproc to efficiently store and analyze and process large datasets. Next, you'll meet my colleague, Alex.
Hey there, I'm Alex, and I'm a data analytics customer engineer. I'm really looking forward to spending time with you as you learn all about the data journey, from collection to insights. You'll explore data transformation and practice strategies to transform real data sets to solve business needs.
Hi, I'm CJ, and I work in data analytics here at Google. I'll guide you through the key stages of visualizing data in the cloud: storytelling, planning, exploring data, designing visualizations, and collaborating with data. You'll use Looker to create data visualizations and build dashboards.
I'm Christine, your Course 5 instructor. Together, we'll put everything you learn from across courses 1 through 4 into action in a capstone project, and you'll create impressive work examples to share with future employers.
All of us are thrilled to introduce you to the fascinating and rewarding field of cloud data analytics. So, let's get you started on your cloud journey. Not too long ago, when a company stored data or ran programs, it needed a huge room filled with a bunch of gigantic, noisy computers humming away right there in the office. But in the 1960s, a group of engineers asked, what if we share computing power among many users so not everyone needs their own computer? Fast forward a few decades, and here we are with remote data centers ready to store our data, run our apps, help us with analysis, and so much more. In this course, you'll start your journey into the world of cloud computing and gain the fundamental knowledge you need to be successful in the field. Whether you're a cloud newcomer or seeking to level up your cloud skills, you've come to the right place. This course will provide you with a solid foundation in key concepts, skills, and tools used for data analysis with Google Cloud. I started my career as a philosophy graduate with no professional experience, unsure of how my education would translate into a job. But after being exposed to a few different roles at Google, I found a passion for data analysis and engineering, where a lot of entry-level tasks were like mini logic puzzles that I was paid to solve. I looked forward to the technical challenges that the role offered, which provided the building blocks for my current career path. I first learned to write SQL in my role as an HR analyst at Google. One of my first responsibilities was as a primary responder on our team's ticket queue. Each day, we'd receive requests from internal business partners to produce data reports, usually in the form of big spreadsheets with custom logic based on real business questions and problems. I really enjoyed the process of fulfilling these requests, starting with transforming the business request into an analytics problem, using SQL to mold the data into an answer, and providing a data set that was understandable and approachable to our non-technical users. It felt great to offer a service to our users and give them information that they couldn't otherwise obtain. It was fun. As more organizations adopt cloud-based solutions, there's a growing need for skilled cloud professionals to help them make the transformation. To get you on your way, I'll introduce you to the program, let you know what to expect moving forward, and share some great tips for successfully completing the certificate. You'll learn how to define cloud computing, identify its components, and differentiate between cloud and traditional computing. You'll explore cloud data analysis compared to on-premises physical data analysis. And you'll learn about the impact of cloud data analytics on all kinds of businesses, with a special focus on the Google Cloud Architecture Framework. Then, you'll discover the inner workings of data management and the data lifecycle, and the cloud data analyst's role in keeping both running smoothly. You'll also explore how cloud professionals collaborate to create some really cool business projects together. Finally, you'll discover key tools in the Cloud Data Analyst Toolbox and learn about the importance of process management in cloud computing. As you progress, you'll be introduced to Google Cloud-based tools, including BigQuery and Dataproc. And after completing this course, You'll know about cloud data tools and be able to understand and communicate cloud benefits, share timely insights, and so much more. I'm so excited to be part of your cloud data analytics exploration, and I'm here to guide you every step of the way. Let's keep the momentum going and head on over to the next topic. Hey there! Coming up, we have many exciting things to discover about the cloud. Here's a quick breakdown. First, we'll check out the basics of cloud data analytics. You'll learn about its history and explore the many benefits of cloud computing. After that, you'll consider the differences between cloud computing and traditional computing. This includes their network infrastructures, defining characteristics, and advantages and limitations. Next, you'll tap into the program resources so you can make a plan to be successful and career ready. To wrap up, peruse the glossary with key terms and definitions. Meet you again soon.
My name is Ben, and I'm the Senior Vice President of Learning and Sustainability at Google. I'd always been interested in learning because for me, my mother was a school teacher, and I felt that learning is really what enables people to reach a different point than they otherwise would. I know it enabled me to go to a place I could not have dreamt of being were it not for the education I got. And I think that's incredibly important for people to have access to that kind of opportunity. And growing up in India, I did have access to a good school. I did not come from a wealthy family, but I had access to a good school. And I saw the difference it made in my life. And I think today, with the help of technology, we can hopefully bring more of that opportunity to more people in the world. The cloud is really important because it's a trajectory of where computation is going. If you think about all of the major products that you use, almost all of them are now based in some online cloud data center. And they have access to all these amazing computing resources, and they enable you to these services to really provide amazing things for their users. So studying cloud technologies enables you to participate in that whole economy of jobs and of opportunities that consist of building these powerful facilities in the cloud that are being used by people around the world. One of the really interesting ways in which education is evolving is allowing people to build and learn individual skills through various skilling courses. Many aspects of education are not available to everybody everywhere, unfortunately. But it's possible to build the basic skills that one could get that one needs from an education more piecemeal today. And I think the approach of skilling can allow people to build up the pieces of the education that they really need in the way that they have access to, in the way that they have time for, in a way that they have the resources for. The initial parts of learning anything are learning the basics and the fundamentals. Whether it is a sport or a physical skill like carpentry or whatever, the first steps are learning the basics. So persevere with it, and it'll get really interesting. I've been working with computers for, over 30, 35 years, and it is still fascinating every day.
Hello, cloud enthusiasts. Get ready to learn exactly what cloud computing is all about, including how it works, the components of a cloud infrastructure, and different cloud service models. So, first up, what exactly is cloud computing? Cloud computing is the practice of using on-demand computing resources as services hosted over the internet. Over the internet is what makes up the cloud part. It eliminates the need for organizations to find, set up, or manage resources themselves, and they only pay for what they use. Cloud computing uses a network to connect users to a cloud platform. This is a virtual space where they can access and borrow computing services. A primary computer handles all communication between devices and servers to share information, and there are privacy and security measures to keep everything safe. Here's another way to think about it. Picture cloud computing like a shared kitchen in a rental apartment, owned by a property management company, or in the case of the cloud, a third-party service host. The kitchen has many appliances and cooking tools, just as the cloud platform has servers, storage, hardware, and software. So when someone in the apartment gets hungry, they just go ahead and cook a meal in the well-equipped kitchen. They don't each have to buy their own wooden spoons or toaster oven. Likewise, the cloud enables organizations to access computing resources on demand, without spending time and money buying and maintaining their own storage, hardware, and software. It's the unique infrastructure of a cloud computing model that makes all of this possible. This infrastructure has four main components: hardware, storage, network, and virtualization. Let's check out hardware first. Types of hardware include servers, processors, and memory, network switches, routers, and cables, firewalls and load balancers, cooling systems, and power supplies. These are the physical items needed to keep things running. Now, data storage in a cloud computing infrastructure can occur in three main ways: file, object, or block. File storage keeps data in one place and organizes it in a simple, easy-to-understand way through a hierarchy of files and folders. This is the oldest and most widely used data storage system, but it's a bit cumbersome and can only accomplish so much. Next, object storage holds unstructured data along with its metadata. Metadata is just data about data. For example, a picture taken with a smartphone might contain information about the location, the date, and the type of device that captured the image. This is really useful for understanding the photo, just as metadata explains what its own data is all about. Lastly, block storage divides large volumes of data into smaller pieces, optimally organized with unique labels. An advantage of block storage is that the data is easily accessible, but it can be expensive and has limited capability to handle metadata. All right, now we have the network. After all, cloud computing infrastructure needs a way to connect its back-end resources, and this connection is made possible through a network of the physical hardware. Through this network, users tap into cloud resources using some of the hardware mentioned earlier, including routers and firewalls. Basically, the physical network setup is what enables the virtual one to operate. Finally, there's virtualization, which is a technology that creates a virtual version of physical infrastructure, like servers, storage, and networks. This is what lets the service work without a connection. Here at Google, we have many data centers. A data center is a physical building that contains servers, computer systems, and associated components. These facilities provide a centralized location for vast amounts of data, and skilled cloud analysts access this valuable information right through the cloud. For all sorts of business tasks and projects, cloud analysts select and extract relevant data, then prepare it for processing and examination. They know how to expertly analyze, visualize, and share data discoveries to uncover valuable insights and make smart business decisions. So it's really important to know that there are three primary models to choose from. Each offers a different level of flexibility and control. These models are infrastructure as a service, or IaaS, platform as a service, PaaS, and software as a service, SaaS. First, IaaS is a cloud computing model that offers on-demand access to information technology, or IT infrastructure services, including hardware, storage, network, and virtualization tools. With IaaS, a service provider hosts, maintains, and updates the infrastructure. Your organization would manage everything else: your operating system, your data, and your applications. An IaaS model provides the highest level of control over your IT resources and works a lot like traditional on-premises IT. An example of an IaaS model is cloud storage, like emails you've sorted into an online folder. Here's another example. When someone leases a car, it's like they're borrowing it for a while, having fun driving it around, but they have to give it back when the lease agreement is up. Well, IaaS is kind of like that. A user picks the infrastructure they want, uses it for the contracted period, but they do not own it. Next, PaaS provides hardware and software tools to create an environment for the development of cloud applications, simplifying the application development process. PaaS is all about helping users build apps. So, your organization would enjoy being able to fully focus on app development without the burden of managing and maintaining the underlying infrastructure. Your developers would create, test, troubleshoot, launch, host, and maintain your app all on the platform. PaaS is like hopping into a taxi and telling the driver where to take you. You're not behind the wheel, but you trust the driver to get you to where you need to be. Lastly, SaaS provides users with a licensed subscription to a complete software package. This includes the infrastructure, maintenance and updates, and the application itself. Other users also have access to use the same services. Using SaaS, you just connect to the app through the internet. Think of SaaS like riding the bus. You pick your stop from routes that are set already, and you share the bus ride with other people. Remember that these examples are meant to demonstrate the level of individual customization in IaaS, PaaS, and SaaS. They do not refer to any actual hardware or software details. Woo! We've covered a lot about cloud computing, infrastructure, and service models. I think we've earned ourselves a study snack. I'm gonna go cook something up in my cloud kitchen. Catch you later. I love today's module because I get to do one of my most favorite things, nerd out about the cloud. I'm a huge fan, but I also know that as a cloud data professional, my enthusiasm level may come on a little strong for folks who don't have a cloud computing background. That's why it's important to really understand the cloud and its many advantages, so that you can explain it clearly to others in a way that is easy to understand and hopefully exciting. Let's first learn about accessibility. One of the big advantages of a cloud computing model is that organizations can access and manage data, software, storage, and cloud infrastructure from any location at any time through the internet. They don't need to be physically present where the hardware and software are installed, and they don't need their cloud service provider's assistance when they need more data. Next is scalability, which means to easily expand or upgrade computing resources to meet changing needs. Scalability eliminates physical computing limitations. Now, the benefit of cost savings is pretty straightforward. Organizations only pay for the computing resources used. In a cloud computing model, organizations get what's called a measured service. Similar to household utilities like electricity and water, users are charged only for what they use, based on the number of transactions, the storage volume, and the amount of data transferred. This helps make all kinds of business initiatives more profitable and sustainable. The advantage of security is also pretty straightforward. With cloud computing, an organization's systems, data, and computing resources are protected from theft, damage, loss, and unauthorized use. Cloud computing security is generally recognized as stronger than the security of a traditional network infrastructure. This is because data is located in data centers that few people have access to. Plus, the information stored on cloud servers is encrypted, meaning it's not something that's easily broken into. Okay, moving on to efficiency. There's a lot that's efficient about cloud computing, but one of the main advantages is that organizations can provide immediate access to new and upgraded applications. There's no time wasted worrying about the state of network infrastructure or going through a costly or time-consuming implementation process. There are tons of amazing things about the cloud, and now we've come to freeing resources so users can focus on more value-added tasks. In the cloud field, we refer to this as managed services. A managed service involves a third-party provider taking care of the ongoing maintenance, management, and support of an organization's cloud infrastructure and applications. This, in turn, gives users lots more time to focus on other work. It's like a mechanic who automatically comes to you for annual inspections and services, rather than you spending many hours in a mechanic shop waiting for services. That's because all of the ongoing maintenance and management from the cloud happens automatically in the background. A user doesn't have to initiate it. Because cloud computing is super versatile, it offers a wide range of common uses, including disaster recovery, data storage, and large-scale data analysis that provides users with significant benefits. Let's start with disaster recovery. Using cloud computing in disaster recovery means having access to more data centers to ensure that data and information is safe and secure during an emergency. The next benefit is data storage. Data storage helps streamline data centers by storing large volumes of data, which enables easier access to the data, analysis of the data, and backup of the data. Then we have large-scale data analysis. Large-scale analysis offers easy and quick access to multiple data sources and intuitive user interfaces to query and explore the data. This speeds up the overall process of discovering data-driven insights. Isn't cloud computing amazing? Users can say goodbye to the limitations of traditional data storage and computing methods and enjoy the world of advantages that it offers. And data analysts can help users seize these advantages with expert cloud data analysis skills. When cloud computing was first introduced, many people resisted the idea of losing physical control over important files, cherished photos, and all sorts of other data. People were used to keeping these things close by, under their own roofs. So let's use those cherished photos as an example. Putting a photo in an album that you keep on your bookshelf does offer control, convenience, and security to a certain extent. Control can be limited by resources. You need money, materials, and time to print out a photo or purchase a frame or album. You can also only fit so many physical items in your space. As far as security goes, well, that physical memento could be damaged. Now let's think about how we can enjoy that photo if it's in the cloud. You can view and share it anytime, anywhere. And if you still want a physical copy, you can make one and feel comfortable knowing that you have backup, just in case. Choosing between traditional and cloud computing is also a trade-off. Both have advantages and limitations, and both can have a place in business depending on what the priorities are. In this video, you'll learn about traditional computing, how it works, and its defining characteristics. You'll then compare traditional and cloud computing, which will be valuable to know in the role as a cloud data analyst. So, what's traditional computing? Traditional computing is a computing model that enables data storage, access, and management through the use of physical hardware and software within a network infrastructure, typically located on premises. Here's how that all comes together. First, hardware is set up in a dedicated space or room by IT professionals. Next, the required software, operating systems, applications, and security tools are purchased and installed. Once the hardware and software are operational, IT personnel are responsible for maintaining and managing the entire system. This infrastructure gives an organization sole control and access to its data and equipment. So, with traditional computing, everything you need is located in one location on premises and can't be accessed anywhere else. This defining characteristic offers 4 key advantages: control, security, compliance, and no reliance on the internet. Let's explore each of these. First, with traditional computing, organizations have full control over their hardware, software, and data. They can customize their localized network infrastructure to meet their specific needs. And because of this control, users usually feel more confident about the second advantage, security, if properly maintained. This is because they have sole access to their systems and sensitive information. Third, traditional computing might be the only viable option if a business is in an industry that requires data to be stored on premises. This is an example of compliance, which means that a company must follow certain regulations, rules, and laws, in this case, ones that deal with data security. Lastly, traditional computing does not rely on an internet connection when users want to access the network or the data it contains. So, important information can be accessed even if internet service goes down. But just as with our photo album example, there are some downsides. First, with the traditional computing system, data access is limited to the device and location where the hardware and software are installed. Also, scaling up in a traditional computing model is challenging. Software limitations, the time needed to purchase and set up hardware, and the physical space required make it difficult to scale. And expensive. Besides scaling up expenses, traditional computing involves buying hardware and software, plus ongoing maintenance of network infrastructure. Lastly, traditional computing can be inefficient, as each user's software must be purchased rather than shared. And again, the software is not automatically updated. These are just some of the reasons why many organizations are moving to the cloud for their computing needs. The cloud is more accessible, scalable, and offers tons of savings. It's also super secure, efficient, and frees up staff to work on more projects. It's picture perfect. Get it? Thanks for joining me as we venture into the wide world of cloud data warehousing. There's so much data out there, it's truly dizzying. So it's no surprise that businesses have struggled to figure out where to keep it all. The fact is, traditional databases struggled to keep up with the evolving demands of data analytics. Luckily, cloud data warehouses are emerging to fill the need. How do they do it? Well, that's what we're going to learn about in this video. First, a cloud data warehouse is a large-scale data storage solution hosted on remote servers by a cloud service provider. To understand this better, picture it like a huge warehouse where large amounts of different types of containers from various places are stored. The cloud data warehouse can collect, store, integrate, and analyze data. There are many advantages to this structure. Cloud data warehouses are typically fully managed by the cloud provider. This means that the cloud provider takes care of various operational tasks and maintenance, allowing users to focus on utilizing the data and gathering insights rather than handling the underlying infrastructure. This saves time, money, and resources. Cloud data warehouses also have more uptime compared to on-premises data warehouses. Uptime is the amount of time a machine is operational. And of course, only working computers have the ability to scale and support increased demands for data. Next, cloud warehouses can integrate separated data by gathering data from various structured sources within an organization, like sales systems, email lists, and websites, and pulling it all into one place. This integrated data then can be analyzed for some pretty exciting and useful business insights. Another big advantage is that cloud data warehouses provide real-time analytics, ensuring users have quick access to the latest information. And in business, being fast is usually the key to outperforming the competition. Cloud data warehouses also offer some really cool artificial intelligence, or AI, and machine learning, or ML, capabilities. And when you apply AI and ML to your data analysis, this really powers up the possibilities. My team worked on a recent project where we built a predictive model to help Google anticipate demand for office amenities, such as its cafes, and help save money and reduce waste. Using ML tools, we were able to test over 30 factors across months and months of data and build a model that could forecast demand with enough accuracy and time to allow on-the-ground teams to adjust accordingly. Pretty cool, right? Last but not least, cloud data warehouses enable custom reporting and analysis. This means that users can analyze and generate reports specifically from historical data because it is stored on a separate server from data related to current business transactions and day-to-day operations. As you've probably figured out, the types and amounts of data that companies need to organize are only growing, which means so is the demand for data storage. Luckily, cloud data warehouses are up for the challenge, with the added benefits of management and analysis to make it even easier to use the data you have. Okay, data enthusiasts, now that we know what cloud-based data warehouses are, we should probably figure out which one suits our needs. And I've got a great one to introduce to you. Meet BigQuery, Google's powerhouse of storage and analysis. An organization's data is vital to its business success, and data warehousing helps make the most of that data by providing quick and easy access to information, which leads to ideas, insights, and best of all, data-driven decision-making. BigQuery is a data warehouse on Google Cloud that helps users store and analyze data right within BigQuery. They can query data, filter large data sets, aggregate results, and perform some really complex operations. BigQuery works with SQL, or Structured Query Language. This is a computer programming language used to communicate with the database. It allows users to search through massive amounts of data and find information they're searching for incredibly quickly using Google infrastructure. As a cloud data analyst, BigQuery's integrated SQL interface and machine learning capabilities will help you discover, implement, and manage data tools to inform critical business decisions. The output of your work in BigQuery can integrate with typical business intelligence tools or spreadsheets. But there's a lot more to explore. Another feature is BigQuery's ability to easily migrate existing data warehouses from other cloud service providers. This is a huge time saver. One of my favorite things about BigQuery is its dry run parameter. This lets you check your query thought process and plan before actually running it. And BigQuery would tell you the number of bytes the query will run so you can estimate the cost before actually querying the database. It's like a practice swing in golf to help you make sure your ball goes in the hole. You can also use BigQuery to store, explore, and run queries on data gathered from servers, sensors, and other devices. And scheduled queries can be used to automatically refresh data and keep tables up to date. Data can be updated hourly, daily, or weekly, so you'll deliver the most dynamic, timely metrics to your stakeholders. On my team, we use BigQuery almost daily to query, transform, and report on data. Using BigQuery, we're able to tap into a multitude of data sources, which allow us to support our users with the most relevant insights. We use SQL to join datasets and transform the data, creating tables and charts that provide answers. And when we land on an answer that can be useful in the future, we scale it, building self-service reports and dashboards that allow users to retrieve the same answer over and over again in a timely manner. For my team, BigQuery helps us create a bridge between the data that exists and the problems folks are trying to solve or questions they're trying to answer. With its smooth integration with other tools, user-friendly interface, and the use of SQL for effective programming, BigQuery makes the discovery of valuable information within complex datasets simple and productive. It's an essential part of the Cloud Data Analyst toolbox. There's tons to explore, so have some big fun getting to know BigQuery. This will be an invaluable tool for your cloud career. It's been a blast introducing you to the field of cloud data analytics. You've learned that cloud computing is an advanced and powerful computing model that resolves many limitations of traditional computing. It also addresses evolving data computing needs of people and businesses all across the globe. Cloud computing provides on-demand availability of computing resources as services over the internet, which offers accessibility, scalability, cost savings, security, and efficiency. And it frees up your time and resources so you and your colleagues can focus on the kinds of tasks that bring more value to your team and organization. You began this course with an introduction to cloud computing. You then learned about its history, current defining characteristics, and the advantages of using a cloud computing model. Next, you examined the differences between cloud computing and traditional computing, like a physical network infrastructure in traditional computing versus a cloud network infrastructure in cloud computing. You've got this. And remember to celebrate your hard work in a favorite way. A yummy snack, a comfort show, or a touchdown celebration. Hi there. Welcome to the next section where you'll continue learning about data analytics in the cloud. In this section, you'll explore migrating data to the cloud from on-premises systems, and together we'll get into the differences between on-premises, hybrid, and cloud data system architectures. You'll also learn a lot about the Google Cloud Architecture Framework throughout. You'll witness cloud's impact on data analytics and many other industries, and you'll check out strategies for cloud cost optimization and its benefits for users. You'll also explore the cost of storage, running queries, and resource provisioning, along with the different billing models. This information will help guide your future employer towards the most cost-effective cloud solution for their particular needs. Meet you in the next video. Anyone who's been through a move knows that it's a lot of work. There's emptying shelves, sorting items for packing or donation, carefully boxing everything up, loading the boxes into a moving van, and then you have to unpack and get everything organized in its proper place once you get to the new place. Whew. An organization migrating its physical computing infrastructure to the cloud also requires careful planning and a great amount of effort to ensure a successful move. Fortunately, Third-party cloud service providers like Google Cloud can help make everything easier. In this video, we'll discuss the process of migrating an on-premises computing network infrastructure to a cloud platform. You'll learn the steps to follow, cloud data migration strategies, and important factors to consider during migration. All right, the first step is to think about some key factors. These include choosing the right cloud environment for your organization. Then think about how much data will be transferred to the cloud. This is important because large amounts of data can take a long time to move, which can delay operations. Next, consider how much downtime your organization can deal with during migration. Obviously, no business wants to shut down their systems any longer than necessary, so this decision should be agreed on by all stakeholders. The next step is to choose your migration strategy. Options include rehosting, also called lift and shift, replatforming, repurchasing, refactoring, or retiring. Let's break those down. Rehosting is a cloud migration strategy that involves moving an entire on-premises system to the cloud without changing anything else about the system. An exact copy of the current setup is created in the cloud, which helps the organization quickly achieve a return on investment as they use the enhanced efficiency of their operations, the robust and reliable nature of the cloud infrastructure, and the innovative technologies that are built into cloud-based solutions. Replatforming is a cloud migration strategy that involves making small changes to the on-premises system once it's migrated to the cloud. So, the main structure of the system's applications remain the same, but a few things are improved for better performance. Repurchasing is a cloud migration strategy that involves moving applications to a new cloud-based service platform, usually a software-as-service platform. The cloud service will be an all-new experience, so this requires some team member training. Refactoring is a cloud migration strategy that involves building all new applications from scratch and discarding old applications. This is ideal when organizations need new features like serverless computing that their current systems don't have. Retiring occurs when applications that are no longer useful are turned off. The next step in the migration process is choosing your migration partner. As a cloud professional, you'll want to help your organization find a cloud service provider that offers the right infrastructure for your particular business, that offers valuable services and tools, and that invests in development to keep things fresh. It's also important to examine the provider's customer support and service level agreement, or SLA, so you get reliable and prompt support. Obviously, I'm a big fan of what we do here at Google, especially how we help our partners prepare for cloud migration success. We've got something called the Google Cloud Adoption Framework, which helps users assess their organization's readiness to adopt cloud technologies. This framework acts like a map from current capabilities to their ideal cloud destination. The Google Cloud Adoption Framework evaluates 4 themes. First, learn refers to the quality and scale of an organization's learning programs. Lead describes the level of support from leadership given to an organization's IT department when migrating to Google Cloud. Scale is the extent to which an organization uses cloud-based services and how much automation they need to manage their system. And secure ensures an organization's ability to protect their cloud environment from unauthorized and inappropriate access. Google Cloud provides a migration path that also has 4 phases: assess, plan, deploy, and optimize. In the assess phase, users perform a thorough review of their existing network infrastructure. Then, in the plan phase, users set up a basic cloud infrastructure on Google Cloud where their workloads will exist. When it's time to deploy, the workloads are actually moved to Google Cloud. Lastly, the optimize phase is when organizations begin using cloud-based technologies and features. And this is where they start to really enjoy the improved accessibility, scalability, cost savings, security, and efficiency. Like any move, cloud migration requires careful planning. As a cloud data analytics professional, the ability to help your organization follow the steps in this video will help ensure everything gets to where it needs to be so you can enjoy your beautiful new place in the cloud. Welcome to this intro to cloud deployment models. We're going to explore how to advise any organization in choosing the right environment for their unique business needs. There are 3 primary models: public clouds, private clouds, and hybrid clouds. As a cloud data analytics professional, it will be important to understand how each works. Then, you can help your organization select a model that's flexible, adaptable, and helps users quickly respond and adjust to changing conditions. First up, a public cloud is a cloud model that delivers computing, storage, and network resources through the internet. In this model, these resources are shared among multiple users and organizations, granting them on-demand access and utilization. Public cloud services are overseen and maintained by third-party cloud service providers, who not only manage the infrastructure but also operate their own data centers. Next, a private cloud is a cloud model that dedicates all cloud resources to a single user or organization and is created, managed, and owned within on-premises data centers. Finally, hybrid clouds are a combination of the public and private models. They enable organizations to enjoy both cloud services and the control features of on-premises cloud models. Think of these three cloud models as different ways to heat a building. Public clouds are like an electricity company that delivers the power you use to generate heat. You can choose to turn it up when you're chilly or turn it off when it's warm outside. You only pay for the power used, and as a customer, you don't need to worry about the maintenance of the power lines and generators. Private clouds are like having your own solar panels to generate power and heat. You need to buy the panels, have a place to install them, and you're responsible for their proper care and maintenance. And hybrid clouds are like using the services of an electricity company, but also owning and using solar panels. This gives you more options over how heat is delivered when the temperatures drop. You can choose when the power company is right to use and when solar panels are the better option. Okay, now let's discuss the advantages and disadvantages of each model. With public clouds, you pick and choose the resources you need and pay only for what you use. Public clouds can easily scale up or down based on demand, and there are no maintenance worries because the cloud service provider handles all of that for you. Another key advantage is reliability. Public clouds have vast networks of servers and can quickly redirect resources in an emergency. Speed and ease of deployment are also benefits of a public cloud model. Adoption occurs faster and more simply because the cloud infrastructure is already in place. Lastly, public clouds offer new services and frequent updates that enable users to benefit from the latest innovations like artificial intelligence and machine learning, or AI and ML. Now, private clouds come with higher maintenance and management costs, but offer a few critical advantages. The first is that, as the name suggests, they offer private and secure networks if protected properly. Without proper security measures put in place, it can be vulnerable to hackers. Second, private clouds help with any required regulations and compliance because you control where your data is stored and where computing takes place. Private clouds also provide consistent performance because hardware isn't shared among other organizations. Going hybrid can be a bit tricky as blending public and private models adds complexity, but there are some key benefits. A hybrid cloud model allows you to add a public cloud provider to your existing on-premises infrastructure, which increases cloud computing power without adding data center expenses. A hybrid cloud model also gives you access to the latest innovations like AI and ML, which can really be business game changers. Because you choose where your applications sit and where computing happens, there are key security and compliance advantages. Likewise, hybrid computing occurs closer to the actual users, so it enables faster performance. There's also greater flexibility because you can choose whichever cloud environment is best for the specific task at hand. Whether your organization is best suited to a public, private, or hybrid cloud model, your guidance will help choose a great option. All three offer some really cool ways to advance any organization's computing power. Keeping track of business data used to be incredibly labor-intensive. From handwritten ledgers to complex filing systems to typing facts and figures into a spreadsheet, collecting, cleaning, organizing, and storing information was a huge and resource-heavy task. But cloud data analytics has automated and enhanced these processes, making data management much more efficient and less prone to human error. In this video, we'll dive into how the cloud enables data from a variety of sources to be smoothly integrated, creating a single source that users can access and analyze in real time. First, cloud data can be managed with data integration or data ingestion. Data integration combines data from different sources into a single usable data source. This integration can happen through the ETL process or extract, transform, and load, or the ELT process, extract, load, and transform. ETL and ELT are cloud-based approaches that use the power of cloud data warehouses like Google BigQuery to transform data. ETL transforms the data before it's loaded into the warehouse, and ELT transforms it after. But either way, it's ready for further processing or analysis. Data ingestion obtains, imports, and processes data for later use or storage. The information is obtained from various sources and processed through stream or batch ingestion. Stream ingestion involves real-time continuous processing of data as soon as it is collected from various sources. Batch ingestion processes data in predefined intervals or larger chunks. Those are just a few of the ways cloud data analytics has transformed how organizations access their data. There are also web interfaces, application programming interfaces, or APIs, SQL, other ingestion tools like PubSub, and business intelligence solutions like Looker and Jupyter Notebooks. All of these help users access data that's stored in the cloud anywhere, anytime. And while we're discussing data in the cloud data analytics also makes it possible to store different types of data like files, objects, or blocks. File data is information that's stored in a file on your computer or another storage device. Object data is a piece of information with a unique identifier which you can find no matter where it's stored. And block data is a piece of information that has been cut from a larger piece of information and given its own file path. So many data analysis activities have greatly benefited from cloud data analytics processes. Big data analysis, the ability for visualization of multiple data sources asynchronously, AI and ML, custom report analysis, data mining, data science, the list goes on and on. In today's world, innovation is the driving force for many companies, and there's no doubt that data fuels these innovations. It's really amazing how much cloud analytics has advanced the field of data analytics, making powerful analytical tools and processes available to organizations of all kinds. At the same time, it enhances the analytics process, making it easier, faster, and more cost-effective for users to discover valuable insights from data. Hello, Future Cloud Pro. Thanks for being with me for this rundown on the key features affecting cloud costs: resource provisioning, storage, and running queries. Let's start with an example. Say you're headed to the market, so you create a shopping list. You think about what you'll need in the coming week, then write down exactly those items. The list helps ensure you don't overspend on items you don't need or that might go bad later. Well, managing the costs of cloud data analytics is kind of like that. The key is to be a super savvy shopper, knowing exactly what resources you need and how much. This saves money and prevents waste. The first method cloud professionals use to achieve these goals is resource provisioning. This is the process of a user selecting appropriate software and hardware resources and the cloud service provider setting them up and managing them while in use. The resource provisioning process occurs through one of three delivery models: advanced provisioning, dynamic provisioning, and self-provisioning. Each delivery model is different based on the types of resources an organization buys, how and when it receives these resources, and how it pays for them. In advanced provisioning, the user signs a formal agreement with the cloud service provider and either pays a set price or is billed monthly. Then the provider gathers the agreed-upon resources and delivers them to the user. In dynamic provisioning, resources are adjusted based on the user's changing needs, and they're only charged for what they use. This means they can easily scale up or down based on usage demands. With self-provisioning, also known as cloud self-service, the user purchases resources from the cloud provider through a website or online portal, and then the resources are quickly made available for the user, usually within hours or even minutes. Although users only pay for the resources they use, how they choose to receive these resources affects how much they pay. Payment can be arranged with one of three rates: fixed, pay-as-you-go, or instant purchase. Now let's move to storage costs. Storage is ranked as one of the top 3 cloud expenses for many organizations, and the demand for more storage capacity only continues to grow. Storage costs vary based on data storage, data processing, and network use. As the term suggests, data storage is the amount of data kept in storage. In the cloud profession, we refer to these as buckets. Exactly how much an organization pays for the storage can actually change based on where those buckets are located in the world and the type or class of the data being stored. For example, cold line storage data is great for data you read or change once a quarter. But archive storage data keeps data that is only meant for backup or archiving purposes, and it's the cheapest form of data storage. Now, data processing is the step where raw data is cleaned, organized, and changed into a format for easy analysis. Data processing can significantly affect storage costs in several ways, like the more data you process, the more storage space you'll need, and faster data processing requires more advanced storage solutions. Finally, network use refers to the amount of data that is read or moved between storage buckets. Okay, let's dive into the costs associated with running queries on stored data. One interesting point to understand is that most cloud service providers charge for query processes based on the amount of data processed, not the amount returned after the query is run. So every time a cloud data analyst runs a query to retrieve, update, or analyze data, a bill is generated based on the total amount of data that query processes. With Google BigQuery, for example, there's a choice of 2 pricing models for running queries: on-demand pricing and capacity pricing. On-demand pricing is based on the amount of data in bytes that each query processes. The on-demand pricing model is ideal for users whose compute and storage needs fluctuate based on business priorities. And capacity pricing is based on the computing power used to run queries over time, measured in virtual central processing units, called slots. The capacity pricing model is ideal for users who want a more predictable, controllable cost for their queries. As a cloud data analytics professional, you can bring a ton of value to your employer by using this knowledge to get the best performance and value from cost-effective cloud resources and services. Best of all, you'll be helping them optimize resources, processes, and the bottom line. It wasn't too long ago that patient charts were kept on premises at a doctor's office. This created a limitation to information access. Important health information couldn't be easily shared with other medical offices or hospitals. A patient might not know if they were up to date on vaccinations or be able to access their medical history. Similarly, people working on a manufacturing shop floor constantly had to count inventory parts one by one, entering the totals into a physical spreadsheet. That's how they knew they had what they needed to get products manufactured for their customers. But today, cloud data analytics is revolutionizing healthcare and manufacturing. In this video, we'll focus on these industries and we'll also dive into the fields of education and transportation. You'll discover the cloud's far-reaching impact and learn how you, as a cloud professional, can help all kinds of businesses predict the next big trend, discover patterns that lead to innovation, and make quick decisions that improve operations, systems, and customer satisfaction. Some fascinating new personalized medicine and predictive analytics opportunities are significantly improving patient outcomes, helping people live healthier lives. Cloud data analytics in healthcare lets us ask big questions about many patients' data. We can learn how a medical product works over time and with different people, or see trends in how often certain medical products are prescribed. And this is just a snippet of the transformative advances that cloud data analytics have had within the healthcare industry. Now let's check out cloud data analytics in manufacturing. Today, the manufacturing industry faces challenges like unpredictable demand fluctuations and supply chain disruptions. The industry is also emerging innovative methods of operations and improving overall efficiency for manufacturers, clients, and customers. The capacity for manufacturing companies to quickly adapt and respond to these conditions is more critical than ever. Integrating cloud data analytics into manufacturing processes is becoming an essential part of the industry. The real-time analysis of massive amounts of data retrieved from manufacturing processes and client and customer interactions helps companies optimize their operations for reliability and efficiency. Analysis of cloud data also offers organizations the ability to build more targeted and innovative products. Cloud data analytics in manufacturing helps keep factory and warehouse operations running smoothly. For example, smart technologies identify issues or need for repairs and flag things that don't meet product standards. AI checks quality at every step of production to keep standards high. Cloud data analytics also improves the customer experience by making sure manufacturers produce exactly what their customers want. Plus, it makes the supply chain transparent. You know what's happening with your customers, partners, suppliers, and even their suppliers. Again, smart technologies can prevent and help track supply chain disruptions. And it helps create products based on customer-driven data, improving efficiency and increasing sales. Okay, let's review how cloud data analytics impacts the education field. Technological advancements, including cloud data analytics, enable educational institutions to better equip learners with the knowledge and practical skills necessary for career readiness and typical workplace scenarios. For example, consider a university that wants to optimize its course offerings based on student preferences and performance data. By leveraging cloud data analytics, the institution can analyze enrollment patterns, student feedback, and academic performance metrics. Cloud data analytics in education enables a more thorough evaluation of the validity and effectiveness of courses and course content. It also helps educators design learning experiences for each student based on prior interactions with content. Next up, an example from the transportation industry. Transportation companies typically cover large geographical areas and make frequent trips to and from major destinations. This not only requires a large number of vehicles, such as planes and ships, but also careful and strategic planning. By using real-time cloud data analysis for effective decision-making, more efficient routes can be designed that save time, money, and resources. The cloud also helps these businesses predict possible delays, optimize operations, increase reliability, and improve customer service. Cloud data analytics in transportation can improve transport vehicle maintenance. Just as in manufacturing, technologies installed in vehicles monitor their operational status and provide maintenance alerts. Smart technologies also enable AI and ML integration. AI and ML capabilities are used by transportation companies to analyze historical travel data and discover valuable insights that are then used to predict future travel trends. And finally, cloud data enables logistics planning. With cloud data analytics, transportation companies can make the most of the latest virtual modeling software to help plan intelligent logistics and efficient routes. Although we've only highlighted 4 industries in this video, cloud data analytics has had a profound impact on almost any field you can think of. And its impact will only continue to grow, which is why demand for cloud professionals is so high, no matter which industry you choose to pursue in your cloud career. Hi there! In this video, we're going to dive into cloud architecture. And to do that, we're heading to the shopping mall. Okay, so picture a huge shopping mall with all kinds of stores, each selling different products and services. Whatever you need, you'll likely find it. The best part? As a shopper, you have access to all of these cool things without having to worry about the building's utilities, maintenance, or security. The mall handles all of that. Well, cloud architecture is like a shopping mall. Thinking about this in business, an organization may need to store files. That's no problem. Need a lot of computing power? Easy as can be. Want to analyze data? Right this way. And behind-the-scenes activities are up to the cloud provider. The organization chooses the services they need, and the cloud provider puts the services to work. Cloud architecture is what builds the cloud. And how the various components and technologies are arranged is what lets organizations pool, share, and scale resources over a virtual network. The components that make up the structure include a front-end platform, a back-end platform, a cloud-based delivery model, and a network. Front-end platforms include the parts of the architecture that users interact with, the screen design, apps, and home or work internet networks. Front-end platforms allow users to connect and use cloud computing services. For example, say a user opens the web browser on their mobile phone and edits a Google Doc. In this case, the browser, phone, and Google Docs app are all front-end cloud architecture components. In contrast, back-end platforms are the components that make up the cloud itself, including computing resources, storage, security mechanisms, and management. A primary back-end component is the application. This behind-the-scenes software is accessed by a user from the front end, and then the back-end component completes the task. When you use an online shopping app, you may browse the products first, add them to your cart, and then make a purchase. All these actions are possible because the back-end application is at work behind the scenes to complete the shopping experience. Another key back-end component is service. You can think of service as the heart of a cloud architecture because it takes care of all the tasks happening in the computing system and manages the resources users access. The third primary back-end component is Runtime Cloud. Runtime Cloud provides a space for all cloud services to perform efficiently. It's similar to your laptop or phone's operating system and ensures cloud services run smoothly. Runtime Cloud technology creates monitors for all services, like applications, servers where data is stored, space for storing files, and network connections. Next, we have storage. This is where cloud service providers keep the data to run systems. Different cloud service providers offer flexible and scalable storage designed to hold and organize vast amounts of data in the cloud. Infrastructure is probably the most well-known component of cloud architecture. It's made up of important hardware that allows the cloud to work, and it keeps systems at their best, including the Central Processing Unit, or CPU, the Graphics Processing Unit, or GPU, and the network devices. The final primary backend component is security. Because more and more organizations are adopting cloud computing, it's essential to ensure that everything is kept safe. Planning and designing security for data and networks provides critical supervision of systems, stops data loss, and avoids downtime. Cloud architecture is the blueprint of how all these components can deliver a highly agile and scalable solution. Understanding cloud architecture is an important step toward becoming a skilled cloud professional, and you're well on your way. Hi, it's great to be with you learning about cost optimization in the cloud. Optimizing costs, in other words, saving money, is something that's important to all businesses, whether it's lowering the price of cloud computing or just planning and making smart decisions. As an everyday example, say you were heading out of town for a week. You wouldn't keep all your lights on, leave perishable food in the fridge, or schedule important deliveries. That would be a total waste of money. Cloud cost optimization is a lot like that. It involves planning and managing resources so you're not paying for what you don't need or spending more on services than necessary. In this video, we'll define cloud cost optimization as it relates to using and managing cloud resources, discuss the benefits of cloud optimization, and dive into some cloud cost optimization strategies. Let's get started. So first, what exactly is cloud cost optimization? Cloud cost optimization is the process of reducing cloud expenses by implementing cost reduction strategies. But cloud cost optimization does more than just save money for organizations. It also offers ways to enhance workload efficiency and ensures cloud resources are giving users maximum value. It does this in a few key ways. The first is cost visibility. This means the organization knows exactly what they spend their money on and how specific cloud services are billed. It's all about being able to justify why a certain amount of money was spent to achieve an operational goal. The next benefit is improved performance of applications. By optimizing cloud resources, organizations can guarantee that apps run smoothly, which improves the user experience while reducing cloud expenses. Another really critical advantage is cutting carbon emissions. Like most business activities, using the cloud affects the environment. So as a cloud specialist, you can play an important role in reducing your organization's carbon footprint by optimizing cloud resources. Okay, now that we've examined some cost optimization benefits, let's discuss some strategies that businesses can use to ensure they're getting the best return on their cloud investments. First, right-sizing. This is the process of adjusting computing resources like processing power and storage to fit the exact needs of an application or workload. This optimizes usage. Similarly, auto-scaling is a cloud service that monitors applications automatically scaling up or down according to the computing resources needed to meet user demand. Finally, reserved instances is a cloud payment model in which an organization purchases a specific amount of resources for a certain time and receives a discount in return for this commitment. Organizations can use cloud resources long-term when they do not expect to have to scale up or down during a specific time period. Then the organization can benefit from reserved instances. When implemented, these cost optimization strategies significantly reduce expenses, improve app efficiency, cut waste, increase environmental responsibility, and provide a better return on cloud investments. Plus, all of these advantages have the potential to create something any business will enjoy: cost savings. Now that's a great way to demonstrate the value of talented cloud data analytics professionals. You've learned so much already and are making great strides towards your future career. You've discovered the fascinating process of migrating to the cloud and how important it is to choose the right data system environment. You also learned about the cloud's impact on both the data analytics field and other industries. Then you reviewed costs and billing models, exploring cloud cost optimization and its many benefits. You also learned about the cost of storage, running queries, resource provisioning, and the different billing models. This know-how will help you guide any employer toward valuable savings. Lastly, you got an overview of cloud architecture and considered how it's a blueprint for everything that's possible in the incredible cloud. Catch you in the next section. Hi there. Welcome to the next section in your Intro to Cloud Computing in Data Analytics. These topics are all about the data lifecycle, from data entry to data destruction and everything in between. To start, we'll discuss the basics of data management and introduce safety and privacy considerations. Next, we'll explore the data lifecycle phases. You'll experience some really cool examples of data in action. Then we'll check out the data analyst role in the data lifecycle. You'll learn about many of the different data professionals you might meet in your career and how they all fit into a data lifecycle. Finally, we'll cover strategies for controlling data lifecycles, including automation, retention policies, and holds and versioning in data management. There's a lot coming up, and I'm thrilled to be here to guide you through the next exciting step in your cloud journey. Let's get started. Imagine that you have carefully organized a bookshelf, expecting it to stay as you arranged it. However, the next day, you find that someone has rearranged the books, maybe borrowed the one you were saving, or even replaced it with a different book. It can be frustrating and confusing when you leave something in one state, but soon find out that it's been changed or removed. This is especially true for data. For example, maybe a company collects data about its users. Some of it's sensitive and a lot of it only applies to certain departments. And what if every single employee has access to all of the company's data? This definitely causes all kinds of problems. Some employees might mistakenly alter the data or save multiple new versions. This makes it pretty easy for someone else to begin working with the wrong information. At the same time, other employees might inadvertently decide to delete some data when they're done with their own projects. That could be catastrophic. This business needs a data management plan. Data management is a process of establishing and communicating a clear plan for collecting, storing, and using data. A data management plan is created to ensure that procedures for each of these steps are understood by all employees. In some organizations, the data management plan may also be referred to as data governance. There are three main reasons why data management is so important. First, it ensures that collaboration is seamless. All users can access data using documented procedures, so the data stays within governance and compliance requirements. Second, data management supports a strong data security program. It helps set parameters to protect from data breaches or data loss. And third, a plan for data management helps with scalability by having a clear procedure in place. As a cloud data analytics professional, you might create data management plans, or you could work within one that's already been established. Either way, some key aspects to consider include access, data types, storage, and archives. Let's dive into each of those. First, access. A data management plan defines the roles of anyone who will access the data, including each user's level of access. This can also include the type of data they have access to. It may even be as granular as certain rows or columns. Along the same lines, the plan should also define the data types the organization is allowed to collect, like personally identifiable information, or PII. For example, maybe only the marketing department should have access to user emails to send notifications, or only analysts have access to user birth dates to segment reports by age brackets. Next, a data management plan should include the types of storage allowed. For example, BigQuery projects and Google Drive folders, and backup plans for outages. And finally, archives. Procedures for archiving or deleting data should be considered and follow business guidelines and any external regulations. It's also important to call out any exceptions to archive rules. For example, litigation data may be exempt from these procedures. Each of these elements of data management are crucial to protecting information and ensuring user privacy. While data management plans vary from organization to organization, they should begin by clearly defining the business objectives. These inform the rest of the plan. Objectives help define what type of data will be collected and which teams can access it. They determine how long data should be saved and how it will be used. And they help prioritize the entire team's goal to effectively share all relevant data management information. Now, there are some key policies to follow when generating a plan. First, a retention policy may be created for your organization as a whole or for each individual project. Retention policies outline how data is archived and deleted. They may be driven by compliance regulations, legal requirements, and General Data Protection Regulation, or GDPR guidelines. Next, a data collection policy is an outline that creates rules around how data is collected and what resources may be used in the process. The archival policy outlines where and how data is stored once an analysis project is complete. And lastly, a deletion policy is an outline of when and how data is permanently destroyed. Of course, if employees don't know about the data management plan and how to access it, that's just as bad as not having one at all. A business needs to clearly communicate the plan long before there's any data to manage. And a business should be sure to educate all users about the plan and the specific permissions and procedures. That's all for now. Stay curious. Hope to continue exploring the cloud with you again soon. Anyone who works with data inherits the responsibility to protect private or personal data, especially personally identifiable information, or PII. This is all about data privacy, which we'll explore in this video. PII and other privacy standards have legal implications, so it's important to call out. Our discussion in this course should not be considered legal advice. So what is data privacy? Data privacy is preserving a data subject's information anytime a data transaction occurs. Any organization that collects data knows that earning users' trust is an essential part of working with their data. As a cloud data professional, one of your primary goals will be to use data honestly, transparently, and fairly. PII is data that is unique to an individual and therefore can be used to distinguish one person from another. A user's email address, mailing address, phone number, precise location, birthday, and full name are all examples of PII and must be safeguarded. Along those same lines, personal health data is PHI, or Protected Health Information. PHI is health data that can identify an individual, like information about patient demographics, mental or physical health diagnoses or treatments, and payment records related to health care. It's also important to know about the General Data Protection Regulations, or GDPR. This is privacy legislation for organizations in Europe. It regulates how they can collect, use, and store personal data. It also has requirements around reporting to increase accountability and fines for those that fail to comply. A pro tip is that even if your employer isn't located in Europe, the rules may apply to any business that collects data from European citizens. Whether complying with GDPR or trying to follow best practices in PII and PHI data security, there are several ways to help your organization avoid fraud and identity theft. One strategy is identity access management. This is a process that gives each employee who interacts with the company's system access to specifically defined programs and datasets. As a data professional, you may be required to only access the bare minimum of data needed to do your job. This is usually referred to as NTK, or need to know. Accessing data just out of curiosity or for a non-valid business reason may be prohibited. Another proven strategy is having internal data stewards. This privacy team is in charge of keeping data access in check. Frequent audits within your organization are an additional security measure. An audit is a formal examination of how users are accessing data in order to ensure safe and appropriate access while identifying and solving any data concerns. Another way to protect data is through the use of security keys for accessing software, accounts, and datasets. This is an authentication method that uses a physical digital signature, or key, to verify a user's identity before they access these resources. Finally, encryption is another proven method. This is just the process of encoding information. Encryption protects data by scrambling it into a unique secret code that can only be unlocked with a digital key. Data may be encrypted on an individual machine and unencrypted when you work with it, or it may be encrypted when it's shared or sent from one machine to another. Having access to data, especially data about people, is a big responsibility. So it's really important for cloud data professionals to know the best practices of data privacy and safety. Hello, and welcome to this exploration of the data lifecycle. Understanding how data moves through its entire life will help you, as a cloud professional, stay organized and keep your work as efficient as possible. Let's begin with an example. Maybe your analytics team is assigned a new project. It can be tempting for everyone to want to get right to work. But organizing project phases and creating a plan before you begin helps you get much better results. Likewise, knowing who's responsible for which task creates a streamlined project. Any data project will benefit from understanding the data lifecycle. This is the sequence of stages that data experiences, which include plan, capture, manage, analyze, archive, and destroy. Let's dive into each one a bit further. As its name suggests, the plan stage begins before you start any analysis. Usually, it involves answering a particular business question or meeting an objective. It's important that all project outcomes are focused on this key point. A typical business question is, how can we increase user engagement with our product? And an objective might be, we will reduce our plastic use by 50% by using only recycled materials in our package design. Next, team members decide what data types to collect. which data management processes to follow, and who is responsible for each stage. During the planning stage, the ideal project outcomes and how to measure success are defined. Next is the capture stage, when data is collected from different sources. This may include outside resources like publicly available datasets, or it may be data that's generated from within the organization. This stage is also when gaps are identified in an organization's current data collection and are improved through iteration. For example, maybe business leaders want to know how many users have downloaded their app. But when reviewing the existing data collection plan, an analyst notes that they can only capture data about how many users have created an account, but not always how many app downloads have occurred. The analyst may need to work with the engineering team to figure out if it's possible to get this data logged. Then it's time to process the captured data. This is important because raw data directly from the source is usually not in a usable format for analytics. So a data engineer needs to clean the data and transform the data. They may also compress the data and encrypt the data for security purposes. Now we've come to the manage stage. The goal of this stage is to ensure proper data maintenance. This includes safe and secure data storage. Keep in mind that the manage stage is an ongoing process throughout the project. In other words, the raw data collected in the capture stage, the transformed data from the process stage, and any business logic that analysts establish all must be managed securely on an ongoing basis. Next is the analyze stage. This is when analysts use data to answer the business question or help meet the business objective generated during planning. At this point, team members review compiled data to find trends, create visualizations, and suggest business recommendations based on data insights. Then, in the archive stage, the data engineer may store data for later use if needed. Finally, when data is no longer useful to the organization, it's destroyed. Although it might seem like a waste to destroy data, this is an important stage to ensure that sensitive data cannot be stolen, to support privacy protection guidelines, and meet other compliance requirements and regulations. For example, this may keep data practices in compliance with GDPR, the General Data Protection Regulation in the European Union. This regulation covers the data that an organization is allowed to hold. Okay, one final point about the data lifecycle. None of these stages work without data team members. You just learned that data analysts primarily work during the analysis stage. They collaborate with data architects who design the plan for managing the data. Data engineers build the infrastructure for the data, and data scientists use the data to create models to understand the data. With these talented people in place, your organization will have a point person for each stage of the data lifecycle, and everyone will have a clear idea of where projects and data are headed. Hello, and welcome to this video about effective data reporting. Being able to share data insights with others is an essential part of data analytics. After all, an amazing insight to the business question is only valuable when the information is shared. As a cloud data analyst, you'll likely create a variety of reports to share your analysis and provide summaries for decision makers. The data lifecycle, plan, capture, manage, analyze, archive, and destroy will help you create engaging, data-driven communications. Now, before we go further, it's important to note that the data lifecycle and the data analysis process are two distinct concepts. When we think about the data lifecycle, this is how the data itself moves and changes throughout its existence. When we think about the data analysis process, this relates to how data analysts interact with the data. Now that we've covered that, let's dive into the data lifecycle. Let's shift to an on-the-job example with the data analyst named Kayla. A stakeholder at Kayla's company requests a report of all payments the company received in the last month. They would like to analyze several invoices to ensure that they're not missing any payments. The stakeholder also wants to see the percentage of payments that were made on time and the payment methods. To generate this report, Kayla will motion through the entire data lifecycle. The first step is the plan stage. So, Kayla will review the business questions and objectives. Then she will determine what fields need to appear on the report. Kayla considers questions like, what filters are needed to extract or separate the data? And how far back in time should the data go? Now she moves on to the capture stage. Here, Kayla will implement the plan she's created and assess the metrics she needs to capture. Then, Kayla will confirm the data is available and then gather the data. Data can come from a variety of sources. In the scenario of the payments report, Kayla will need user information and payment details. Sometimes the data you need doesn't exist. If that's the case, you may need to work with the product or engineering team to figure out how to fill in the gaps. You'll also want to establish a reasonable timeline for the data export. Let's get back to Kayla's process. The manage stage is all about data management. In this stage, Kayla considers how to store the data and prioritize security. Kayla will also determine whether she's working with any PII or personally identifiable information. When sensitive data is involved, it's critical to take steps to protect people's privacy. The report Kayla is generating will likely include user credit card numbers, addresses, and phone numbers. If she determines this information to be necessary for her project, then she will ensure it's secure. Otherwise, she will omit the PII at the start and simplify her data security needs. Kayla can also ensure that the data is accessed on a need-to-know basis so that only people who need the data can access it. In this phase, Kayla can also perform quality checks to confirm no required values are null or missing. In this payments report project, let's say she has multiple physical stores collecting payments in addition to an online website. So, it's important to check that the same fields are using the same kind of data so everything combines seamlessly during table joins. For example, the field account number will need to match to the correct user account, and both need to match in field types, like string values. For example, CUST12345. Next, it's time to analyze the data. In this stage, Kayla uses the data to solve problems and support business goals. She can do this through the collection, transformation, and organization of data in order to draw conclusions, make predictions, and drive informed decision-making. One of the most exciting parts of the analyze stage is sharing reports of your insights. Now, Kayla will create visualizations to help others understand the insights. She will also go back to the security protocol to ensure that she's not sharing any PII with people who should not have access. Next, in the archive stage, Kayla will determine what needs to be saved. She may need to save data to share it with additional stakeholders later on, or she might save it to compare with other reports. Finally, once Kayla determines she doesn't need the data anymore, she moves on into the destroy phase. Destroying data completes this cycle. Congratulations! You've just experienced the whole data lifecycle. You've met your business objectives and kept all of your company's data safe and sound. Have you ever played on a sports team or experienced a live sporting event? For example, take the sport of basketball. In basketball, there are 2 teams, each with 5 players. The players on each team work together, trying to score points by throwing a ball through a net. They're all basketball players, but each has an individual position and distinct role to play. The same is true for a data team. Everyone's on the team and each one plays a distinct role when completing a project. In this video, you'll discover the interesting jobs of people who work with data. Based on what you learn, you may even decide to pursue one of these new career paths instead of cloud data analytics. That's great. Whatever direction you end up taking, knowing all about these different jobs will be invaluable. First up, data analysts. These are truly dynamic people with a wide skill set. They know how to seamlessly switch between roles on a data team, acting as a data detective, a translator, even an artist. Data analysts blend the science of analytics with the art of storytelling. They work directly with the data. Data analysts perform data analysis workflows, including importing, manipulating, calculating, and reporting on business data. When reporting, they visualize and communicate results to stakeholders, which includes creating presentations and dashboards for sharing data. Data analysts also perform statistical analyses. In working through a data cycle, Some of the tasks they may complete include analyzing and reviewing databases, using scripting languages like Python or SQL to query data, creating visualizations in dashboards and programs, maybe Tableau or Looker, and presenting findings to stakeholders. Data analysts also play a role in the management and sharing of data under the direction of a data architect or engineer. They work with data engineers to clean data and ensure that it's focused on answering the business questions generated during the planning stages. If all of this sounds exciting to you, then put on your detective's hat, start translating information, and choose your artist's paint palette. This just might be the career path for you. Okay, let's meet the data engineer next. A data engineer is a professional who transforms data into a useful format for analysis and gives it a reliable infrastructure. They design, create, manage, migrate, and troubleshoot databases used by applications to store and retrieve data. Much of their work involves developing the structure the team uses to collect, store, and analyze data. The data engineer is also the one who builds the data pipelines. Pipelines are a series of processes that transport data from different sources to a destination for storage and analysis. Engineers also test and maintain pipelines once they have been built. Data engineers are also tasked with the important job of ensuring that data is accessible to all other members of the team as permitted by their company's access policies. Like all members of a data team, engineers must be effective communicators. They collaborate with team members and other stakeholders to ensure company objectives are met. It's an exciting career path that makes a powerful impact on everyone in the organization. Next, we'll get to know data scientists. These data professionals analyze data, do statistical analysis, and usually build and train machine learning models. The data scientist is someone who works primarily in data research, identifying business questions, collecting data from multiple sources, organizing it, and finding answers. Now let's consider how a data scientist and a data engineer are alike and how they differ. Like a data engineer, a data scientist uses coding and scripting skills to clean and summarize data. They differ in that an engineer typically builds a data pipeline from start to finish, and a data scientist uses the data from the pipeline to draw conclusions. Data scientists create data analysis workflows. Along with data analysts and engineers, data scientists import data from various sources, clean it, and use data to perform calculations. They also understand the business applications of data and focus on statistics, machine learning, and modeling. The role of data scientist is another wonderful option for your own data career. All right, last but definitely not least, we have data architects. These professionals collaborate with data analysts, data scientists, and data engineers to design the infrastructure of the database. The data architect helps their team to plan the overall data lifecycle of a solution. The data architect will usually produce a data or solution architecture diagram to support the management of a data lifecycle in collaboration with the analyst and scientist. Then they relay it to the data engineer to build the database. Every business is different, but those are some of the most common data team roles. However you make your way into the field, keeping your career options open will allow you to grow and make your own valuable contributions.
Hi, I'm Safa. I'm a product analyst at Alphabet. Doing work that feels meaningful is what excites me the most about my job. One thing that my parents did give me, their intentions in giving me a computer was for me to do well in my studies so that I can research things, do my homework better. But what they didn't realize was that the computer was a vortex into online connections. And I think just by virtue of spending so much time on the computer, I found myself really good at tech skills. When it came time to going to college and deciding, oh shoot, what do I want to study now? I knew I wanted to do something within tech. I think cloud is an exciting career space because if we're talking especially around data analytics and we're thinking about where we can host data on the cloud, I mean, there's going to be trillions of records of data on the cloud, and we're going to need folks who have that analytics or data knack to be able to know how to report on it, to be able to know how to engineer ways for that data to live on the cloud. And so I think if someone is interested in being a part of the cloud, especially as a data analyst, I feel like there would be a lot of opportunities to mend those two ways together. Cloud makes it possible for a lot of people to do their job well, so it is an exciting place to be at. In my job, especially as a data analyst, it's really important to have a reliable and robust way for having our data organized, for having our data able to be accessed, to have an intuitive way to query and report on that information. The cloud makes that possible for us because we're able to use tools like BigQuery that allows me to query that data and find where those tables are accessed, and it creates like a platform for us to have our data warehouse on it, and it's fast and it makes it a lot easier. And I've been in jobs before where we didn't have something like that. I think a lot of folks, especially at Google, because everyone is so smart and just so hardworking, I think we all probably are going through something or another and doubting ourselves and feeling like I'm not as smart as the person next to me, I'm not as hardworking as the person next to me. When I had first started at Google, I, like many other folks, I had so much imposter syndrome. I thought they made a mistake hiring me because I was not the traditional person that I had attributed as someone who gets hired into Google, which is the Harvard graduate, the person who got amazing grades, who was like valedictorian. And, here I was, high school dropout. If you want a product to reach multiple people, as Google products do, then you need diverse people working on it. So yeah, I think it's super important for folks of non-traditional backgrounds to have their voices be heard and their opinions to be inputted and woven into products because it makes for a better product. A piece of advice that I would share for folks doing the certificate when moments of self-doubt come up is reminding yourself that you are incredible. Trusting that gut instinct that led you to this certificate in the first place is important to hear and honor. I feel like for me, coming back to that place of like, there's a reason why I'm doing this, and I know I like this stuff, and I know myself well enough to know that this is just a momentary wave, and if I ride this wave through, I'll go back to that same place of feeling excited about this topic again.
Business demands are always changing. And as a data professional, being able to adapt and respond is invaluable. Sometimes data professionals will wish they can multitask or be in two places at once. This actually applies to many jobs. For example, consider a farmer. When the farm is small, a farmer might water crops by herself every morning. As the farm grows, the farmer no longer has time to water the crops as she once did. She wants to figure out how to water a huge field's worth of crops efficiently. How can she possibly achieve this? She invests in a timing system that waters her crops at the same time every day for a preset interval. This means that all of her crops are watered simultaneously, and she harvests a record number of crops. In data management, you'll sometimes encounter similar situations. You might need to ingest data on a set schedule, or you may need to automatically cap the amount of data ingested. You might be asked to be more efficient with a set amount of resources. There are many ways you could be asked to scale or streamline data processing. In this video, we'll explore how data management systems can be implemented and automated to respond to ever-changing business needs. Automation is the use of software, scripting, or machine learning to perform data analysis processes without human work. For example, consider a business that has over 200 employees to pay twice per month. Someone could verify the hours worked for all employees. Then another person could calculate the amount of each paycheck, and a third person could write and sign the checks. Most businesses don't operate this way. Instead, the payroll process is usually automated. Verification of hours worked and calculation of pay is all done automatically by a computer program. In some cases, payment is automatically transferred to each employee's bank account by an automated process. Automation saves time and resources and ensures that people are paid on time. One of the key benefits of automation is that it reduces mistakes during data collection through automatic checks for errors or incomplete data. This helps ensure your dataset is complete and accurate. In situations where compliance is key, automation ensures uniformity and accuracy important for compliance. Automation scales up workloads, ingesting or processing more data at once without losing key information. Finally, automation allows for efficiency and process improvement, which can help to preserve resources, both human and technical, and controls costs. Having a clear process for moving data through a cycle makes it easier to control your outcomes. With automation added at key areas, you'll be able to move data through its lifecycle quickly and efficiently. Now that you've automated repetitive tasks, this frees up your time to focus on the meaningful work of data analysis. Have you ever cleaned out your closet and donated some clothes to a charity? Or maybe you've cleared out old pictures from your smartphone so your phone is faster and more efficient. Now, what happens if you donate a sweater you actually meant to keep, or deleted a photo that you really wish you still had? Whatever type of cleaning you're doing, it's important to have a plan in place so you don't accidentally throw away something you need. A clear process for cleaning or for deleting items makes it easier to keep track of everything. In your role as a data analyst, you'll likely encounter something called a data retention policy at your organization. This is a key part of data management, which deals with how and when data is saved or deleted. Data retention is the collection, storage, and management of data. Every organization that collects data should have a policy for its retention. These retention policies may consider internal needs, industry regulations, and laws that apply to the particular business. A data retention policy should clearly define the scope of the policy and the reason for saving information. It also defines whose data may be collected, both internally and externally. And, as applicable, the policy may list any laws and regulations the organization follows. The policy provides a detailed description of the organization's data retention process. For example, a schedule for saving and deleting data, rules for keeping data safe, and processes for destroying data. It also includes guidelines for data breaches. Other guidelines that may be a part of a data retention policy include the format of the data, whether the organization archives or destroys data, and who has the authority to make decisions about deletion. Now that you have an idea of what goes into the data retention policy, let's review some of the regulations that may affect your data, depending on the industry you work in. A business may need to adhere to the following regulations or standards. It's important to call out, our discussion in this course should not be considered legal advice. If it's a publicly traded company in the United States, it must adhere to the Sarbanes-Oxley Act for Data Retention. Sarbanes-Oxley requires organizations to maintain internal control systems that protect financial data of consumers. A business that accepts credit card payments must have policies that follow the Payment Card Industry Data Security Standard, PCI-DSS. This standard requires organizations to build secure networks, protect cardholder data, and implement strong access control measures. A business must also regularly monitor and test all of these elements. Certain healthcare organizations in the United States are subject to the Health Insurance and Portability and Accountability Act, HIPAA, or HIPAA. HIPAA establishes requirements to protect an individual's identifiable health information. And any organization that processes personal data of European Union citizens, even if the organization is based outside of the European Union, must follow the General Data Protection Regulation, or GDPR. GDPR requires that reasons for personal data collection must be transparent, and a business may only use data for the stated collection purpose. GDPR also provides European Union citizens with certain rights and requires that businesses securely store personal data. When using a cloud service like Google Cloud, a data professional will usually activate a bucket lock feature. A data professional can use this as a tool to create a data retention policy for each storage bucket and define how long it will be retained. Google Cloud's bucket lock also provides access to a detailed audit log, which gives users a clear picture of data requests and responses. This helps a business maintain compliance with policies about who accesses data and when. Finally, object lifecycle management is an automated way a data professional can manage a data retention policy. In the cloud, an object is data stored in a cloud object storage service. The cloud service provider stores the data in large chunks with associated metadata. This management process enables a data professional to create parameters for object storage, to delete objects or data, or move it into different buckets. With predefined parameters, automation makes it easy for the business to keep track of important information. You can use the strategies in this video to make your data more organized and secure. You'll keep what you need for as long as you need it and get rid of what you don't to keep processes moving efficiently for speedy data insights. Have you ever worked on a document and saved multiple versions of it along the way? It can be really difficult to find the most up-to-date version. It's also sometimes challenging to keep track of a document while multiple people are working on it at the same time. And worst case scenario, someone might delete the doc altogether, thinking it's no longer useful. In this video, we'll discuss version control and holds as effective ways to ensure a document's current version is the most accurate for all document editors. In the data analytics field, data professionals use versioning and holds to keep data current and make sure everyone has access to the accurate version. Let's start with versioning. Versioning is the process of creating a unique way of referring to data. This may be through an identification number, a query, or date and time identification. The main goal is to label a file or dataset with the date and time that it was created. This means that even if you have multiple versions of the same data, you can always refer to the date and time to ensure you're working with the most recent version. This is especially important if you're on a team where multiple people have access to the same files and may be creating versions. The process of versioning can also include saving a dataset with a new name or saving data in a new file path. With clear directions about how and where to save files, you can track current versions with all of your teammates. There are several benefits of versioning to help ensure a data professional can perform accurate and reliable tests on the data. Along with making sure you have the latest version of data, versioning can also support quality control. Sometimes there may be an editing error or an error in data import. Being able to revert to a previous version allows you to return to the most recent accurate dataset, and it's valuable when addressing compliance concerns. You can version data that lives in databases or warehouses and cycle it out by version. Plus, sometimes when you find an error in code, you can go back to the original code to find where edits are incorrect. Okay, now let's move on to holds. A hold is a policy placed on a dataset that prevents its deletion or prevents deletion capabilities for certain accounts. Sometimes a dataset will have an organization-wide hold, meaning no one can delete it. There are several benefits of holds. Most importantly, they prevent accidental deletion and preserve data indefinitely, which means someone can't remove data that may be needed in the future. Holds policies will allow the business to determine and define each user's responsibility for datasets. For example, some users may have access to view and edit data, but are prevented from deleting it. A business may put both versioning and hold policies in place if there are security concerns about sensitive information. A business may also create policies to help manage storage costs. Ultimately, both versioning and holds support increased collaboration, accuracy, and better business results. Implementing these policies is just one way that data professionals help their organizations achieve data excellence. Nice job! You've made it to the end of this section. Before moving on, let's review what you've learned. You explored data management when working on a data project. You also found out about data teams and data cycles and how they work together. Now let's review some specific key points. You learned about the importance of data security and safety and retention and deletion policies. Then you explored the stages of the data lifecycle, and you considered the roles in the data lifecycle you might play, plus where your team members make their own contributions. You then went on to identify how automating the data lifecycle can resolve issues and boost efficiency. Finally, you identified strategies for safeguarding and controlling data, including retention policies, versioning, and holds. Congratulations on all of your progress so far. Hi there. Welcome to the next stage of your cloud data analytics journey. In this section, you're going to dive deeper into data analyst roles and responsibilities, cloud data tools, and data identity and access management. You'll first check out the unique ways the data analyst role operates in cloud data analytics. Then, you'll learn more about other key team members who interact with data. This will help you collaborate like a pro. Next, you'll explore Google Cloud's data and analytics portfolio. You'll get a high-level introduction to the tools: BigQuery, Looker, DataProc, and Dataflow. Your final section will focus on data access management. You'll understand why this is an important part of the data analyst role. You'll also learn about identity access management. We're going to cover a lot in this section, and it will be a great glimpse into the day-to-day activities of your future role in the cloud. Let's do it. Wherever your data journey may take you, the cloud is going to have a big impact on your data career. To make the most of all the cloud has to offer, you'll need some specialized knowledge about many of the unique aspects of data analysis in the cloud. And that's what we're going to explore in this video. First, let's understand cloud data analytics. Cloud data analytics is the process of analyzing and extracting meaningful insights from large volumes of data using cloud-based services and solutions. It enables data professionals to analyze data and use services and systems all hosted on the cloud. Cloud data analytics allows analysts to access large amounts of data from multiple sources without having to worry about setting up the infrastructure and security for each data set. Even for organizations that also have data on premises on physical servers, with cloud data analytics, a major portion of their data analytics is hosted in the cloud. This includes the data itself and the systems used to manipulate and analyze it. Let's check out some of the key advantages of working with data in the cloud. One big benefit is having quick and easy access to real-time data from different sources. Plus, analyzing large data sets is simplified because computing and processing power don't rely on local machines. Plus, data professionals can aggregate and analyze data right in the cloud. This is especially valuable as cloud data analytics continues to have a huge impact on website data, sales data, financial data, and performance data roles. For example, if a web server is hosted in the cloud, much of the data will be generated right there. So it makes sense that aggregation and analysis also happen in the cloud. Here are some specific ways data analytics works in the cloud: sentiment analysis and customer segmentation. On a sentiment analysis project, you can monitor the feelings of customers, employees, and competitors on social media. Using cloud analytics, you can bring in data from all major social media platforms and create summaries of themes in feedback. When working with customers, you can use cloud analytics for customer segmentation to group customers by their behaviors, needs, and preferences. With cloud databases and tools, you can automatically ingest large amounts of data and train your system to generate themes and summaries. Much of this is made possible by a cloud-based data pipeline. Through that pipeline, information moves seamlessly from creating data to archiving data. Pro tip: in a professional setting, some data analysts may never have to access data based on physical or on-premises hardware at all. In your career, you'll probably build SQL data pipelines in a variety of cloud-based tools, like BigQuery. You'll create visualizations in Tableau or Looker and maybe use predictive analytics from the latest artificial intelligence offerings. You might even find yourself creating exciting machine learning models. Of course, you'll perform the typical analytics tasks of data ingestion, cleaning, and transformation. A benefit to hosting versus on-premises is that with hosting, you'll have cloud tools and platforms to help you with those tasks. Whether your future role lives on-premises or in the cloud, you now know how the cloud affects many facets of the data analyst's daily work. This know-how will help you maximize the cloud's amazing tools and solutions. As the cloud continues becoming a more prominent reach in the data world, all kinds of exciting new data tools will arise. As a data professional, it's important to know that cloud data tools will usually be specific to each stage of the data lifecycle, and there will probably be a lot of choices for each stage. So, how do you choose the right solution for a particular task? In this video, we'll introduce you to some of the tools offered by Google and explore how they can support many types of projects and initiatives. First is BigQuery, a serverless data warehouse. This tool is pretty popular in the data world because it works across many major cloud platforms. With BigQuery, you use SQL to query and organize data. There are also some really cool machine learning and artificial intelligence tools integrated within the platform. And BigQuery includes built-in business intelligence engines to create interactive and responsive data insights. As a data analyst, you may use BigQuery to process seemingly unlimited amounts of data, think terabytes and even more terabytes, without having to manage the database. Another solution that may become part of your toolkit is Looker. Looker organizes business data and builds workflows and applications based on data insights, but it's primarily a data visualization and reporting tool. As a data analyst, you might use Looker to integrate various file types like CSV, JSON, and Excel into a single application. You may also use it to publish data in a variety of dashboards. Next is Dataproc. This service is fully managed and allows you to run Apache Hadoop, Apache Spark, and Apache Flink, along with many other open source tools and frameworks. Dataproc can modernize data lakes and perform ETL functions or extract, transform, and load for massive amounts of data. As a data professional, you might use Dataproc to process large data workloads and place them in clusters that allow you to access your data quickly. Then there's Dataflow, which gives you the ability to stream and batch process data in a serverless application. Data professionals may use Dataflow to develop data processing pipelines. It can assist with reading the data from its original source, transforming it, and writing it back to your database. You may also work with Cloud Data Fusion, another fully managed service that allows you to integrate multiple datasets of any size. As a cloud data analyst, you might use Cloud Data Fusion because it allows you to use a graphical user interface instead of code to manage your data pipelines. Dataplex also allows you to work with multiple data sources. It creates a central hub for managing and monitoring data to work across various data lakes, data warehouses, and data marts. As a data analyst, you may access Dataplex with BigQuery. This will allow you to access data from a variety of databases and platforms with a single interface. Finally, BigLake is a storage engine that you can use to unify data warehouses and lakes with BigQuery and open source frameworks. It also provides options for access control and multi-cloud storage. These are just some of the standard tools you might encounter as a data analyst, and there are even more on the horizon. Hello, data enthusiast. I'm so happy you've joined me for this investigation into data access controls and best practices of data management. As you're about to discover, a major part of data management is ensuring that data is secure. And security in this context is about where the data is stored and who has access. Let's begin with an example. Picture an office manager with a security device at their office entryway. They need to provide an up-to-date access code to their staff and trusted vendors. In these circumstances, the office manager can give other people the access code to allow them in. In other words, sharing this code means they can give access to only the people they trust and keep out those who shouldn't enter. Chances are you use unique identifiers like this access code all the time. Other types of unique identifiers include the code to access a phone or a computer. Data access management works in a similar way. As a data professional, you give specific people access to your data and your data processes and keep out those who shouldn't have access. Okay, first, a quick definition. Data access management is the process of implementing features including password protection, user permissions, and encryption to protect data and related processes. In the context of the cloud, it includes the creation of individual user roles or user groups, and the access for each role or group is predefined by an administrator. The act of assigning this access is called Identity Access Management, or IAM. IAM is the process of assigning certain individual roles or groups with access to particular resources. And some key resources may include software hosted in the cloud, datasets, databases, or entire data warehouses. The level of access is determined by the role of the user. There are three main components of identity access management: Principal, role, and policy. First, principal is the account or accounts that can access a resource. You can think of this as the account attached to each username. It's important that each account has a unique identifier. The second aspect of identity access management is role. This is the collection of permissions that list the elements that an account has access to. Each principal may have a different role. And finally, policy is the collection of roles that are attached to a principal. Let's explore how this might work in an organization. As a data analyst administrator, you're setting up a security group for the entire data team in the finance organization. The principal is a group that contains all the individual usernames for those on the data team. The roles in this group include both data writer and data reader. Both roles are attached to the principal. The policy is both data writer and data reader attached to the principal's username. Now, universal access, access by role, and access by environment are the primary access types you'll encounter. Here's how they work. Universal access, as the name suggests, is access that everyone needs. This may be universal access to an entire project or to one portion. Next, access by roles is access for each individual role assigned to a project. Creating profiles by roles helps determine what access is needed for the tasks each role will perform. Finally, access by environment is determined by user location. So, a remote user may have different access than someone who's on site. There are some best practices to help ensure data is accessed according to assigned permissions. First, be sure to audit data access and monitor user tasks. Second, put additional permissions on remote access. Also, verify and stop unusual activities. And finally, add two-factor authentication or strong passwords to accounts to ensure security. It's also a good idea to regularly check access roles. Users may not need as much access as originally provided. Alternatively, a user may need increased permissions to complete a project. And it's always possible that users change departments and take on new roles and need an update to their permissions. Along the way, it's very important to document user access so you have a record of who has access and why. This also helps audits go smoothly and is critical for compliance documentation. Consider sharing this information in a team playbook so access issues don't become blockers to completing work. With effective access policies in place, you'll know you're helping your employer keep its data safe and sound. Welcome, Future Data Pro. Thanks for joining me for this investigation into business data requests. The business data request is the kickoff to help launch a successful project. It's where all the fun starts. A business data request is any business question that can be answered with data, whether the request involves data that already exists or new data. As a data analyst, you'll typically receive this request through a ticketing system. This is a tool for recording requests and assigning them to the appropriate team member. Data requests can be simple or complex. Some can be responded to by a single data analyst. Others will require a team of data analysts to work together to generate a large report. Typically, data requests will vary from organization to organization, but data requests will have some similar elements. First, requests can be internal, from employees within the organization, or external, from outside. External requests may come from government or regulatory agencies, vendors, users, or clients. Types of requests might include answers to a data-related question, or the creation of a data report, an extract, or a dashboard. And requests usually include information or structure specifics. Here's a case to consider. Drew, a data analyst, works for a company that runs clinical trials for a healthcare product. Stakeholders want to know how long participants spend filling out surveys during the trial. So Drew receives a business data request asking for a report about survey timing. This is an internal request for a data report. Drew can also potentially add the report information to a dashboard. As Drew begins to work on this request, there are several things he keeps in mind. First, the overarching goal. In this case, the goal is to find out how much time participants are spending on surveys. And it's also a great practice to go beyond this and try to understand why the stakeholders need the data. An example question Drew might ask about the goal is, do the stakeholders need to correlate the length of time taken with the quality of the response? Then, Drew will determine what's being measured. In this case, it's pretty straightforward, the length of time participants take to finish a survey. Next, Drew figures out what data is needed and how much. Does he consider all survey response times, or only the surveys that launched in the last year? In this case, he determines he wants all surveys, but segmented by survey name. Drew reviews the survey completions to identify any errors or outliers in the data. For example, if the average survey completion time was 10 minutes and a participant took 24 hours, is that a bug or did they actually take that long? Finally, Drew searches for trends to identify within the survey name segment. For example, does one particular survey take longer than the rest? Next, he gathers the data and creates a summary report of all of the information. This enables Drew to find connections and draw conclusions about how long participants spent filling out surveys during the trial engagement. This is just one example of a data request, and you're sure to come across lots more throughout your data career. But no matter what question you're trying to answer, working through these steps will help ensure that you gather the right data and use it to come up with a brilliant solution. Hello, data detective. Always being curious, enjoying investigation, and committing to tracking down necessary information are all big parts of the data analysis process. Yet sometimes that information just isn't as useful as we'd hope. In this video, you'll gain some great strategies for figuring out how to fix this problem. Maybe, as a data analyst, you're asked to respond to a business data request. This is a business question that you can answer with data. Your first step is to assess the request to make sure you understand what's involved and the goal or conclusion desired. Let's take up this case study. The request involves a supply chain organization that wants to determine if supply partners have a successful customer experience when purchasing inventory from their online store. Now, there are a few ways to confirm whether you have the data you need to respond to this request. You could use analytics software to check the structure of the database. Then, determine if it is possible to learn when supply partners began searching for a specific product compared to when they clicked the purchase button. You might also track timestamps on their visits to your website. This can help confirm that partners are able to efficiently find and buy what they need. And it lets you know that they're actively engaging with your website. Next, you move on to data cleaning, sometimes called data wrangling. In this phase, you correct or eliminate any inaccurate or repeat records from the dataset. For example, maybe a supply partner omits important details from an order, then creates the same order again to correct their mistake. You'd want to remove the duplicate. Also, during this phase, you have the opportunity to learn more about your supply partner and define specific segments. And then break down the dataset into smaller sections. Now it's time to check for any outliers or deviations in the dataset. If a partner mistakenly enters an order for 1,000 products, but they really only need 10, you'd want to address that outlier. Here, you also integrate multiple data sources, or use data from multiple methods or sources to ensure information is accurate. In this example, you'd use data from your website, your customer management system, and your purchase orders. If available, you could also check summary statistics. You can create these in a dashboard or spreadsheet that calculates the average, mean, median, minimum, maximum, and other various relevant statistics and calculations. You can also run a quick SQL query that does the same. Finally, if you've done this type of analysis in the past, it might be helpful to compare the two projects. If the results vary widely, this likely indicates that you need to recheck your dataset and your process. Better yet, consistent results help confirm that you're working with valuable, useful data. By putting on your detective's cap and viewing data from many different perspectives, you can be sure you're using the best possible data. Your stakeholders will appreciate your investigative spirit when their requests are fulfilled skillfully and thoroughly. Hi there, and thanks for joining me as we explore a business case about data management and storage tools. Data analytics in the cloud brings with it a library of tools that can assist with each phase of the analysis process. In this video, you'll work through a business data request and explore the tools you might use to fulfill it. In this example, you're a data analyst working for an app-based gaming company. After a few months on the job, you receive a business data request from the advertising team. They want to know how many users and what % of users are clicking on ads during gameplay. The advertising team will use your findings to decide whether they should continue showing ads during gameplay or instead just charge users more for the app. Your game app is hosted on various platforms and users are able to purchase a subscription if they want fewer ads. So you'll need to gather data from multiple data sources. The first data management tool you use is Google Cloud Storage. This will host all data once it's compiled. With this tool, you can upload data from remote servers through an internet connection. While working towards your business question, you're able to move your application databases, analytics, and data science tools into one place. You also use Dataflow in this project to create a data pipeline. Dataflow gives you the option of either stream or batch processing. This makes it possible to stream data from your various apps into one database. You can also use the batch processing feature to import any data you already stored on your computer. Cloud Data Fusion is the tool you use to build a data pipeline. You can also create data integrations, run high-volume data pipelines, and continuously integrate user data from your applications into your database. Once you have data from all sources streaming into your Google Cloud Storage, you use BigQuery to write SQL queries to join data and clean the data to ensure it's complete, has no duplicates, and will be useful for your project. Next, DataProc allows you to use open source data analytics tools at a large scale. And you can apply programming languages and algorithms to data also at a large scale. With these tools, you're able to move your data to the next phase and start drawing conclusions. After analyzing the data using the relevant tools, you share your discoveries with the advertising team, highlighting how many users click on ads and what percentage of total gamers that equals. With this information, the advertising team can effectively choose whether to keep using ads to generate revenue or charge users a fee. You've just experienced a typical business case involving data management and storage. Along the way, you successfully integrated multiple tools to complete a data workflow and find important answers for your stakeholders. Cloud data professionals are excellent data stewards, and with the strategies from this example case, you now understand how to use key tools and solutions to protect and control all kinds of data. Hello, future data expert. Welcome to this video all about DataProc. Together, we'll explore what makes it such a powerful tool and how you can implement it in order to both save time and increase the reliability of your data. Let's begin with an example. Maybe you work for a major online retailer that sells more than 500 products and sources them from about 2,000 suppliers. Obviously, this adds up to a lot of data, both structured and unstructured. This retailer is working on a strategy to stay competitive in the fast-paced world of online retail. Staying ahead of the competition is a top priority. That's why your company is so focused on building a cutting-edge data system that revolutionizes the way they process data in customer reviews. To help achieve this objective, you and your data team utilize DataProc to manage the unstructured data. DataProc is a fully managed service that maximizes open source data tools for batch processing, querying, streaming, and machine learning. One of the benefits of DataProc is that you can increase and decrease compute resources based on the project, so then you don't need to guess, underestimate, or overestimate resources. This means your online retailer can dedicate cloud computing resources that focus only on processing customer reviews. And you can have separate resources that focus only on processing sales information. You also learned that Dataproc works especially with Apache Hadoop, a framework that distributes the processing of data across clusters of computers. This also means that we can scale up to use the power of multiple computers, even thousands, to process our data in real time when we need it. Dataproc uses its open source tools on virtual machines that scale up and down as needed, and it can install a Hadoop cluster in 90 seconds. Let's learn a bit about how Dataproc scaling works. Dataproc disaggregates storage and compute services so both can be created and terminated as needed. This means that once you have data to store, your storage will remain. But if you're not actively processing data, the compute services will terminate. For a more specific example, let's go back to our online retailer. So your company is going to store external application logs in cloud storage. Then the data will be processed by Dataproc, which can write it back to Google Cloud Storage or BigQuery. You can also send the data to a data science notebook for analysis, or to data scientists who can build and train AI models. Because storage is separate from processing, your organization will save money by grouping tasks. So you'll be using exactly the right amount of memory and storage space to meet all your data analysis needs. Your company has always stored data in different servers and on some hardware-based servers. You learn that Dataproc has pre-built templates that can help you move your data from your existing structure into Google Cloud Services or GCS. Some of the common templates include Snowflake to GCS, Redshift to GCS, S3 to BigQuery, and Kafka to BigQuery. This means your databases in Snowflake, Redshift, or Amazon can be automatically moved into Dataproc with these templates. Plus, Dataproc makes it easier to manage Hadoop, and you can integrate organization-wide security. Plus, you can enable data users through integrations, giving varied permissions to different users. All right, now that your company has integrated Dataproc, it's able to provide data on all 500 products to all of its vendors. This has given your data team increased visibility into the best products to source and sell. Best of all, your suppliers receive a smoother, consistent flow of valuable recommendations, enabling each vendor to tap into the waves of user demand like never before. With real-time feedback and actionable insights, suppliers can fine-tune their product descriptions, ensuring they resonate with users on a whole new level. Hello and welcome to this video about process management. We are going to dive into some great strategies for keeping your data projects progressing smoothly. Data analysts usually have several projects going on at the same time, all at different stages and involving different tasks and teams. Managing this work simultaneously requires the talent of a skilled juggler, gracefully keeping several balls in the air at once. Each project represents a different ball, and you must carefully coordinate your movements to maintain control over all of them. With the well-organized internal process workflow, you can become a masterful juggler, skillfully switching between tasks and preventing any balls from dropping. There are 3 key parts of a typical data analyst workflow: using a data request central system, checking in code, and keeping an internal record of your work. Let's review each one now. First, it's important to have a data request central system to store and manage business data requests and related team conversations. This system provides relevant documentation, enables collaboration, and preserves historical records. Documentation is a process for preserving all of the details and conversations about each request in one place, making information easy to find when a data analyst needs to find or request it. Collaboration happens when members of the data analytics team visit the central system to review data requests, including queries and data delivery methods. Historical records are past data or information that's been stored and can be accessed or retrieved when needed. This supports collaboration and helps refresh your own memory. For example, Maybe you can't remember why you wrote a specific query a year ago. If it's documented, you can go back to the original request, review your notes, and remind yourself of why you wrote it. This can be a great time saver for new projects. And while we're on the subject of queries, it's also best practice for any teams who write code to check their code into some sort of central repository. GitHub is a popular tool for this kind of sharing. To check in code is to upload code to a main repository so others can access it and review it. You can check out a copy of the code and teammates will know that you are actively working on a copy of the code. Then, when you are ready, you can request a code review so you can get sign-off from your teammates. Once they approve the code, you can check in the code, and now everyone will have access to the changes you made. You just unpacked the importance of checking in code for effective teamwork. Now you explore more benefits of using a check-in system with a central repository to help you manage the code you check in. First, more effective collaboration. Another analyst on your team can review your code to catch potential oversights or errors before using it in production. Next, if a data report comes from a centralized repository, updates can be made there directly, avoiding the need to rewrite the report or create inconsistencies with changes in one place and not in others. Third, having code reviews and keeping all the live code in one place can improve code quality by ensuring consistency, following a style guide, and enhancing code readability in terms of using appropriate syntax and well-placed comments. For major changes to dashboards or reports, a code sharing system lets you track code easily. The next advantage is having an easier way to revert code. This system lets you undo changes with a single click, making it quick and simple to troubleshoot and fix code errors. Next, revision history reveals when and who changed or added code, helping you trace its origins and reach out to the relevant data analyst if you need clarification. Finally, keeping all your code in one repository makes it easier to locate. After all, you and your team will always need to know where to find your code files. As a final strategy, keeping an internal record of your work is a great time saver. You can use the same system when stakeholders submit data requests to create and track your own tasks for different projects. And logging your tasks in a central place not only keeps you organized, but also allows you and your team to share progress. Juggling multiple projects is all part of a day in the work life of a data analyst. But here's the good news. If you've got an efficient system that handles data requests, manages code check-ins, and tracks all your work, then you've got this. You'll have a super organized workflow and deliver top quality work on all your projects. Welcome, Data Wiz. Thanks for coming along for this journey into data management. In your role as a data analyst, you may receive data requests. In this video, we're going to focus on strategies for expertly handling these business data requests. A business data request is any business question that can be answered with data. So, when a stakeholder needs help from the data team, they'll typically use a ticketing system to submit their request. Then, the data analyst uses that same ticketing system to track and prioritize the request. While ticketing systems vary, usually they allow people in the business to submit a question or issue or ask for a new computing feature. The system then helps people track their requests from start to finish. Other examples of data requests may include asking for a new report or asking for modification to an existing dashboard or report. Generally, each ticket submitted will have a details page. Comments are written about each item, so all communication about the request exists in one place. The general elements of each data request are type, priority, and status. The type category can be set by your organization to help group requests together. You might group requests about a similar issue or by the person who's responding. Grouping the requests allows you to address all aspects of an issue as different people may point out different problems. The issue priority category does exactly what it says, helps people determine the priority for each issue. And the issue status allows the data analyst to provide a real-time status update about how the request is progressing. Besides the ticketing system, it's important to intake issues thoroughly. This means collecting as many details as you can upfront to avoid a lot of back and forth later. When taking requests, consider what, when, who, where, why, and 2 hows. Let's illustrate all of this with an example. Maybe, as an analyst, you're working for a nonprofit solar energy initiative. Your organization is tracking how a particular program is affecting smaller communities outside a city. You've been taking data requests from all stakeholders in any form, and it's starting to get confusing. So your data team institutes a ticketing system. Through this new system, stakeholders can now submit business data requests to ask for reports, data clarifications, reference data, data extracts, and more. All right, here comes your first issue in the tracker. You receive a data request asking for a count of communities affected by the Solar Energy Initiative. So you ask the following. First, the what. Should all solar energy initiatives be counted or only certain types? Second, when. How far back should the data go? Just this calendar year? The last 365 days? Or for all time? Next, who. Will all communities be included in the dataset or only a subset? Okay, now you've come to where. So you ask, should the data be stratified by any particular region or zip codes? When you stratify something, you divide it into groups. All right, now why? It's important to understand the business context in which the stakeholder is coming to you with this request. For example, what are the business questions this report would help answer? Thinking about context also helps guide additional questions you may have missed asking in the data intake process. Next is the first how. This how is about refreshing the data. So you ask, how often should this data be refreshed? Is this just a one-time pool, or will it be needed on an ongoing basis? And finally, the second how is about data delivery. For this, you consider how the stakeholder wants the data delivered. They might prefer a lightweight static report like a spreadsheet or a more robust dynamic dashboard. These are a lot of details to cover with your requester. Thankfully, having a system allows you to document the details so you can easily refer back and iterate if needed. With this info, you're able to get back to your stakeholders with valuable data insights. But wait, you've just received another ticket. Now, one of your stakeholders wants to know how many buildings have reduced energy costs compared to buildings that didn't opt into the solar initiative. When you start to research this question, you realize that you need to first create a report listing which buildings received solar energy in which year. Then, you'll need a report that segments those buildings by start date. For these tasks, you create something called a parent-child relationship. Luckily, this is another great feature of ticketing systems. A parent-child relationship enables users to divide a single ticket into sub-tickets, which can be worked on simultaneously, sometimes even by different team members. So, for example, identifying which buildings received solar energy over the past year is a separate task that needs to be finished before you can answer the main question related to overall solar savings. With this in mind, you create a child request for each new report and attach them to the parent, the original request you received. In the ticketing system, you then define the relationship between the requests and order them in a way that makes sense. Great work. Now you're prepared to answer the stakeholder's latest question. As a final point, let's go over how to track all of the requests in a ticketing system. For this, you'll use status fields. Some common status fields are assigned, start work, in progress, fixed, verify, and reopen. Your organization may customize these based on their needs, but the key is that the status fields enable everyone to easily understand the status of a request. Also, saving fixed and verified requests creates a handy database of previously answered questions. So, for the purposes of your solar energy project, you'd indicate the issue regarding the number of buildings using solar that needs to be verified and the request regarding the total amount of savings. Nice. Using an efficient tracking system enables you to share data quickly and accurately. It improves overall communication and collaboration. And it'll definitely make your life easier when you have numerous requests coming in for your expert data work. Hello, and thanks for being with me to discover some great ways to keep data team members on the same page. And I do mean page because this video is all about data documentation. Data documentation is a written guide to the data contained in a dataset, how it was collected, and how it's organized. Data documentation typically includes the purpose of collecting the data, the procedures followed, the date and time data was collected, the structure of the dataset, and any notes about data validation or quality assurance. Data documentation may come in the form of README files, a data dictionary, a code book, a lab notebook, a spreadsheet, and more. Let's get into this with an example. Maybe you've just joined a data team as an analyst at a cutting-edge renewable energy company. As you start to become familiar with the data available to you, you notice that wind and geothermal energy are recorded on different spreadsheets with different columns and notations. And you notice that the different departments within your organization are keeping their own data tables and integrating them together for reporting. You also wonder why your team only has access to data for the last 2 years when there is at least 10 years worth of data available. Just then, one of your new coworkers hands you the team's data playbook and documentation for the data sets you're using. They explain that the playbook documentation defines the data, which will help you understand the information you're working with. Full of curiosity and momentum, you delve into the playbook, ready to uncover solutions that will bring clarity to the data puzzle. You discover that the team's data playbook provides the company's overall plan for handling and managing data with team-specific processes. For a data analyst, the most important elements of the team playbook are information about how to request data access, how to grant data access to others, where your team stores data tables in BigQuery, and how to carry out common tasks. As an added bonus, sometimes a team playbook includes sample queries for common requests like merging data. As you review the playbook, you start to understand why the wind and geothermal data are kept in separate files. You find out that there are certain individual projects that are crucial to the environmental success of the company. And in some of the case studies included in the playbook, you find some great examples of how the data has been merged together in the past for other initiatives. You join your team in a retrospective and discuss the benefits of sharing the playbook to complete your data analyst tasks. You learn that the data playbook is a living document, meaning it's updated as needed. So, when you become more accustomed to working on the team, they look forward to your contributions as well. Now you understand the importance of data documentation, like a data playbook, and how teams follow documentation procedures to collect and manage data. Having an up-to-date playbook will help ensure you and your data team stay on the same page. Congratulations, you've accomplished so much during this section of the program. You're well on your way to becoming a cloud data analyst. Now you understand lots more about the work of data analysts in cloud data and how you might collaborate on a data team. You also discovered the basics of some key cloud data tools and processes. Along the way, you focused on data gathering, plus data access management and storage tools. This also included an investigation into data processing and transformation. And this section covered a lot about data requests, data documentation, and team playbooks. Thanks again for joining me, and well done. You're making outstanding progress.
As a hiring manager, I really want to screen people in rather than screen people out. We're always looking for reasons to say yes to people rather than to say no. I'm Vince, and I'm a cloud data engineering manager. That means that I work with a team of data engineers to help customers solve data and analytics challenges. The qualities we look for in candidates are general facility with data. A little bit of an analytics background is always good. Familiarity with technologies like SQL, big data technologies, and batch and stream processing. Workplace skills are critical. Workplace skills are almost everything else that you do other than the hard technical skills that you exercise in your job. So the ability to collaborate, the ability to find compromise, the ability to lead, all of these things go into being a really strong employee. When it comes to showcasing your workplace skills, it's not just important what you would do to solve a problem, but how you would solve the problem. Helping your interviewer understand your process and how you get to a solution is just as important as the solution itself. I think confidence is really important when I'm interviewing a candidate. I like to see that a candidate is comfortable in a situation like interviewing, which is inherently kind of uncomfortable. It's a good signal if someone shows up with a high degree of confidence to an interview, that they'll show up well when they're in high-stakes situations with customers. Candidates have a lot of power in the interview process. If you've made it to the point of an interview, then the company views you as someone who might be someone who they want to work there. I think it's important to ask questions of your interviewer that would give you some insight into what it's actually like to work at the company you're interviewing for. Questions that you might have about things like work-life balance. One question that I always like getting from candidates is, what's one thing you would change about the company that you work for? If you're considering getting started in a career in data analytics, I would really encourage you to find some public data and use some of the great open source tooling out there and start playing with some data. It's a great way to build experience and also see if it's something you'd like to build a career around. Hi, I'm Vince.
Hi, I am Monica.
Congratulations on making it through this course. Now you're going to get a sneak peek on what an interview on the topics in this course would be like.
We hope this will let you know what to expect in your next interview.
What interests you in a career in cloud data analytics?
I have always been very passionate with numbers. I understood and worked them very well through high school. I remember math being one of my subjects with my highest score in my report card. And then when I had to choose for a career path, I decided to do computer information system, which was like the business and also like the technical side of analysis. One of the projects that I worked while in the university was to create a data set schema. And I remember then I was amazed by everything data. So that's what got me into data analytics.
So tell me about your work experience and how that prepares you for a role in data and analytics.
Previous role that I had was in IT technician. Part of my role was to be responsible creating a dashboard to show the usability of a tool. After the analysis, we concluded that the tool was being used, but just by promoting it a little bit more could be more useful and decrease the time of troubleshooting for the techs.
What are some ways that cloud computing can be challenging for a company?
Cloud computing can be challenging for a company integrating data from these different sources. Also compliances, they have to meet the strict regulators and the privacy standard.
Can you talk a little bit about your experience with either of those two areas?
Sure. I would say when I created the dashboard that I was talking earlier, all the information that I was using was for different data sources. So I have to basically clean and then join them using the same attributes.
So imagine this scenario. A stakeholder approaches you and says that they need a report on company payments. As an analyst, how would you intake this request?
If a stakeholder comes to me asking for a report of payments, I will ask some questions. Some of the questions that I would ask is, what is the objective of this analysis? So I know the purpose of it. I would also ask the times. Does he want to do an analysis of a year, of 2 years, of like just a month, so I can gather the information, the data that I just need for that dashboard. And lastly, I would ask if there's any PII or data security requests for this dashboard.
All right, so you've completed your requirements gathering. What are a couple of things you might need to start the analysis?
So the first thing that I would do is to make sure the data is valid, the one that I'm working with. And after that, I would just analyze it using query.
What would you query the data with?
I will use SQL to query the data.
What's an example of a system that might enable you to query it with SQL?
Sure, one example of that could be BigQuery.
Okay, Monica, I want to thank you for interviewing with us. I really wish you good luck with the rest of the process.
Thank you, Vincent. Thank you so much for your time and consideration.
In this scenario, Monica showed how to talk through your answers and show your thinking. By sharing your thought process, you demonstrate what you know and how you solve problems. Problem solving is a top skill hiring managers are looking for. That's it for now. Stay tuned for more tips.
Congratulations on finishing this course. You are well on your way to accomplishing great things in cloud data analytics. My favorite part of working in cloud data analytics is the opportunity to provide answers and insights that a user, stakeholder, or customer may have never thought possible. Making data available, usable, and accessible is no small feat, and with the right tools and skills, you can really change how people think about problems and make decisions. As someone who loves helping people, that's exciting. Now, let's take a minute to go over all the things you learned in this course. You began by exploring an introduction to the program and some tips for successfully completing the certificate. You also learned about cloud computing, its components, and cloud computing versus traditional computing. Then you explored cloud data analysis versus on-premises data analysis. And you learned about the impact of cloud data analytics on all kinds of businesses, with a special focus on the Google Cloud Architecture Framework. Next, you discovered the inner workings of data management and the data lifecycle, and the cloud data analyst roles in keeping both running smoothly. You also explored cloud team collaboration and how this helps teams to create some really cool business projects together. Finally, you discovered what cloud data tools are in an analyst toolbox and learned about the importance of data documentation in data analytics. You now know about cloud data tools, and you can understand and communicate cloud benefits, share timely insights, and so much more. Congratulations on your progress so far. You're off to a great start.
Hello, data enthusiast. I'm so happy to welcome you to this course about cloud storage and data management in the cloud. My name is Eric, and I work as a product analyst at Google. I began my career as a recruiter in aerospace, where I aim to quantify what attributes set apart especially great job candidates. I've since worked across several industries, from aerospace to entertainment to tech, and across several departments, from recruiting to real estate to product. Across all of these experiences, the importance of data infrastructure has been a through line. Deriving insights from a dataset fundamentally requires that data to be organized and accessible. I can't wait to share more and help guide you through the next series of topics, all about how data is structured and organized. You're about to gain tons of practical experience in data organization, which means you'll be equipped to establish a plan that ensures you can find the data you need in a useful format anytime you need it. You'll examine data lakehouse architecture, which, as you know, is not how you build a house on a lake, but an effective way to store, process, and analyze vast amounts of data. Here's the breakdown. You'll start with data storage, data connections, data types, and data structures. Then, you'll move on to table schemas, along with batch and streaming data processing. Next, you'll explore denormalized data, data governance, metadata, data catalogs, the key components of data lakehouse architecture, and more. Then, you'll discover the dataplex and how it can be used to identify data sources in BigQuery. You'll learn to identify and trace data sources and how to access data libraries. Finally, you'll explore data reference architectures, how to manage tables in BigQuery, add and export data, and query tables. You'll learn to access data from Google Cloud Services and manage a Dataproc cluster. Then, you'll explore the benefits of data partitioning. These lessons are specifically designed to give you a solid foundation in organizing and structuring data, which any employer will appreciate. You've made a great start in your journey as a data analyst so far, but we've got lots more fun ahead. Let's keep the momentum up and move on. Hi, I'm Eric. Here at Google, I'm a product analyst focused on Google's technical infrastructure. This means that I help Google use the many machines across its data warehouses as efficiently as possible. In other words, I improve the stuff that helps run Search, Gmail, and every other Google product. I'm excited to help you ramp up your analytics skills. The vast majority of my analytics and data science skills are self-taught. My educational background is actually in psychology and communication. I began my career in recruiting. I supported an internship program for a space company and represented that company at career fairs across the organization. Ultimately, I recognized that to recruit efficiently was actually an analytics problem. I needed to quantify HR data to answer questions like, What is most predictive of a candidate's success? And what factors most contribute to an intern's employment satisfaction? I ultimately learned, mostly via searching online, optimal ways to measure and present that information. Fortunately, analytics techniques are often shared across many departments and industries. This has allowed me to bounce between industries like aerospace, entertainment, and tech, and departments like HR, real estate, finance, and product. These experiences enabled me to recognize how analytics concepts translate across business contexts. I started my analytics career with a social sciences undergrad degree. While statistics and computer science degrees are certainly helpful, they're not necessary if you're hungry enough to learn on your own. As people work to grow in the cloud data analytics space, there are a few things that were helpful for me that I recommend. First, start with clean data. An insight is only as valid as the data it's derived from. Before you start, make sure your data sources are correct and accurately represent the big picture. Also, while we work with numbers, analytics is really about storytelling. Don't just focus on the numbers. Focus how to communicate those numbers such that folks understand what they mean and how to respond. Hey there! Are you ready to get moving? And by that, I mean get data moving, of course. This module will get you into how data moves within and across systems. We'll identify different types of data, their appropriate storage structures, and various data extraction methods, including ways to transfer data between systems. The first topic you'll explore is modern data architectures. After that, you'll review the concept of a data lakehouse and examine its benefits and challenges. Next, you'll consider the different data types highlighting their key characteristics and considerations. Finally, you'll gather essential techniques and strategies for handling both batch and streaming data sources. You'll then be able to effectively manage and process data in diverse systems. I can't wait to help you start this journey. Picture this. You're lounging, scrolling your favorite website, and then bam! You notice an ad for a product you've never thought about before, but now you have to have it. You know, something that exactly matches your interest and style, like a tea kettle disguised as a houseplant. How did they know? Most likely, a business has tracked data related to your past purchases to send you ads, offers, and coupons that will make sure you come back again and again. It can be mind-boggling to consider how perfectly an ad figured out what you, personally, would like. Now, say you work as a data analyst for a company that has millions of different customers. That company needs to know a lot about their customers' likes and needs to recommend the right product for each customer. How can companies manage all this data? And how do they handle multiple sources and formats? A key piece is data storage and how data is connected across systems. And that's what we're going to explore in this video. Cloud data storage is a solution that enables organizations to keep, access, and maintain digital data in off-site cloud-based servers that they don't need to own or manage. The data can include files, business data, videos, images, and tons more. In the context of these data storage tasks, data analysts generally focus on input and output data. Input data is any information that a user sends to a computer, like the text you type into a document, the information you enter when filling out an online form, or an image you scan with a scanner. Conversely, output data is information that a computer sends to a user. Some examples include a spreadsheet outputting a pie chart, or a photo editing program outputting a PDF, or an online store outputting a sales receipt or order summary. Data storage systems can be used to store both input and output data. Some common storage systems you might want to connect in order to access data might be systems of record, transactional databases, and cloud storage. A system of record is a data storage system that serves as the source of truth for an organization's data. Related to processes or systems, this includes any proprietary information and data used to maintain compliance. All of the data associated with these systems is uniform in a system of record. The system of record is the authoritative data source for data related to the process or system which it supports. Next are transactional databases. A transactional database is a data storage system which stores each transaction, or interaction, and their fields as individual rows. Transactional databases are common in e-commerce, online banking, and other businesses that may record customer transactions. A transactional database can also be one of your systems of record. For example, imagine you work for a company that sells clothing and equipment for outdoor enthusiasts. Each time a customer purchases a pair of hiking boots, a new row is created in your transactional database. The row contains the customer name, the inventory name of the boots, the date of the purchase, and the sales price. All of the rows together make up the transactional database. That's a mountain of data. Finally, there's cloud data storage, which is a solution that enables organizations to keep, access, and maintain digital data on off-site cloud-based servers. A cloud provider hosts and securely stores the data, making it easily scalable when you need to increase or decrease capacity. So, it's very likely that you'll be working with multiple sources of data in your cloud career. And to make sure that all of that data can work together, you'll want to be able to connect to all of your data sources. A data connection is a link formed between a data source and another tool in order to access the data source from the tool. In order to view and interact with your data, you will want to work with a tool that allows you to easily connect to all of your data systems from a single place. Usually, this is a business intelligence or analytics tool from which you want to be able to connect to all of your business's data in order to create dashboards, reports, pivot tables, or other types of analysis. These tools provide data connectors to let you access the data you might have in transactional databases, cloud storage, or other storage systems. Now you know the essential tools you'll use to gather, store, and access data. And you've learned how data connections help keep everything working smoothly together. With this know-how, you'll be ready to find and transport your well-organized data.
I think data analytics has a profound impact on the world. I think it ultimately helps us to truly capitalize on the potential that digitization has and really helps us getting to a better, more equitable, more sustainable world. Hey, I'm Garrett. I'm the head of data analytics at Google, and I'm building services that process and analyzes large amounts of data. Data analytics is really about helping our customers to unlock the value from the data that they are having. So you can think about data like all of those secrets and hidden patterns that surround us every day. We want our customers to be able to understand them, see them, and ultimately harness them to drive business value for them, improve their customer experience, or ultimately just take better decisions quicker. The beginning of my career was in software development. I started as a junior software developer in a database development team and learned from the very first lines of code that data processing systems are awesome. I studied computer science at college, yes. One of the biggest lessons, though, of my life is that, learning is not an institution. Learning is an attitude. When you are at work, that of course, doing your job, but also having an interest in all of the areas outside of it and trying really to get a very broad skills profile because, once you progress in your career, you really draw on the breadth of your experiences, on the breadth of your knowledge, much more than on something that you have deeply specialized. So I think there is a big opportunity in learning broadly and widely, even outside of the regular career and work paths. I think the most important part is to really appreciate learning and appreciate what learning is. Learning is not applying. Learning is not being proficient. Learning can be very frustrating, actually, and it's hard. But once you understand that it's a hard and rewarding and sometimes, lengthy process and accept that, you can make it, I think, really a part of your life and of your life experience in a very positive way. Data analytics and cloud really go hand in hand. Data is vast. There is no limit that we conceive to how big data can get. It's being generated every day. It's generated at increasing rates. And the cloud actually provides the capacity. It provides the systems that actually can store and process these vast amounts of data in an efficient and even in a conceivable way. So you do need both, right? You do need to have the digitization of everything, and you need the cloud as the foundational infrastructure to process that data. So I think rather than limiting to I want to learn one language or I want to learn one technology stack, I would really recommend learning and appreciating the breadth of Google's cloud. Feeling unprepared is part of the journey to growth. I think it's quite normal to feel unprepared or overwhelmed when you get into a new job or into a new opportunity. I think what everyone experiences, what I have experienced all throughout my career. And it's really the trigger point, right? It's basically telling you that, hey, here's something interesting. Here's something new to learn. Once you appreciate it for what it is, really growing yourself, it kind of, gets real fun and exciting.
Hi there. It's great to have you here. Thanks for joining me in this video about getting data organized. This is a really important topic, not just because data organization is a big part of the data profession, it will help you be more time savvy too. How much data are we talking? An astounding 2.5 quintillion bytes of data. That's 2.5 billion gigabytes. Or to help you comprehend this better, that's roughly 10 million laptops worth of storage space generated globally per day. Wow. It's no surprise that effective data organization is so valued by analysts and their organizations. All right, let's begin exploring the different types of data storage tools. These include relational databases, data warehouse, data marts, CSV file, and data lake. Each of these has benefits and drawbacks depending on the type of data being stored. So as a data analyst, it's helpful to understand which option is best for whatever type of data project you're working on. First, relational databases. A relational database is a database that contains a series of tables that can be connected to form relationships. Relational databases are frequently used in businesses of all sizes to manage their data because they allow users to perform complex queries on data from multiple tables all at the same time. Then there is the data warehouse. The data warehouse is a database that consolidates data from multiple source systems for data consistency, accuracy, and efficient access. They're optimized for analytical queries, making them ideal for organizations that require complex data analysis. Next up, the data mart. The data mart is a subject-oriented database that can be a subset of a larger data warehouse. Being subject-oriented just means that it's associated with a specific area of interest or department of a business. This makes data marts useful for business intelligence and reporting because they provide easy access to specific data subsets. Next is the CSV, which stands for comma-separated values. A CSV file is a delimited text file that uses a comma to separate field values. While CSV files are simple ways to store tabular data, like in a spreadsheet, they lack scalability and are ineffective when working with large or complex datasets. Finally, the data lake. The data lake is a database system that stores large amounts of raw data in its original format until it's needed. Data lakes are a versatile solution when you're working with diverse sources and data types. Data lakes allow you to process data without restriction to size and format. But no matter what data you encounter, managing and storing it effectively is crucial to making sense of it and to make smart, data-driven decisions. Welcome back, data devotees. Today, we'll start with discussing a crucial part of your data career, the main ways in which data is stored. These include structured, semi-structured, and unstructured data. Being able to recognize these three main ways of storing data will set you up for success when it comes to finding and querying the right data for each particular project you work on. Okay, let's start with some definitions. Then we'll take a deeper dive into how to store different types of data. Structured data is data organized in a certain format, like rows and columns. For example, you might find structured data in a table or a spreadsheet. This makes it easy to understand and process by computers. Structured data is easily stored in traditional databases, like a SQL database. One of the essential features of a SQL database is its ability to establish relationships among tables. For two tables to have a relationship, one or more of the same column must exist inside both tables. These columns are called keys. There are two types of keys, a primary key and a foreign key. Each table has a primary key, which is an identifier that references a column in which each value is unique. You can think of a primary key as a unique identifier for each row in the table. As an analyst, you may need to create tables. If you do decide to include a primary key, it should be unique, meaning no two rows can have the same primary key. Also, it cannot be null or blank. There are also foreign keys. A foreign key is a column within a table that is a primary key in another table. For example, a foreign key is how one table can be connected to another. That's what makes it possible to establish the relationships among tables. Pro tip: it's important to keep in mind that more than one foreign key is allowed to exist in a table. With these keys, users can combine data across multiple tables and query them simultaneously, making it easier to analyze complex relationships and gain valuable data insights. Next, let's check out semi-structured and unstructured data. Unstructured data is data that is not organized in any easily identifiable way. It lacks a predefined structure and can include text, images, videos, and more. Examples of unstructured data include social media posts and audio recordings. Unstructured data is valuable because it can be used for such a wide variety of purposes, even though it's more challenging to process and interpret. For example, cloud-based data lakes are well suited to unstructured data. Some of these tools include Google Cloud Storage, or GCS, and Google Cloud Dataproc. They don't require a fixed schema. Instead, they store data as documents or files, and this can include any number of fields and nested data structures, or no structure whatsoever. This allows a data analyst to quickly store, search, retrieve, and analyze data as needed no matter the data format. It's also easier to modify the data without impacting the application. Imagine a social media app. If the user posts a text caption along with a video, both the text and video file are examples of unstructured data that cannot be mapped to a predefined structure since they could contain anything. Finally, now that you have an understanding of structured and unstructured data, let's move on to semi-structured data. Semi-structured data is data that has some structure but is not as precisely organized as structured data. This means it's more flexible than structured data, which makes it great for storing data that might not fit into a traditional table or spreadsheet format. One common example of semi-structured data is email. Email messages have a header that contains structured data, such as the sender and recipient names, subject, date, and time. This structured data makes it easy to find and store email messages, but the body of the email is unstructured and can contain a variety of data types, including text of various lengths, images, links, and attachments. This makes emails flexible and easy to use for a range of tasks. In your data career, you'll come across tons of different data sources. They're the true foundation of any data-driven decision-making process. And that's why it's crucial to be able to recognize the various data structures so you can determine the best way to get that data moving. Great work tackling this important topic. In the early days of data analytics, as businesses started collecting and analyzing large amounts of data, the term data warehouse emerged to describe the architectural concept used to store and organize this data. The analogy of a warehouse illustrates the idea of a centralized, structured, and organized storage space where a data analyst can efficiently manage data and make it accessible for analysis. Then, as businesses accumulated vast amounts of data from various sources, including unstructured and semi-structured data like text documents, images, videos, social media posts, and sensor data, traditional data warehouses faced challenges in efficiently storing and processing this data. To address these limitations and accommodate the diverse and rapidly growing data, the concept of a data lake emerged. In this video, you'll explore an example of a data lakehouse and witness just one way they're revolutionizing the way data is managed and analyzed. A data lakehouse is a hybrid data architecture that combines the features of a data lake and those of a data warehouse. This creates a unified platform for storing, processing, and analyzing vast amounts of structured and unstructured data from diverse sources. By leveraging the strengths of both data warehouses and data lakes, a data lakehouse offers improved data management capabilities, seamless integration with analytics tools, scalability, and the flexibility to efficiently handle various workloads. Let's examine this with a business example from an agricultural company. The business has a data infrastructure which includes an on-site data warehouse and a cloud-based data lake. Hosting data in separate infrastructures is hindering the ability to adapt to changing business needs and extract timely insights. To potentially resolve the issue, the data analytics teams wants to migrate to a data lakehouse. They initiate a comprehensive migration plan. It begins with assessing their existing data infrastructure and identifying any pain points and bottlenecks. It turns out that their traditional data warehouse is struggling to handle the growing data volumes and diverse data types. There are JSON documents, supplier call recordings, and free text from vendor and partner surveys. Storing and processing hundreds of terabytes of data is going very slowly, and sometimes overwhelms the servers to the point of crashing or breaking the system. At the same time, the company's data lake lacks the necessary structure and governance mechanisms. Data analysts are struggling to understand if the data has quality issues like blank fields and product categories that don't match other tables. Data discovery, integration, and quality control are significant challenges impeding efficient data analysis and decision-making. The company's data team then implements the data lakehouse to unlock the true potential of their data. Now, they can store and process data in its raw, unaltered form, while providing necessary structure and organization for efficient analysis. Plus, they can scale resources on demand, ensuring optimal performance during peak data processing periods. The data lakehouse also addresses their data governance concerns. With defined data schemas, access controls, and security measures, they establish strict policies adhered to compliance requirements. Things are going so well that the company decides to take it a step further and tap into the cloud's analytical capabilities. They integrate advanced analytics and machine learning tools into their data lakehouse architecture, enabling them to uncover hidden patterns, perform predictive modeling, and generate actionable insights. Their data scientists and analysts explore vast amounts of data, experiment with different algorithms, and drive innovation. This company now enjoys significantly better agility when creating reports, dashboards, and queries. Teams can respond more quickly to market changes and customer demands. And the enhanced data governance framework instills confidence in their stakeholders, ensuring the privacy and security of sensitive information. Through the strategic move to a data lakehouse from a data warehouse, the company has harnessed the full potential of its data and empowered its people. And now you're empowered with the knowledge of data lakehouses. Great work. Schemas are powerful tools that help people make sense of the world. Schemas provide a way of describing how something is organized, and people use them constantly, usually without even knowing it. For example, you may use a schema when planning to visit a new museum. The schema for a museum might include a description of the different types of art on the display, the size of the museum, the entry fee, and the location. All of this information can help you to understand what to expect when you get there. Schemas are also an essential part of understanding tables. In this video, you'll explore table schemas with BigQuery. There are several parts of a table schema that provide important information essential for understanding a table and its columns: the column name, the data type, and the mode. Let's explore each one. First, we'll start with the column name. Each column in a BigQuery table has a unique identifier called a column name. You use column names to refer to columns in queries and access the data in the columns. Column names can contain letters, numbers, and underscores, and they must start with a letter or underscore. It is also important that each column name is unique. This means that each column name needs to be different from other column names so that the columns are easy to find and use. Next, let's move on to the data type. The data type of a column specifies the kind of data that can be stored in the column. For example, a column with a data type of string can store text data, while a column with a data type of integer can store numeric data. The exact data types you can use will depend on your cloud tool. BigQuery supports a wide range of data types, including numbers, strings, date and time, location, time interval, JSON objects, struct, and array. Number types can be used to store numeric data, which is any data that can be represented as a number. This includes integers, floating point numbers, and decimals. Common number types are numeric, integer, and float64. String types in BigQuery can be used to store any sequence of characters, including text data, such as names, addresses, and phone numbers as strings, as well as binary data as bytes. While number and strings are the most common, there are other data types you can use in BigQuery. Date and time types, like date and datetime, can be used to store date and time data, such as order dates and shipping times. Location types, like geography, can be used to store geographic coordinates, such as latitude and longitude. Time interval types, like interval, can be used to store periods of times, such as how long it took to fulfill an order or how long a customer was on the phone with support. BigQuery also has two main complex data types, arrays and structs. Arrays are called repeated columns in BigQuery, which means they can store multiple values of the same data type in the same column. Structs are called records, and they can store multiple values of different data types in the same column. In BigQuery, you can also use JSON. JSON objects can be used to store key value pairs of data. Now, let's discuss the mode. The mode is another important part of a schema. The mode tells you whether a column can contain empty values. A nullable column can contain empty values, while a required column cannot. Mode is also important because you can turn a column into an array by setting the mode to repeated. By looking at the column names, data types, and mode for each column in a schema, you can learn how the data in the table is structured. This will help you write queries, group data, create tables, and share the data with others. Keep practicing using BigQuery to explore table schemas and how they organize data into logical groups to streamline your workflows. You're well on your way to becoming a BigQuery Schema Data Pro. Hello, Data Virtuoso. Thanks so much for being here to learn about nested data structures. Understanding the concept of nested data is super important to the field of data analytics. The good news is that you likely already have a basic understanding of something that's nested. Have you ever reviewed a company's organizational chart? In this nested structure, the company is the main object, or structure, and the departments are the substructures contained within it. Those departments further subdivide into teams, and the teams further subdivide into individual employees. A website is another everyday example. The home page is the main object, with the other pages being the substructures. Each page further subdivides into sections, and the sections further subdivide into different types of content. Similarly, a nested data structure is a structure that organizes data within other data structures, forming a hierarchy of information. They provide a highly effective way to store, process, and retrieve information. This allows a data analyst to ensure data integrity and facilitate efficient data management. Nested data also plays a major role in representing complex associations, like parent-child relationships or multi-level categorizations. By nesting data, it's possible to capture these connections and dependencies, enabling more advanced data analysis. There are various types of nested data used in data processing, but not all tools support all data structures. Two common data structures used for nested data include struct and arrays. A struct is a way to group multiple columns together. A struct is called a record in BigQuery. This is useful when you want to organize data that is part of a common thing. For example, imagine you have a group of columns that each contain one important piece of information about a customer's address. To group this data together, you can use a struct called address. In this address struct, you can nest the related columns, like the first or second line of the address, the city name, state or province, postal code, and country. By grouping the related columns together in a single column using a struct, you can make it easier to find and query the customer data. An array is a list that contains values of the same data type. An array is called repeated in BigQuery. Arrays can be used to store a range of data types such as numbers, strings, structs, or even other arrays. When you use an array, you can store an entire list of data in a single column, as long as they are of the same data type. For example, you can use an array to store a list of email addresses from a customer in one place. Arrays can even store nested data. An array of structs is a list of structs stored in a single column. This is especially useful for storing lists of complex repeated items, such as different addresses. For example, each customer may have multiple addresses for different purposes, such as shipping, billing, home, and work addresses. By grouping all customer addresses together in an array of structs, you can keep all the customer's address information organized and easier to access when querying. Each type of nested data has its unique characteristics and use cases, providing versatile tools to manage and analyze complex datasets. Additionally, patterns within the data, like recurring structures or hierarchical relationships, can help you decide when using a nested data structure may help make it easier to work with the data. Now that you can identify nested data structures, you can start to understand how the different parts of the data relate to each other. This is important because querying nested data is different from querying regular columns. To write queries that work with nested data, you need to know how to recognize nested structures and how the nested data elements work. Just like a business's organizational chart helps you locate where your data team members fit in the organization, and a website homepage links to its many pages to help you find the content you need, you can identify and understand nested data structures to help you pinpoint the right information. Imagine observing, from the rooftop of a building, the intersection of two bustling roads. One represents the world of batch data, where information is collected, processed, and then delivered in regular, steady intervals. Just like the cars waiting at the light before zooming down the road, batch processing enables data professionals to collect large volumes of data over a period of time and then process it all at once. The other road represents the fast-paced streaming data. Streaming data is processed right when it's received, like the constant flow of traffic. Now, please ride along with me on this road trip to catch the sights of the fascinating landscape of batch and streaming data. Let's begin with batch processing. Batch processing is a method of collecting large volumes of data over a period of time and then processing all of it at once. Batch processing uses various data sources, and each has their own characteristics and advantages. The most common formats include CSV, or comma-separated values, found in spreadsheets, and many types of databases. JSON, or JavaScript Object Notation, which provides easy-to-read representation of complex data structures. And Parquet, a columnar storage format for quick compression and improved query performance. The frequency of batch data processing varies based on the specific use case, ranging from hourly to daily to weekly and beyond. Now, on the other hand, streaming data processing is a method of processing data as it's received. It might come from a device in the Internet of Things, or IoT, a social media feed, and more. The frequency of streaming data processing is typically in real time or near real time. With streaming data, you'll encounter file formats and systems specifically designed to handle velocity and agility. One is Avro, which is a file format that helps programs understand and share data using schemas and seamless handling of data structure changes. There's Apache Kafka, an open-source distributed event streaming platform that allows you to publish, subscribe, store, and process streams of records. This is particularly useful for building data pipelines and applications that require handling large amounts of data. And finally, there's Apache NiFi, an open-source data integration and data flow automation tool which is particularly useful for collecting, transforming, and moving large volumes of data. Both batch and streaming data processing have advantages and disadvantages, depending on the use case. Batch processing is great for handling large volumes of data efficiently, like in data warehousing and analytics. It also enables organizations to perform complex analytical operations, like aggregations, transformations, and statistical calculations on huge datasets. And it provides the necessary time window to process historical data and generate insights for long-term planning and decision-making. However, it takes time to generate these insights. Conversely, streaming data processing is instrumental in near real-time analytics and monitoring scenarios where timely insights and continuous monitoring are vital. Organizations use it to monitor live data streams, to detect anomalies, trends, or critical events in near real time. Streaming data processing supports implementing alert systems and triggers actions based on predefined conditions, enabling companies to respond swiftly to new situations. However, handling streaming data is often more complex and expensive. Selecting the right data processing paradigm is a critical decision that affects data processing efficiency and compatibility. To make the best choice, consider factors like data requirements and data characteristics, processing speed and latency constraints, and integration capabilities with existing systems. As a cloud data professional, it's crucial to evaluate the pros and cons of each format in different scenarios to make informed decisions about data processing strategies. With this understanding, you've now got what it takes to enhance your organization's data processing efficiency and navigate with a tank full of potential data. Wow! You've come to the end of this section all about data types, organization methods, and how data moves. You've learned a lot of valuable information that will be incredibly useful as you continue on your path in the cloud data profession. You began this section exploring data storage and connections, plus data types and structures. You then moved on to table schemas and data processing methods. You were introduced to the concept of a data lakehouse, uncovering its advantages and challenges, and you investigated important aspects of modern data architectures, giving you an overview of the entire data transformation process. There have also been many new terms and definitions in this section of the course. Be sure to check out the glossary to make sure you are comfortable and confident with these concepts. Thanks for joining me. You've got this. Hey there, and welcome to another exciting section of the program. I'm really excited to dive deeper into more ways you, as a data professional, can build your skills. You'll start by learning more about key elements of normalized and denormalized data. Next, you'll explore data governance, technical and business metadata, and master data management. Then, you'll check out data catalogs and their different components and types. Finally, you'll spend a bit more time with data lakehouses and get some great tips for implementation. There's a lot to cover, and all of it's specifically designed to give you a comprehensive understanding of data organization best practices. After completing these lessons, you'll be able to easily define your role in both data organization and the entire data lifecycle. Let's get started. Hey there, data fan! Thanks for joining me for an in-depth examination of denormalized data. You're about to learn some common denormalization techniques, but don't worry. This examination has no wrong answers. But first, let's understand normalized data. Normalization organizes related fields into different tables and maintains defined relationships between columns in these different tables. For example, one table can hold data related to employee information, like employee ID, employee name, manager ID, and so on. Meanwhile, another table can contain information about the department they work in. We can join these two tables together using the manager ID. When data is normalized like this, it's generally easier to avoid duplicate data and inconsistencies and apply updates. On the other hand, denormalized data stores repeated information in one or more tables. Denormalized data is ideal for gathering information quickly. It reduces overall complexity, and it creates the ability to scale quickly. But denormalized data has disadvantages, like duplicated data, increased storage needs, and the potential for inconsistencies. There are different ways to denormalize data, which improves query performance. The most common way is to add duplicate columns in each table. Then a data analyst doesn't need to join the tables themselves. Other methods are to split tables into smaller ones that only have rows or columns that each application needs, mirror tables by making copies of tables for easier reading, or create summary tables that hold ready-made totals like counts or averages. So, the company can consider their options on how to structure the data, and whether to move from normalized to denormalized based on the business goals. This may include additional application features, how fast the data team needs to retrieve data, and the different ways the data team uses the data. Our modern world is awash in data. It's everywhere we look, from the news feeds we read to the websites we visit. This data can lead to incredible business outcomes, but it can also be overwhelming and difficult to manage. If companies aren't careful, they can easily get lost, swimming in a sea of stormy data. To prepare you to navigate these complex waters, this video will explain data governance. This is a process for ensuring the formal management of a company's data. It helps organizations maintain data accuracy, reliability, and security. Data governance consists of several essential elements that work in concert. These are data policies and standards, data quality management, data privacy and security, and data stewardship and ownership. Let's check these out. Data policies and standards define the rules, guidelines, and procedures for data management within an organization. They establish the expectations for data handling, use, and sharing, ensuring consistency and adherence to best practices. Next, data quality management focuses on maintaining the accuracy, completeness, consistency, and reliability of data. It involves processes for data cleaning, validation, and ongoing monitoring to ensure that data meets predefined quality standards. Continuing on, data privacy and security are critical aspects of data governance. Activities here include implementing security protocols, access controls, and compliance with data protection laws. And lastly, data stewardship and ownership involves the assignment of roles and responsibilities for data management and oversight. It ensures that there are designated individuals or teams responsible for data governance activities. Data governance aims to achieve several important goals, which drive the effective management and use of data within an organization. First, it helps achieve data integrity and accuracy throughout the data lifecycle. By implementing data quality controls and validation processes, organizations can ensure that data is trustworthy and reliable. With the increasing number of data protection regulations, data governance also plays a crucial role in compliance. This enables organizations to establish policies and practices that align with regulations and protect privacy rights. Another key objective is to make data more accessible and usable for authorized users. This is made possible by implementing proper data classification, access controls, and metadata management. And data governance provides a foundation for making informed decisions based on reliable, timely, and accurate data. By enhancing the quality and integrity of their data, companies can realize more reliable insights and informed decision-making. This also leads to more robust security measures, reducing the risk of data breaches and privacy violations. This builds trust and can help protect the organization's reputation. With proper data governance, organizations can establish a culture of trust and credibility in their data-driven initiatives. And finally, data governance streamlines data management processes, reducing redundancies and inefficiencies. This leads to improved organizational efficiency and effectiveness when using data as a strategic asset. Maintaining data governance so that it stays on the right track is key to an organization's growth and success. So, let's go through a quick, suggested step-by-step guide on how to implement data governance. To begin, set clear goals and objectives for a data governance project. Then, get support from top leaders in the organization. After that, put together a data governance team with representatives from different departments, like IT, legal, finance, and operations. Next, clearly define the roles and responsibilities of the data management team and ensure that they know and understand them. Finally, create a data governance plan that includes policies, procedures, standards, and guidelines for data management. Once the data governance plan is created, it's time to invest in tools and technologies that will help automate and streamline data management processes. Train the data management team on how to use these tools and follow best practices. Keep track of how well the data governance plan is working with key performance indicators, or KPIs. Also, promote a data-driven culture where everyone values data and shares insights. And the processes, policies, and technologies used in the data governance plan should grow and evolve with the organization. And that's it for an overview of data governance. The ability to manage data assets is an essential skill for every data professional. The strategies you learned in this video will enable you to navigate a sea of data in your future role as a cloud data professional.
I was a special agent in the Federal Bureau of Investigation for 22 years. It was during that time in the FBI where I was assigned an investigation that included a cybersecurity element to it, and that's what I would call my pivot moment that really was the deciding factor for me I need to invest time, cycles, develop my intelligence on this, take courses, do whatever I need to do in order to get smart on it. My name is MK Palmore. I'm a director in the office of the CISO for Google Cloud. My team is responsible for helping customers onboard safely and securely into the cloud. I'm a child of the 80s, and for those of us in Gen X that come from that generation, everything in the 80s was really about the opening of the door to all things computers. Even families that, like mine, that were socially and economically disadvantaged, we even had opportunities to avail ourselves of computers and computing technology. And so this interest in computing and what it might evolve into, I think the seeds were planted. Cybersecurity is important in a cloud-first world because cybersecurity is the number one topic for business enterprise risk. I made a pointed decision on my own to change my career path and begin investing in the opportunity to learn and become educated in cybersecurity. The skill that I think is most important for cybersecurity practitioners is a willingness to understand that you don't know everything. I'm a huge supporter of certificate programs, certifications in the industry, because that is the pathway that I took in order to get educated. I feel that the more training that we can make available to a wider audience to give folks that opportunity to get educated in this field, I just think the better off we're all going to be. Cloud is probably the most exciting industry to be in right now because the possibilities, I think, are endless. The benefits of cloud to business, to individuals, to society overall, I think that that trajectory is still on an upward arc. So when you combine cloud with cybersecurity, and you think about it in terms of the availability of jobs in the job market, this is a market that will continue to expand for years to come.
Picture a data analytics team at a construction company. Every analyst has access to the organization's main database, but some employees require keeping datasets stored on their local hard drives because they do not always have the online access to the datasets. Unfortunately, when new data streams in about engineering plans or updates are made to their lumber and concrete inventory records, those employees with locally stored datasets will not have the updated inventory information. So over time, datasets will become outdated and error-prone. And when team members share data insights with stakeholders, there is a risk that results won't line up with what other analysts communicated. This business needs help. It's time for the data team to prioritize having a single source of truth. And that's made possible through Master Data Management. Master Data Management, or MDM, is a discipline and framework for managing and maintaining critical data assets in order to achieve a single consistent view of data across the organization. These critical data assets, also known as master data, include core entities like users, products, locations, and employees. There are 4 key components that work together to ensure effective MDM. The first is data governance, which is a process for ensuring the formal management of a company's data assets. Data governance establishes policies, standards, and guidelines for data management. It defines roles, responsibilities, and processes to ensure data integrity, security, and compliance. Second, data integration describes incorporating master data through different systems and applications. It ensures that data flows harmoniously, allowing different departments and systems to access and use up-to-date information and a single source of truth. Next, data quality management focuses on maintaining and improving the accuracy, completeness, and consistency of master data. It involves data cleaning, validation, and enrichment to ensure that data meets predefined quality standards. And lastly, data stewardship assigns responsibilities for data ownership, maintenance, and governance. Data stewards are accountable for ensuring data accuracy, resolving data-related issues, and promoting data governance best practices. MDM offers many essential business benefits. First, it improves data quality by establishing standardized rules, processes, and controls for data management. It ensures consistency in how data is captured, stored, maintained across systems, eliminating duplicate or conflicting information. With MDM, you can trust your data is accurate, up-to-date, and consistent. Second, it empowers data-driven decision-making by providing a holistic and complete view of master data. Having this accurate, consistent, and reliable information brings about well-informed decisions that drive business growth and competitive advantage. Maybe most importantly, MDM creates that single source of truth. It eliminates data silos and discrepancies, like the ones happening at the construction company. By synchronizing data across systems, everyone accesses the newest, most accurate, and most reliable information. This leads to improved operational efficiency because employees can rely on the data they work with. Likewise, by streamlining data management processes and eliminating redundancies, MDM saves effort, money, and time spent on costly mistakes, rework, reconciliation, and manual data entry. By implementing and supporting a master data management framework at your organization, you'll help your employer boost data quality and consistency, enhance accuracy, increase operational efficiency, and improve the bottom line. And that's the truth. Hello there, data fans. In a world where every click or tap leaves a data footprint at a website store, and a website visitor shares content like photos and video clips, an organization can end up collecting a vast amount of data to keep track of. This doesn't even include the internal data an organization amasses, like structured and unstructured data, reports, and more. In this video, you'll learn all about Data Catalog, a valuable tool for organizing data and getting data analysts on the right path to amazing insights. A data catalog is a centralized inventory of an organization's data assets. Think of it like a compass, guiding users through the data landscape and helping them reach the datasets and informations they need. It provides a comprehensive view of available data, enabling users to easily discover, understand, and use data assets. This level of visibility and accessibility is the foundation of efficient and effective data management. This means that all of the data your organization owns can be cataloged, making it easy to search and to find the exact piece of data you need. Let's say you work as a data analyst for a sports team. Your data catalog will include structured data, unstructured data, reports, dashboards and visualizations, and any automation and machine learning models you have created. What does this mean for how the sports team's management builds and grows the team and tracks the data they collect for each player? Structured data includes all statistics on player performance collected over the team's history. Unstructured data includes all the news articles, photos, social media content, and video clips captured by the organization. Reports may include payroll reports and player performance reports, while dashboards and visualizations may focus specifically on player performance. Finally, automations and machine learning models include attempts to make predictions about player performance. You have an incredible amount of data at your fingertips, and you would love a way to be able to search it all and build a profile for each individual player. A data catalog can help you make this search possible. Let's explore the key elements of a data catalog that make a data catalog an essential tool for any data-driven organization. One of the key elements of a data catalog is metadata. Metadata, or data about data, is a key to unlocking the data's true value. And data catalogs enable metadata management by organizing and storing important details about the datasets. Data catalogs also enable organizations to track the origin and transformation of data, ensuring reliability and accuracy. With the data lineage information supported by data catalogs, users follow the journey of data, identify any potential issues, and have confidence in its integrity. Data catalogs facilitate data governance by establishing policies, controls, and guidelines for data use, security, and privacy. Data catalogs advance collaboration by providing the centralized platform where users can work together on data assets and share insights. Okay, you've been working on a project to compile individual player data. You have had an easy time searching for a single player because the metadata allowed you to search an entire data catalog. Now, let's move along to the many benefits of data catalogs. First, the comprehensive metadata provided in data catalogs can enhance data understanding, leading to more accurate analyses, decision-making, and business strategies. Second, users can quickly locate and access important data assets. This helps data teams be much more productive. And by streamlining both metadata management and data discovery, data catalogs can decrease time spent on data preparation. Data catalogs also enforce data governance practices and safeguard data integrity, privacy, and security. This ensures organizations meet compliance requirements. Finally, data catalogs create a wonderful culture of innovation because they empower people organization-wide to become more data literate and, therefore, more confident sharing their ideas. I'm confident that you are discovering some great new ideas to share with your future data team as well. Data catalogs are just the beginning, so keep learning about how you can contribute to cloud data, no matter where your compass may lead you. Every time you search the web, your search results are built around something called metadata. The simplest browser search can return vast amounts of information describing each of the web pages in your search results, including the page titles, brief descriptions, keywords, and the sources or authors. This is metadata. Metadata is just data about data. And in the world of metadata, just as with a web search, the possibilities are limitless. So get ready to discover the true potential of your data. Metadata describes, organizes, and contextualizes data, making it easier to understand and use. Metadata works behind the scenes, playing a critical role in ensuring data is searchable and meaningful by a data analyst. Metadata encompasses various attributes that describe data. It includes details about data structure, format, origin, quality, and meaning. Think of metadata as the what, when, where, and how, providing crucial information about the data's characteristics and properties. There are a couple of different types of metadata that data professionals are most likely to encounter in their work. First is technical metadata. This focuses on the detailed aspects of data, like file formats, structure, source, and lineage, which is where the data has moved throughout a system and how it has transformed over time. Technical metadata is the foundation for seamless data accessibility, flow, exchange, and integration, ensuring compatibility and interoperability across systems and applications. The second type is business metadata, which focuses on data's context and meaning. Business metadata includes the meaning of the data, associated business rules, and information about data ownership and relationships. It provides the necessary context to understand the significance and relevance of data in context of business objectives. Business metadata provides a business-important context and enables data-driven decision-making. It helps bridge the gap between technical complexities and business requirements. These two types of metadata are complementary, together forming a comprehensive approach to managing and using data effectively. But it's still very important to be able to distinguish between them. So, keep in mind that technical metadata focuses on the details, while business metadata provides the business context and meaning. Thank you for joining me in this exploration of metadata. Data about data can feel a bit complex, so being able to use metadata to describe and understand information is going to be a valuable skill for your future cloud data career. Hi there! Thanks for joining me in this video all about data lakehouse architecture. Here, you'll review the history of data lakes and data lakehouses, and take a deeper dive into how data lakehouses can increase a data team's agility when creating reports, dashboards, and queries. Now, you'll first check out a quick history lesson. In the early days of data analytics, the term data warehouse emerged to describe the architecture used to store and organize data. This analogy likened the warehouse to a large organized storage space. Companies need to store thousands of terabytes of data, including tricky unstructured data like product reviews, social media posts, images, and near real-time data streams. As a cloud data professional, your organization may already have their data lakehouse in place, but it will help you to know about the selection and building of data lakehouse architecture so that you're aware of how your database works and how your data moves. An architecture is a framework that defines the design of a technical solution. This includes various components and technologies that are arranged to let organizations pool, share, and scale resources over a virtual network. For your purpose, a data warehouse architecture defines the data structure, from the data ingestion to the data presentation. Data ingestion is the process of obtaining, importing, and processing data for later use or storage. Before we explore data lakehouse architecture, let's start with the data warehouse. The architecture for a data warehouse relies on the idea that all data is routed to a single area, the data warehouse. The basic architecture of a data warehouse includes the data sources, the extract, transform, and load, or ETL process, ingestion into the data warehouse, and moving to visualization, business intelligence, and reporting programs. Now that you have a basic understanding of data warehouse architectures, consider what might happen in an organization with continuous streams of data. As technology advances and the internet becomes more common, the speed, volume, and variety of data increases exponentially. As the amount of data increases, traditional data warehouse limitations become apparent to the data team. To address these challenges, data teams developed data lakes. A direct contrast to the highly organized data warehouse, data lakes are unstructured, fluid, and vast. A data lake is a database system that stores large amounts of raw data in its original format until it's needed. Data lakes are composed of cost-effective storage systems that accumulate vast amounts of data. Rather than carefully planned table structures with rows, columns, and limited data types, data lakes typically use a file system with folders that are named for each set of data. Data lakes make data ingestion easier and facilitate quicker access to data. But quality and consistency become more difficult to ensure within the unstructured data lake environment. Enter data lakehouse architecture, an approach that combines the best features of data warehouses and data lakes. A data lakehouse stores data in its native format, maintaining the accessibility benefits of a data lake. And a data lakehouse incorporates structured elements and organization, similar to a data warehouse. This ensures data quality and consistency. You'll notice that some of the components and technologies in a data lakehouse architecture are also found in a data warehouse architecture. The data lake architecture starts with all data and moves into the ETL process. From here, the data moves into the data lake. Then, it is transformed before moving into a data warehouse, a visualization program, or into a machine learning model. Next, here are some of the data lakehouse architecture advantages. First, it provides scalability, enabling businesses to store and process vast amounts of data without requiring additional hardware or software to transform it. Second, it offers flexibility, allowing companies to leverage various data tools and technologies without compatibility concerns. And it saves money on storage and processing costs. That sounds great, right? But what happens if you have a need for a structured data warehouse? You can have a two-tier architecture that includes both a data warehouse and a lakehouse. Data lakehouses empower organizations to store, process, and analyze data in a much more efficient way. This is only possible because data lakehouses are built on an effective data architecture. And by understanding that architecture, you've now added another building block to your own well-designed data career. Architecture is the art and science of designing buildings and other physical structures. It encompasses everything from conceptualizing initial design to overseeing construction. This video is all about architecture, not of buildings, but of data, and in particular, data lakehouses. Let's begin with the significance of data lakehouse architecture in modern data management. Data lakehouse architecture is a comprehensive approach to managing and analyzing data. Data lakehouse architecture combines a data lake with a data warehouse. The data lake is a repository of data in its original form, and the data warehouse is organized sets of structured data. The lakehouse allows you to combine both of these, structured and unstructured datasets, into a single platform. Since the lakehouse combines two data structures, the architecture is crucial to developing pipelines. An architecture is a framework that defines the design of a technical solution. The architecture of a data lakehouse combines two separate platforms. It also allows you to connect all of your tools to a single data source. There are 5 layers of a data lakehouse architecture to keep and organize all the data. These include ingestion, storage, metadata, application programming interface, or API, and consumption. Think of these as the building blocks for any data lakehouse architecture. Let's review an example of what goes into each of these layers. First is the data sources layer. This includes structured, semi-structured, and unstructured data. Then there is the ingestion layer, which can bring all of these data types into the data lakehouse, either through batch or streaming processes. Next up is the storage layer. In this layer, some data goes into the data lake, and other data goes through ETL and into the data warehouse. From here, our data goes through a metadata layer, where governance rules are applied and indexing occurs. From here, APIs are used to abstract and simplify data and metadata access for the final layer. This is the consumption layer, where business intelligence, visualizations, and machine learning occurs. As a data cloud professional, once you add the data to the data sources layer, let's follow what happens in each of the other 5 layers in a little more detail next. The primary purpose of an ingestion layer is to pull data from the data sources layer and deliver it to the storage layer. In some cases, this is just using batch and streaming strategies to move data into the data lake. For structured data, you may implement an ETL structure and move data into a warehouse. By leveraging scalable storage, you can efficiently store structured, semi-structured, and unstructured data in the data lakehouse. This versatility allows you to seamlessly integrate diverse data sources and ensure that no valuable information is left behind. The metadata layer plays a major role in ensuring data integrity, privacy, and compliance. This includes data governance, metadata management, data quality, and security. One of the key strengths of the data lakehouse is the metadata layer. It catalogs all of your data, both structured and unstructured, and data in your data lake and your data warehouse. Next up is the API layer. This layer is designed to help you integrate APIs that process tasks faster. This is also the stage where you might integrate machine learning. Finally, there is the consumption layer. This layer provides you tools and interfaces to extract valuable insights from the business's data. Business intelligence tools, including visualization dashboards and querying interfaces, give you self-service analytics capabilities, so you can easily explore the data, create reports, and gain near real-time insights. Data lakehouse architecture offers a transformative approach to managing and maximizing data. It combines scalable storage, powerful compute capabilities, effective control, and user-friendly business intelligence layers. And your data lakehouse know-how will help you empower any future employer to make the most of each of these valuable features. Congratulations! You've reached the end of another section of this program. Through these topics, you explored data organization, data governance and data lakehouses, and the various aspects of data organization that can affect decision-making processes. First, you discovered the basics of normalized and denormalized data. Then, you were introduced to data governance, technical and business metadata, and master data management. Next, you explored the components and types of data catalogs. Last, you learned about the benefits of data lakehouse architecture and how a data lakehouse can transform an organization's data management. Awesome job on your progress so far. Can't wait to catch up and see you again in the next section. Hello and welcome to the next section of this course. I'm excited to guide you through these topics all about exploring and finding data. One of the coolest things you're going to do is query large amounts of data in BigQuery. This is going to be incredibly valuable for your future career in cloud data analytics. In addition, you'll discover proven methods for tracing data to its source. And you'll learn how to access and explore data libraries. First, you'll get right into an example of how to find data using BigQuery. This is essential. After all, you can't analyze data if you can't find it. Next, you'll learn what it means to trace a data source and how to use data lineage, a feature that helps a cloud data professional follow their data's journey through the systems, where the data came from, where it went, and what changes were made along the way. Then, you'll get an introduction to Analytics Hub and all the tasks you can perform. Finally, you'll explore data discovery, curation, and unification, as well as why they're important in the cloud setting. Once you've finished this section, you'll have the know-how to effectively use these tools to find data. And I'll find you in the next video.
What gets me excited about my role is being able to design some of the largest data systems in the world. Hey, I'm Ryan. I'm a cloud data engineer here at Google Cloud. What I love about working in this field is peeling back the covers on technology and data systems and being able to understand what is actually driving decisions and driving the services that I use on a daily basis as an end user. As a kid, I was always curious about how things worked. And within my role as a cloud data engineer, I look at data and try to derive insights out of it. And with that curiosity that I developed as a kid, I'm able to apply that to my daily role where I'm always looking for how to connect different data sets together to help derive better business value for customers. When I was a young software engineer, I was always met with resistance with trying to push the boundaries within the organization that I was in. I was always interested in trying to find new ways of doing things, new technologies to apply to common problems. And throughout my career, I sort of found my path in innovating along the way to actually satisfy that itch for curiosity and innovation. At the time, I was making a career transition into a cloud-based role. And in order to prepare for that role, I did a lot of reading tutorials, a lot of watching YouTube videos. And then I also built my website on the cloud itself to help me stand out from the rest of the applicants for the role that I was applying for. And that really helped me understand a little bit more about cloud services and helped me ramp up along the way. I feel like I have a large impact within my role because the customers that I work with are able to provide new features, new insights, and new data to their customers. I face a significant challenge working with a customer in the health industry because the health industry has very high stakes because the decisions that you make directly impact people's lives. We had to make sure that our design was very, very comprehensive and that we had exhausted all different points of failure such that we were able to ensure that when we went live with the system, that we were very, very confident that we weren't going to encounter any issues. The margin of error was very, very small. If we didn't deliver a notification to somebody who needed a notification at that time, they wouldn't be able to take the appropriate action, such as getting their child to the hospital or getting their child to a doctor. That experience helped me grow in my role because it taught me what it takes to deliver on a solution and to never give up. Ultimately, at the end of the day, you're not going to always have the answer from the beginning. And to be able to navigate through complexities and be able to learn along the way really taught me about perseverance. The advice that I'd give to someone starting within this career is to stay curious. There's always so much to learn. And so just having that natural growth mindset or that curiosity really helps you develop and become a better data engineer.
Humans are usually intrigued by finding out something's origin or source. Sometimes we investigate things to better appreciate their meaning and significance, like a cultural tradition or a work of art. Other times, we check things because we care about certain issues, like confirming our food was grown sustainably, or that the products we buy were manufactured ethically. Knowing where things come from is also important in the data world. This is because understanding a data source's lineage that clearly shows where the data has moved throughout its life cycle and how it has transformed over time ensures its integrities and lets data professionals share insights with confidence. So, what exactly is a data source? A data source is a place where data was generated. Data sources can take various forms, including databases, application programming interfaces, file, or even streaming platforms. Databases usually hold structured sets of data and store and manage large volumes of data. Application programming interfaces, or APIs, are used to gather data from external systems, like social media feeds. Files can come in many types like Excel, CSV, or JSON files. These types enable the import and export of data between systems. Streaming platforms provide a steady flow of live, current data that can be collected and processed for near real-time analysis. For example, analyzing near real-time user interactions on a website. This wide variety of data sources can create challenges related to compatibility, integration, and understanding the data. Each one requires a unique approach, so it's important to understand what they are used for in order to use them most effectively. All right, so tracking lineage for data sources involved following data from its point of origin to its current state in order to better understand where it's been and how it may have been affected along the journey. Determining lineage for a data source can also lead to better understanding of the context surrounding the data, provide traceability, and help audit its reliability and accuracy. And it helps data professionals ask better questions and make informed decisions. Maybe most importantly, data lineage provides a clear understanding of its authenticity, quality, and integrity, and it helps organizations maintain control over their data assets. This is why data tracing is so important to data governance, compliance, and regulatory requirements. Just like reading the label on your food or researching a company before buying its products, data lineage and traceability provides critical transparency, accountability, and trust. And as data really does shape our world, it's essential for you as a cloud data professional to analyze and verify the data. In your data career, working with trusted data will help your business achieve better outcomes. Just one of the many reasons why data professionals are so incredible. The world's oldest continually operating library is thought to be in Fez, Morocco. Opened in 859, its maze of rooms holds thousands of rare books and manuscripts containing information about people, philosophy, medicine, astronomy, physics, mathematics, law, and much more. Today, people visit this library from all around the world to glimpse these fascinating texts. Databases are kind of like modern libraries. Instead of being filled with books, they're filled with data. And just as people visit a library to find books about anything and everything, databases enable users to locate diverse datasets. One such resource is Google Analytics Hub, a data exchange and library of internal and external assets. In this video, you'll learn all about Analytics Hub, its architecture, user tasks, and more. Let's get going. First, just like you can use a library's catalog to search and check out books and other media, Analytics Hub organizes and secures data, then helps users find the data they need for an analytics project. Acting as a connector between producers and users, Analytics Hub provides a process of sharing and using data among organizations while ensuring safety and privacy. Analytics Hub is built on a publish and subscribe model of BigQuery's datasets. This means data producers, or publishers, make their datasets available to data consumers, or subscribers. The separation of compute and storage enables data producers to share data with many users without having to duplicate it. Data producers only pay for the space to store data, and consumers only pay when they access or run queries on the shared data. So, a data publisher first identifies the dataset they want to share in BigQuery, then creates a listing of the datasets in Analytics Hub. After the listings have been published, they manage the use of their shared datasets. After a subscriber browses Analytics Hub to find a dataset, they can subscribe to it. Then, a read-only link to the dataset is made available in the subscriber's BigQuery project. Now they're ready to query the data. There are three key data management features: shared dataset, data exchange, and listing. And the subscriber workflow has a fourth feature called the linked dataset. Let's check these out. Shared datasets are collections of data, tables, and views that data publishers share in BigQuery. Data subscribers receive a version called a linked dataset. This is similar to any other BigQuery dataset, but it's read-only. In this way, the dataset always remains the same, and the subscriber doesn't have to pay to store it. Also, each piece of data is uniquely identified as a listing. These listings include a link to the dataset, a brief description, and related documentation. Data exchanges can either be open to every user or restricted to certain users, with exchange administrators managing who can access the data. By default, the exchanges are set to private. Now, let's discuss what users can accomplish with Analytics Hub. There are 4 main types of users: publisher, subscriber, viewer, and administrator. First, an Analytics Hub publisher can generate income with instant data sharing within their organization or with network partners. It can also use listings to share data without creating duplicates. Also, an Analytics Hub publisher can build a catalog of data sources ready for analysis and create detailed permissions that ensure the data reaches the right users. And it can manage subscriptions to the listings. Next, there's the Analytics Hub subscriber, who can merge shared data with existing data. And when a user subscribes to a listing, a linked dataset is created in their BigQuery project, and they can use built-in tools in BigQuery to analyze the data. Then, there's the Analytics Hub viewer, who can browse through datasets and ask for permission to use the shared data. And finally, there's an Analytics Hub administrator who can create data exchanges that enable data sharing and give access permission to both data publishers and subscribers. Now, there are a few Analytics Hub limitations for publishers to be aware of when using Analytics Hub. We'll discuss just a few now. First, if a publisher creates a listing for a shared dataset that's encrypted for more control over key operations with a customer-managed encryption key, subscribers won't have the cloud key to access the dataset. Second, there is a limit of 1,000 linked datasets to a shared dataset. And third, when creating a listing, a dataset with unsupported resources can't be shared. For example, not all routines are supported in shared datasets. And there you have it. Analytics Hub connects those who create datasets with those who need datasets. And just like a library with thousands of interesting titles, Analytics Hub offers tons of well-managed and easily accessible datasets. As a cloud data professional, you'll benefit from the process of being able to share and use data among organizations. In today's data-filled world, many industry professionals like to think of information as the currency of business success. But a big challenge is separating the data gems from the pebbles to find the insights that will empower effective analytics. In this video, you'll learn how to make your own data sparkle with key tools and techniques for managing and maximizing data in the cloud. But first, some fundamentals. To lay the groundwork, we'll need some data discovery. This is the process of finding and understanding data assets within a dataset or data ecosystem and identifying relevant patterns and relationships. For data discovery to work well, you need the right tools, and you need to understand what a business wants to achieve. But if you know what questions to ask and what insights to look for, you can help a business make the most out of their data. The next step is data curation. This is the process of selecting and organizing data to ensure it's useful and of high quality. Curating the data creates a solid foundation for analysis and decision-making. Data curation is a critical part of the data analytics process because it also involves data preservation and access, which preserves data for future use and makes data available for those who need it. Then, data unification is the process of integrating data from diverse sources to create a consolidated view. Usually, data exists in different formats and locations, making it challenging to analyze comprehensively. Data unification brings together disparate data sources, harmonizes their structures, and enables holistic analysis. Data unification ensures that data analysts are working with a complete and single view of all data, which leads to more accurate insights and better decision-making. All right, now let's explore the benefits of data discovery, curation, and unification in the cloud. The cloud offers unique advantages that can revolutionize your data management and analysis processes. One significant advantage is scalability. Resources can easily expand or contract based on data discovery, curation, and unification needs. When working with a small dataset or a massive data ecosystem, the cloud provides the flexibility to adapt to user requirements. Access is also a key benefit of cloud-based data management. Cloud solutions allow seamless access to data discovery, curation, and unification tools from anywhere, at any time. This supports collaboration and remote work while breaking down geographical barriers. When it comes to data discovery, curation, and unification, cloud-based technologies also bring powerful automation capabilities. Consider the process of data curation. In traditional data management, curating large datasets can be time-consuming and resource-intensive. But with cloud-based automation tools, these tasks are streamlined by automatically identifying and resolving quality issues, performing data transformation, and applying predefined rules and policies. This accelerates data management and analysis workflows. The cloud also provides security measures and compliance frameworks to protect data during discovery, curation, and unification. Cloud service providers prioritize data security and offer advanced encryption, access controls, and regular compliance audits. This ensures the confidentiality, integrity, and availability of your data. And of course, all of these benefits combine to equal some serious cost savings. With all of your organization's cost savings, you'll have even more resources to dedicate towards finding more of those sparkly data gems. Have you ever read an ad that claimed a certain percentage of dentists recommend a particular chewing gum? Or that the majority of people in a taste test like the flavor of one pasta brand more than another? The numbers can be compelling and might even make consumers want to purchase these products. But statistics should always be regarded with caution. In particular, it's essential to consider the context in which they exist. Without context, data can be both meaningless and misleading. Maybe the dentists who participated in the survey weren't given the option to choose no chewing gum at all. Or maybe they were presented with just a few brands to choose from, rather than all the gum on the market. Likewise, the people taking the taste test can easily be led to a particular direction by the pasta company. For example, just displaying one dish in a more appetizing way than the others can influence a taster's decision. Context is the condition in which something exists or happens. It's all about the surrounding circumstances affecting the data, like the specific questions asked in the dentist survey and the way the pastas were presented. In the same way, identifying the context surrounding a dataset is crucial for meaningful and truthful analysis. Dataplex is a centralized data catalog that unifies search and data discovery, which helps data professionals understand the source of data. Dataplex simplifies the process of data source identification, as users can easily navigate through complex data environments to find just what they're looking for, and confirm that it's reliable. Dataplex provides a centralized hub where users can explore, catalog, and manage data assets. They gain a comprehensive view of the data ecosystem, enabling informed decisions and valuable insights. Dataplex provides a user-friendly interface for exploring data sources within BigQuery. BigQuery allows users to store and analyze massive datasets. It offers fast query performance and scalability, making it ideal for handling large volumes of data. To use Dataplex to identify data sources in BigQuery, first, log in to the Dataplex platform. Dataplex scans many data sources automatically within Google Cloud, so you can start exploring right away. So, you want to find a dataset. Click on the Dataset tab and browse through the datasets that appear. If you already have a dataset in mind, start typing its name, or even just the first letters, in the search bar. Then click Search. A list of datasets will appear, and you can easily select the one you want. You can also filter data assets based on different criteria. If you head over to the Filter section, there are some cool options. If you want BigQuery datasets, then select BigQuery and Datasets. Instantly, a list of BigQuery datasets will appear. But if you're interested in tables, you can filter further by choosing BigQuery and Tables, and you'll get a list of just BigQuery tables. This is a quick and easy way to find exactly what you want. Once you've selected a data source, you can examine its metadata to better understand its structure, how the data is organized, stored, and connected, its schema, a blueprint of how the data is organized within the data source, its lineage, a history of the data's journey, and other important details. Keep exploring the capabilities of Dataplex to make sure you know how to identify and select meaningful and trustworthy data sources. Whether your data analysis project is about chewing gum, pasta, or anything else, knowing the context of each and every dataset you use will be an essential part of your future career. Check out the progress you've made. You're almost done with this section of the course. In the previous section, you explored how to find data in BigQuery. Next, you explored what a data source is and how data lineage and traceability is useful. Then, you investigated Analytics Hub, its architecture, and common tasks that you can perform as an Analytics Hub user. Finally, you shifted to data discovery, curation, and unification. You also got a close-up view of Dataplex and the importance of identifying data context. Congratulations on an important milestone in your voyage to data analysis in the cloud. Hello there, data virtuoso. I'm so glad to be with you again. Today, we're going to learn about accessing data using cloud tools. You'll discover how to interact with data tables and use optimization techniques to improve your queries. You'll also use cloud-based data lakes and data warehouses to link up with helpful data sources and answer important business questions. Okay, now let's check out exactly what's coming up. First, you'll explore data patterns and how to create table schemas in BigQuery. Then, you'll get an intro on tools for Google Cloud integration, like Vertex AI and Google Colab. You'll even explore some fascinating machine learning concepts. Then, you'll work with partitioned tables, which are large tables divided into smaller segments, and gain some great strategies to help you better understand the many benefits of partitioning. After that, you'll discover how to manage partitioned tables with information about data subsets and query partition tables. Finally, you'll end with an exploration of Dataproc for scripts, managing Dataproc clusters, and more. This section is full of information that will prepare you for the next exciting steps of your data career. So let's get started. Hello and welcome to this video about table schemas in BigQuery. Schemas are one of the most important tools for data professionals. They help describe how data is organized, which provides a lot of valuable clarity, context, and structure. And structuring data is an important part of ensuring that it's usable. Here's an example. Maybe a data team at a commercial real estate agency is tasked with compiling surveys from clients who have recently leased a commercial property. The inputs on the surveys include scaled responses. Clients rank the effectiveness of real estate agents from 1 to 5, or least effective to most effective. The survey also includes questions that have a true or false response option. And the clients are invited to add comments in open response questions. When an analyst begins to compile the data, they decide that they want to import all of the data about every agent into a single table. To complete this import, they will need to create some sort of organization and structure for the data. They need a schema to create this table. A schema is a way of describing how something, like data, is organized. A database schema is a way of describing how an entire database is organized, including all of its tables and their relationships. A table schema is a way of describing how each individual table within a database is organized, such as its columns and data types. There are 3 primary ways that database schemas are created. First, as a data analyst, you can create the schema as you load the data into a table from the Google Cloud Console. Then you assign the schema in the console. To design the schema in the console, provide each column's name and data type. For each field, use the Add Field option and specify the field name, type, and mode. You also need to know what columns the data has before you begin. Or, if creating a new table without any data, it's important to have a plan for the columns the data will have as it's collected. The second option you have to create a schema is to use schema auto-detection. This is a feature in BigQuery that infers the schema based on CSV, JSON, or Google Sheets data. Just import the existing data, and BigQuery will figure out the schema. To set up schema auto-detection in BigQuery, select Auto Detect Schema when creating a table. Then, BigQuery determines the data type for each column. BigQuery determines the data type for each column by selecting a random file in the data source. Then, it scans up to 500 rows of data to create a representative sample. Once complete, BigQuery assigns a data type to each field based on those values. Pro tip: It's always a good idea to check the Google Cloud Console or the command line to confirm the accuracy of the data types assigned to each field. All right, now the third option you have to specify a data schema is to use a JSON schema file. This file includes the column name, column mode, column data type, and column description, and can be used when creating a table from the command line, but cannot be used from the console. To create a new table from JSON file with schema auto detection, in the BigQuery Explorer pane, click Create Table in the Dataset Info section. In the Source section, select Google Cloud Storage under the Create Table From section. There, you can select your JSON file. Be sure to select JSON EL under File Format. If you'd like to auto-detect the schema, you'll select Auto Detect. And that should do it. You should have your JSON data uploaded in BigQuery in no time. So, returning to the client surveys, it's now time to ingest them. The data team decides to use schema auto detection. They upload all of the data, and BigQuery creates column names for each of the datasets. But after reviewing the results, the data team supervisor suggests having a bit more control over the column names. No problem. One of the analysts just recreates the schema with Google Cloud Console. Perfect. Now the schema is working great. The commercial real estate agency is able to easily understand agent performance and provide any helpful feedback or training to make the client experience even better. And now you know several ways to create a database schema, making your data analysis experience better as well. You're on your way to structuring data in a meaningful way, and you have more experience working in the Google Cloud Console and BigQuery. Great work. Hello. Let's start this section by thinking about language. One common aspect of many languages around the world is dialects, which are variations in a language that may present in grammar, vocabulary, or pronunciation. The data field also has dialects, especially when it comes to programming languages. Programming language dialects are typically very small differences that don't change the intrinsic nature of the code. One of the most popular programming languages is SQL, usually referred to as SQL. SQL works with many different databases with some minor variations. So learning the basics will give you a great foundation for programming with SQL and setting up database tables. And that's what you're going to learn in this video. Okay, to start, a SQL dialect is a version of SQL that's unique to a specific database. It's important to recognize that all SQL languages have the same basic structure as standard SQL. For the most part, the key commands are identical or very similar, but there may be a few differences in the syntax across the various dialects, or small differences in the code. Syntax is a predetermined structure of a language that includes all required words, symbols, and punctuation, and their proper placement. Commands are an important part of SQL syntax. And as a data analyst, as you learn to construct SQL syntax, there are 4 basic commands that you need to know when working with data: retrieving information, selecting columns, sorting, and creating a table or database. Retrieving information involves pulling information from a table. Statements used to retrieve information include select, from, and where. Select identifies the needed information. This is done by selecting either individual columns or all columns. From identifies which table to use, and where adds conditions on the data being returned. For example, requesting only data that contains a certain value, or only data with a particular keyword. Now we select columns. This requires both select and from statements. Select identifies the column, and from identifies the table that the column should come from. Great. Now we've come to sorting. To sort data, use the same first 2 statements, select and from, to identify the column of data to be retrieved. Then, the order by statement specifies which column to sort by. Order by will automatically sort in ascending order. If the DESC command is added, order by will then sort in descending order. Finally, Let's check out how to create a table using SQL. To do this, type create table. Then, list all of the column names and describe the type of data to be found in each column. The data type of a column defines the kind of data that can be stored in it. This is important to ensure that data is stored efficiently and that you can query data correctly. Common data types include numeric, string, and Boolean, to name a few. The exact data types available may vary depending on the SQL dialect that you use. Let's try this out. Imagine you want to create a table in the customer's dataset called customer names. This table will have two columns, customer ID and customer name. The customer ID column will store a unique identifier for each customer. This column will be of type int64, which is a numeric data type that can store large numbers. This makes it a good choice for storing identifiers, which are typically large sequential numbers. The customer name column will store the customer's name. This column will be of type string, which means that it can store text data. This is a good choice for storing names, addresses, and even phone numbers. When you run this query, an empty table called customer names will be created in the customer's dataset. This table will have two columns, customer ID and customer name, and each column will store its own type of data. Nice! You now know the foundation of SQL dialects. These simple commands will set you up for successful interactions with whatever database you encounter. As a new data analyst, working on a variety of databases helps you better understand SQL dialects and makes it possible for you to contribute useful code right away. Data holds the key to transforming industries and shaping the marketplaces of the future. Add to that the exciting power of machine learning, or ML, and you can open a whole new world of insights and groundbreaking advancements. But there's a catch. Traditional methods of data analysis, like statistics, limit the potential of ML. In this video, you'll learn some simple steps for using cloud computing to take ML to the next level. But to start, consider the definition of machine learning. Machine learning is the use and development of algorithms and statistical models to teach computer systems to analyze and discover patterns in data. ML algorithms and models rely on vast amounts of high-quality data to make accurate predictions and drive smart decision-making. Accessing the right data at the right time is crucial for the success of ML projects, and that's where the cloud becomes a game changer. To consider how this works, let's consider a real-world example with a data analyst named Zane. Zane's organization wants to predict annual farming yields in an agricultural community. But his organization has only been tracking crop yields from public datasets that include communities all over the country. He doesn't have any information about crop yields in your community. Zane knows that he'll create a machine learning model to help with the prediction, but he's missing some data. This is where the cloud comes to the rescue. Zane can request datasets from various organizations, and he can use these datasets to train his ML models. In this case, he'll ingest data from internal datasets from local farmers and from the National Weather Organization. Zane will take data about both forecasts and actual reports, and he'll use that to start to train the model. Pro tip, datasets from private organizations sometimes require coordination to access. After you've received permission to access, you'll need to find a way to transfer the data. As you start to work with machine learning models, you may find that the datasets you access provide the reference points you need to train your models. Now, let's get back to Zane. It's time to get the necessary datasets. First, he chooses the appropriate cloud service provider based on his organization's particular needs and requirements. Then, he sets up the necessary credentials and permissions to ensure secure access to your data. Finally, Zane establishes connections to the data resources. Before you ingest data from external datasets, you first need credentials. Credentials are similar to a login that you'd use on a personal account. These are a username and a password. An organization may give you credentials that allow you to access and transfer data. Once you have credentials, you will need to use an interface that allows for the transfer of the data from an external organization to your own. There are a few interfaces you may come across in your work: login credentials, application programming interfaces or APIs, and software development kits, or SDKs. Each of these interfaces allows you to ingest data directly from an external dataset to your own dataset. An API is a protocol that enables one application to interact with another application. In your case, you'd use an API to access and transfer data. An SDK is a set of software building tools that include groups of code libraries. As a data analyst, you might use an analytics SDK to access data about users and their interactions with your software. For Zane's work with the crop prediction model, he is able to access an API. This allows him to transfer data directly from the national agriculture databases and into his own database. Ingesting data directly can streamline your process and create a direct pathway to your machine learning model. This means your model can get to work. At this point, you can select a common model or create your own. And the best part is, once you set the initial parameters, your model will be able to train itself. Okay, now let's check out some common types of models you can create with machine learning. First is a classification model. You may train a classification model to classify items or group items into a predefined category based on common characteristics. This could be as simple as determining whether something is a mammal or a reptile, or as complex as determining whether a new product is likely or unlikely to sell. Next is a clustering model, which involves grouping data points that are similar to each other in some way. In this instance, machine learning will decide how to group items together based on similarities determined by the model. For example, you may try to determine what geographic area has customers that are the most likely to purchase products. Another type of model is a linear regression model. Linear regression is a technique that estimates the linear relationship between a continuous dependent variable and one or more independent variables. With linear regression, you may try to predict sales, or even the amount of rain that might fall next week. Finally, there are ranking models. A ranking model uses characteristics to order items by likelihood. For example, entertainment streaming services use ranking models to recommend music or movies that customers are likely to enjoy. These models try to find similarities in what users listen to or watch, and rank new entertainment options by the likelihood that users will enjoy the content. So, back to Zane's crop prediction. After reviewing the data, he uses a regression model to try to predict the amount of crops his town can expect to produce in the upcoming year. So, now he has datasets, and he knows what type of machine learning model he will use. Zane is well on his way to building a model that can predict which years will have the most crop production. The cloud is your gateway to data access, and to maximize the incredible capabilities of ML. By working with the cloud, you'll ensure ML can continuously improve its own models. Keep exploring the world of data-driven discovery. Machine learning, or ML, is really incredible. It has so many capabilities. For example, it can identify objects and photos and analyze medical images. It can understand and process natural language for chatbots, voice assistants, and translations. And it can recommend products, services, and content to help users find just the right online store, movie, or new playlist. In your data career, you may have the opportunity to train and deploy ML models. To prepare you for this really cool opportunity, this video will explore Vertex AI, an ML platform, and how it combines with BigQuery for data collection. But first, the definition of machine learning. ML is the use and development of algorithms and statistical models to teach computer systems to analyze and discover patterns in data. ML helps data professionals make better decisions, automate processes, and uncover valuable insights. Vertex AI takes ML to the next level by providing a comprehensive platform for developing, deploying, and managing ML models at scale. It allows you to use machine learning operations to manage and govern all of your ML workloads. This means that your data enters and moves through your pipeline quickly, so you can focus on innovating. For example, consider an online store and worldwide marketplace that sources products from other sites and personalizes search returns based on users' past activity. You're a new data analyst at this online store, and your team is responsible for increasing the accuracy of projected ship times for each product. In the past, Your organization has built machine learning models and ingested data monthly to update projected ship times. But this process is slow, and usually the monthly updates provide customers with inaccurate projections. One of the first projects that your team tackles is moving the on-premises data warehouses into Google Cloud. From there, your team develops a pipeline to ingest new data in near real time, and that is scalable when there are influxes or reductions in data. Once your data is prepared and made available for ML, your team's next step is to automate hyperparameter tuning. Hyperparameters are parameters whose value is used to control the learning process. This is the part where the power of machine learning begins and the model starts to update itself. Your team will set the hyperparameter metrics you want to optimize before the machine learning process begins. This will help the model to train itself. Even more exciting, with Vertex AI, your team can accelerate the hyperparameter tuning, as Vertex AI will auto-adjust your hyperparameters to help you determine the best values to set. Next, your team will focus on updating the delivery time predictions. Your team can rely on Vertex AI to automate your machine learning models and update predictions. Given the hyperparameters, your team's model will constantly update itself using the data that pours into your organization's site on a daily basis. There are a couple of options for moving your organization's on-premises databases into the cloud. One option for cloud data storage is BigQuery. BigQuery provides powerful querying and data access capabilities. You might have already learned about how you can use BigQuery to access your data. But BigQuery also has built-in machine learning capabilities that you can use to build ML models directly within the platform. In an on-premises database, or a physical server that houses your database, you would need to have advanced programming knowledge and access to specialized frameworks to develop your ML model. With BigQuery, you can use your SQL knowledge to develop machine learning models. Let's go back to the online marketplace. You and your team solved the problem of calculating shipping times. Now, you can use BigQuery SQL to solve another problem. Your team needs you to generate a daily report of projected sales for the next day. You know that you'll need constant data input and a model that projects sales every 24 hours based on multiple inputs, including products, past sales by date, past sales by hour, and past sales on holidays. You use BigQuery's built-in linear regression model to forecast sales on a daily basis. Linear regression is a technique that estimates the linear relationship between a continuous dependent variable and one or more independent variables. You can input your information, including products, past sales by date, past sales by hour, and past sales on holidays. Then, using SQL, you can create a model and use the pre-built linear regression model. BigQuery will get to work. Now, you have access to daily reports about projected sales. And the best part is, as more data is input, your model will train itself and become even more accurate. Machine learning is a super valuable technology that can be used to answer all kinds of questions and solve a wide variety of problems. And with automated options, you can build and upkeep your own models easily. Welcome back. You may have noticed that a lot of work with data is done with a team. Sometimes the tools we have may not be dynamic enough for teams to work collaboratively. The good news is that Google Colab can help with that. In this video, you'll learn about Colab. You'll also discover how Jupyter Notebooks and Python make the capabilities of Colab even more amazing. Let's get started. Colab, or Colaboratory, is a cloud-hosted version of Jupyter Notebooks that allows users to write and execute Python in a browser with no configuration required. Data analysts working in Colab have access to graphics processing units for free, and their work is easily shareable. The two main contributors to Colab are Jupyter Notebook and Python. Jupyter Notebook is an open-source, web-based platform for creating and sharing documents that consist of code, equations, narrative text, and visualizations. It can be used for many tasks, like numerical simulation, machine learning, and data visualization. Jupyter Notebook, or Jupyter, is most frequently used within a Python environment. With Jupyter, data professionals can write in multiple programming languages, including Python, Java, R, Julia, MATLAB, Octave, Scheme, Processing, Scala, and many others. Jupyter is also used for data visualizations, bash scripts, markdowns, and mathematical and scientific notations. Python is an object-oriented programming language. It's flexible and easily adaptable to changes, which makes it a popular tool for data analysts. Python is the primary programming language used in Colab, and users write Python code through most popular web browsers, including Google Chrome, Mozilla Firefox, and Safari. Then, users can run their code on a browser without a command line interface or runtime environment. Colab notebooks allow users to combine executable code and rich text in one document, along with images, HTML, LaTeX, and more. After creating a Colab notebook, it's stored in the user's Google Drive. The notebooks can be easily shared with collaborators, who can then add edits or comments. In the data field, data analysts use Python libraries for data analysis and visualization with Colab. Python libraries are collections of code that can be used to automate some functions. They can import data into Colab notebooks from spreadsheets and many other sources. Machine learning programmers also use Colab for their data work. They can import an image dataset, train an image classifier with that image, and assess the model with just a few lines of code. And because Colab notebooks run code on Google's cloud servers, data professionals of all kinds can tap into Google's hardware, including graphical processing units and tensor processing units, without worrying about the limitations of their personal computers. All they need is an internet browser. Now that you're familiar with the uses of Colab, consider the benefits of Colab notebooks for data analysis. First, Colab's free version uses graphical processing units and tensor processing units for up to 12 hours at no cost. This means that users can access Colab's powerful computing resources to do things like analyze large datasets. Also, users can create shareable links for Colab files stored on their Google Drive for easier collaboration and notebook sharing. And users can install libraries like AWS S3 GCP, SQL, MySQL, and others that are not available in code samples. Libraries are useful for accessing and analyzing data. They allow users to tap into a variety of databases, cloud storage services, and other resources. Another benefit is that Colab has a bunch of pre-installed libraries, like NumPy and Keras. This means that users can immediately start to code without needing to set up these libraries. Plus, since Colab saves everything in Google Drive storage, users can pick up where they left off from any computer using their Google Drive account. If you're a GitHub user, you can even connect your GitHub account to Colab and move your code files between them easily. Also, Colab is compatible with all sorts of data sources, which is great for machine learning and AI training projects. And, just in case you're worried about losing any changes, Colab keeps track of every single change you make from the moment you create a file. Pretty cool, right? Okay, a few uses. To ensure Colab remains free for users, its resources are not guaranteed and not unlimited, and the usage limits may vary. This means that while Colab provides valuable computational resources at no cost, there can be fluctuations in their availability. Also, when sharing a Colab notebook, all its content, including text, code, output, and comments, will be shared. But users can omit code cell output from being saved or shared, enabling users to run the cells and see the results themselves. To omit code cell output from being saved or shared in a Colab notebook, users can go to Edit, select Notebook Settings or Preferences, check the box for Omit Code Cell Output when saving this notebook, and close the Settings dialog. Google Colab combines the power of a text editor with a Python coding environment, all within an internet browser. It's like having a high-powered coding laboratory right inside a regular sketchbook. Keep practicing to discover all the new possibilities. Hi there, future data pro. Thanks so much for joining me in this video about database partitioning. You're going to learn how to make your data work much more efficient by dividing data into manageable and efficient segments. Let's get started. Database partitioning is the process of dividing data into separate data segments, or partitions, that can be managed and accessed separately. Database partitioning occurs across servers or databases. It's important to call out that database partitioning is different from table partitioning, which involves segmenting data within a single table without distributing data across hardware. Database partitioning offers many benefits, but the most important are improved scalability, availability, and performance. Let's discuss each of these benefits. First, database partitioning helps with improved scalability by spreading data across multiple partitions. By dividing the data into manageable parts, the system can handle more work efficiently, ensuring continued excellent performance. Second, partitioning helps with improved data availability by dividing the data across multiple servers. This also prevents a single point of failure. And data partitioning includes a built-in backup feature that ensures that services remain available if a failure occurs. Third, database partitioning helps with improved performance by allowing the system to query a smaller part of the database instead of the entire thing. This makes the service more efficient. When partitioning databases, there are three key strategies that data professionals employ: horizontal partitioning, also known as sharding, vertical partitioning, and functional partitioning. Horizontal partitioning is a process for dividing data into separate segments in which each partition, or shard, is its own data storage, but all shards follow the same organizational layout. Each shard keeps a unique piece of the whole data, like all orders from a certain group of customers. Consider a sneaker inventory that is divided into shards based on the SKU, or ID number. This sneaker inventory is an example of horizontal partitioning. Next, vertical partitioning is a process for dividing data into separate segments in which each partition maintains a unique piece of the fields for items in the data store. These fields are divided based on how often they are used. So, fields that are used often might be put into one vertical partition, and fields that aren't accessed as frequently might be placed in another. In the sneaker inventory example, one partition holds frequently accessed inventory data, including sneaker name, color, and price. Another partition contains other inventory data, like current inventory and location. Lastly, functional partitioning is a process for dividing data into separate segments in which data is grouped based on how it's used in different parts of the database system. With functioning partitioning, data is grouped based on how it's used in different parts of the database system. For example, sneaker brands may be placed in one partition based on what the sneaker was designed for, like training or running. Simultaneously, they could be assigned to another partition based on pricing. There are three key considerations when incorporating partitioning into an already active system. First, it may be necessary to change how data is accessed in the system. Second, dividing data into different partitions will require the migration of large amounts of existing data. And third, users will want to keep using the system during the data migration. Now, dive into important considerations when partitioning data. First up, parallel processing. Parallel processing enhances query performance by dividing the data into smaller parts that can be processed at the same time. Parallelism is the system's ability to perform multiple tasks simultaneously on different database partitions. Next, consider application requirements. Application requirements refer to how the data will be used, queried, and changed in order to design a system that performs well, responds quickly, and remains reliable. Application requirements are important because database partitioning can make system design and development more complex. And a pro tip, users must rebalance partitions to address uneven distribution of traffic when there is a surge. This is done by creating a new strategy and moving data from the old partitioning scheme to a new one. Nice work. You now understand how database partitioning improves query performance by allowing a system to work with smaller subsets of data. The result is faster and more efficient analysis. By applying an effective partitioning strategy in your own data work, you'll provide your organization with a big advantage as it navigates through its data systems. Have you ever searched through a pile of papers trying to find a specific document? It can be very time-consuming. But what if papers were neatly organized in a folder with labeled sections for personal, banking, medical, and so on? Your search would become so much easier and faster. Well, that's basically what partition tables do in a database system. They neatly categorize data into separate sections, or partitions, streamlining both data management and queries. In this video, you'll learn what it means to partition a table, when to partition a table, and the types of table partitioning you can perform. You'll also learn about clustering in concert with partitioning and as another option. Okay, so a partition table is a large table that is divided into smaller segments, or partitions. Partitioning reduces the amount of data a query needs to process. This has two benefits. It improves query performance, and it controls costs. In a partitioned table, data is stored in separate storage units, each containing a single data partition. Unlike database partitioning, which results in managing multiple databases, a partitioned table can still be treated as a single table. Partitioned tables also keep track of the metadata about the data stored in each partition, and can use that metadata to optimize queries. Also, thanks to the metadata, BigQuery can provide a more precise estimation of a query's cost before it's run. Partitioning is effective for columns with fewer unique values, so that each partition still has a relatively sufficient amount of data. In BigQuery, it's best to have at least 1 GB per partition. For example, if you have a table storing months or years worth of data, you could store each day's data in a different partition. This way, if you are only interested in querying the last 30 days worth of data, BigQuery knows it does not need to scan any partitions older than 30 days. Now, consider some examples of when to partition a table. First, partitioning is valuable when a data professional needs to improve query performance by only scanning a specific section of a table. Second, if a table operation exceeds the expected volume of data, the data professional needs to limit it to specific partition column values. This is a benefit of higher partition table quotas. Third, another time to partition is when the data professional needs to set an expiration schedule to automatically delete entire partitions after a specific time period. Fourth, a data professional should consider partitioning when they need to load data to a specific partition without affecting other partitions in the table. Fifth, and finally, a data professional should partition when they need to delete specific partitions without scanning an entire table. There are 3 ways to partition a table: integer range, time unit column, and ingestion time partitioning. With integer range partitioning, users partition a table based on ranges of values in a specific integer column. To create an integer range partitioned table, provide the partitioning column, the starting value for range partitioning, the ending value for range partitioning, and an interval of each range in the partition. Next up, time unit column partitioning. This type of partitioning enables data professionals to partition a table based on a date, timestamp, or datetime column. When writing data into a table, BigQuery will automatically place it into the appropriate partition based on the values in the column. When working with timestamp and datetime columns, data professionals can set partitions with hourly, daily, monthly, or yearly divisions. For date columns, they can set partitions with daily, monthly, or yearly divisions. The partition boundaries are based on Coordinated Universal Time, or UTC time. Finally, with ingestion time partitioning, BigQuery automatically assigns table rows to partitions based on the time when the data is ingested or imported by BigQuery. Data professionals also have the flexibility to choose between different partition divisions based on their specific needs. Ingestion time partition boundaries are also based on UTC time. Great, now let's move on to clustered tables. A clustered table is a table in which column order is defined by the user using clustered columns. And a clustered column is a user-defined table property that arranges storage blocks based on the values within their columns. The order of the values in a clustered column determines the order in which the rows of the table are stored in memory and disk. This can improve the performance of queries that access the table by the clustered column, because the rows are already sorted in the order that the query needs them. For example, think of a table with sales data, with columns like product, date, and regions. By defining the date column as the clustered column, the storage blocks within the table will be sorted by date order, so rows with the same date will be grouped together. The size of the storage blocks in a clustered column is flexible and adapts to the size of the table. Clustering is great for columns with tons of unique values, so that even more rows can be filtered out by querying. A clustered table keeps the sorting criteria in the context of each operation modifying it. Just like partition tables, clustered tables improve query performances. And if clustering on a table that is also partitioned, each partition's data will be sorted based on the clustering columns. There are many very useful options available for all sorts of data projects. And no matter which you choose, you'll be able to locate what you need quickly and easily. Just as a well-organized folder helps you locate specific documents, partitioning and clustering in BigQuery facilitates effective data management and faster query performance. Pruning is the practice of removing unwanted branches from a tree. Gardeners prune trees to improve their overall health, to shape the trees, and to help the trees produce more fruit. In the data field, we do a kind of pruning as well. And just like with trees, pruning makes our data work more fruitful. In this video, you'll explore partition pruning. Partition pruning is the process of eliminating unnecessary or irrelevant data from consideration when running a query. In other words, the data professional runs a query using a qualifying filter on the value of the partitioning column. This tells BigQuery to scan the partitions that match the filter and skip the rest. All right, now let's examine the queries that can be run on different types of partitioned tables. First, to remove unnecessary partitions when querying a table partitioned by a time unit column, use a filter based on the partitioning column. Consider this example of a query partitioned table. A dataset table is partitioned based on the transaction date column. The example query prunes dates by excluding any before January 1st, 2016. Now, the ingestion time partition tables in BigQuery. There's a special column called partition time. This column holds the coordinator universal time, or UTC, when each row was imported, rounded to the nearest partition boundary, like hourly or daily. This is represented as a timestamp value. If a data professional were to add data on April 15th, 2021 at 8:15 UTC with a partition granularity of hourly, the partition time column for those rows will store the timestamp value truncated to the hour. And if the table is partitioned by each day, it will also include a fake or pseudo column called partition date. This is just the partition time shortened to present only the date and is represented by a date rather than a timestamp value. To prune partitions on ingestion time partitioned tables, filter either of these columns. This example query only scans the partitions between the dates January 1st, 2016 and January 2nd, 2016. All right, so to prune partitions when querying an integer range partitioned table, include a filter based on the integer range partitioning column. Consider this example of an integer range partitioned table. It has partitioning based on a range of numbers, with a focus on customer ID between 0 and 100 in steps of 10. The example query scans the three partitions that start with 30, 40, and 50. Data that is being sent to BigQuery in near real time is written to write-optimized storage before being moved to its assigned partition. The data is temporarily stored in a partition called unpartitioned, and you can query data in this temporary unpartitioned partition. Data in the write-optimized storage has null values in the partition time and partition date columns. Okay, now to query data in the unpartitioned partition, use the partition time pseudo column with the null value. Great. Now let's consider 3 best practices for designing and implementing partition pruning strategies. The first best practice is to use a constant filter expression to limit the partitions that are scanned in a query. This is helpful because you will always reduce the amount of data processed to only the partitions needed, and that will make your query more efficient. The second best practice is to isolate the partition column in the filter. Filters that require data from multiple fields to compute will not prune partitions. And the third best practice is to require a partition filter in queries to ensure queries always eliminate unnecessary partitions. Partition pruning improves queries on partitioned tables by eliminating unnecessary data and enabling analysts to focus on only relevant partitions. This makes data work more efficient, effective, and insightful. Just like a flourishing, beautifully pruned tree, which comes back even more bountiful year after year. Hi there, and thanks for joining me in this video all about Dataproc. Dataproc is a fully managed service for running big data processing jobs on the Google Cloud platform. You may know a little about Dataproc already, but in this video, you'll consider how to use Dataproc in your work as a data analyst. To understand Dataproc's many benefits, let's check out an example. Maybe a data professional is working at a governmental agency, where data flows like the sound waves of a never-ending symphony. Day after day, for 6 whole months, a data analyst diligently combs through and processes the numbers like a true data conductor. It soon becomes clear to the analyst that they're performing the same tasks and delivering the same reports time and time again. Eventually, the repetition starts to seem like an endless loop. They're playing the same tune on repeat, and sometimes hitting a few wrong notes along the way. It occurs to them that it must be possible to either automate portions of the work or find a way to reduce errors. So, the data analyst decides to use Dataproc to run Hadoop and Spark clusters. Dataproc is a fully managed service that maximizes open source data tools for batch processing, querying, streaming, and machine learning. With Dataproc, users can create clusters quickly, manage them easily, and save money by turning off clusters when they're not needed. Using Hadoop and Spark clusters, the data analyst can significantly reduce the manual effort required, process data efficiently, and mitigate potential errors. Before we move into the specifics of Dataproc, let's review its key processes. Batch processing is a method of collecting large volumes of data over a long period of time, and then processing it all at once. Querying is requesting data or information from a database. Streaming involves working with data as it is generated. And finally, machine learning is the use and development of algorithms and statistical models to teach computer systems to analyze and discover patterns in data. Data analysts can process data in BigQuery directly from Dataproc and can manage Dataproc with the Google Cloud Console. Apache Hadoop is a framework that distributes the processing of data across clusters of computers. When working with Dataproc, data analysts may also encounter PySpark, the Python API for Apache Spark. PySpark is a language for creating more automated analyses and pipelines. These can be applied to both structured and semi-structured data. And there are several benefits of integrating Dataproc into a workflow. Once a data analyst integrates Dataproc, they're able to process data at a lower cost because clusters are turned off when not in use. Also, the process speeds up because the work is distributed across multiple machines and clusters with the integration of Hadoop. The integration with BigQuery means that a data analyst only interacts with a single platform for all of their analysis needs. And Dataproc is fully managed by the Google Cloud Platform, so no maintenance is required on analysis systems. Plus, with integrating Dataproc into the workflow, data analysts can ingest data several times per day without fail. Likewise, the clusters scale up and down, so the organization only pays for the compute power needed. With very little oversight of the data integration and a consistent application of the batch processing, the data professional is now able to devote more of their time to analyzing the data and finding valuable business insights. And that's music to their ears. Congrats! You've completed another section of the program. Awesome work. You now know how to interact with BigQuery tables and use optimization techniques to improve queries. Plus, you experienced using a cloud-based data lake and warehouse to connect with data sources and answer business questions with data. You explored data patterns and learned how to create table schemas in BigQuery. Then, you worked on integrating Google Cloud tools into BigQuery. You also discovered the benefits of partitioning and how to manage partitioned tables. Finally, you used Dataproc for data processing and dove into managing Dataproc clusters. Great job! You're one big step closer to your goal.
Hi, I'm Vince.
Hi, I'm George.
Congratulations on making it through this course. Now you'll have an opportunity to look in on an interview while it's happening. This interview will include technical topics from the course.
We hope that this helps as you prepare for your next interview.
So what interests you in a career in cloud data and analytics?
What got me interested about a career in cloud data analytics was in college, everyone was talking about the cloud and how powerful that it can be and how much it seemed like it was the future of where technology was heading. And it sounded like something I'd be interested in. I started to look more into the cloud and how I can use it in my studies in business. And I saw how scalable and how powerful it could be, and decided that it was an area that I wanted my career to go into.
So can you tell me about a favorite data analytics project that you worked on, and tell me what your role was and what you liked about the project?
My favorite data analytics project was one where I was a data analyst, where I got to combine all of these data sets about compressors and engines, where I was able to put them up in the cloud and perform some statistical analysis to help prescribe if they're going to have some sort of maintenance event or fail. And I really liked it because it had a real world impact.
Suppose you're working for a company that wants to modernize their data lake and their data warehouse. What are some components of a modern cloud data platform they should consider?
They should consider their ETL policy, their data lifecycle policy, their privacy policies, and then how they're going to scale all their data and make it available, and if they can apply any machine learning or AI onto it.
So when it comes to ETL, can you talk to me about the differences between batch processing and stream processing?
The differences between batch processing and stream processing is, for batch processing, you will process all of your data at once in one large workload. But for stream processing, you're going to process each little bit of data that comes through your system.
Can you tell me some use cases for each?
A good use case for batch processing would be data analytics. If you want to perform data analytics around how a product might be performing, you want to have a complete picture of the performance. And so for batch processing, you would wait until you have a complete data set. A good use case for streaming data would be like stock trading. You want to know where the market is moving at any given minute, and you can't wait until the end of the day. And so you would need to process that data in real time.
Can you give me an example of a problem that a streaming data source would solve?
A problem that a streaming data source would solve might be something like an intrusion detection, where a security company could monitor real-time data in order to determine if there's any unauthorized personnel in some perimeter. It could also be a virtual perimeter, like in the cloud.
All right, so imagine that you've been asked to build a new report for a toy manufacturing company. The report should contain the names of each toy built and the number of units shipped by each month. What data would you look for, and where would you look for this data in cloud tools?
If I wanted to create a report that showed each toy and how much we shipped each month, the first pieces of data that I'd be looking for is their manufacture date and the names of each of these toys and any variations of these toys, because we'd probably want to track that as well. And I would find all this information in BigQuery.
So what language would you use to query the data in BigQuery?
I would use structured query language, and that's how we talk to databases to retrieve any information that we need from them.
If you're looking to essentially query the number of units shipped by month, you don't have to sort of say the query exactly as you might type it into a console, but what might that query look like?
In general, that query would look like selecting all of the products and any variations of them that we might be interested in reporting on. And I would sum like a unique count of each product who had a manufacture date within a certain month, and I would aggregate those to get a view that shows for each toy that we produce, how many we ship that month.
Really appreciate you taking the time to interview with us, and I really wish you luck with the rest of the process.
Thanks, Vince. I really appreciate your time today, and it's been a pleasure.
Great to meet you. In this scenario, George demonstrated how to provide examples when answering questions. During an interview, you can differentiate yourself by providing examples of how you've used your skills in relevant situations. Watch for more interview tips later on in this program.
Awesome work. You've made it to the end of this course. I hope you've enjoyed learning with me all about cloud storage and data management in the cloud. My favorite part about analytics is that it combines the objectivity of data with the creativity of storytelling. At Google, many of my projects end with a colorful dashboard or snazzy slide deck explaining why trends are happening and how folks should respond. At their core, the stories that I craft are grounded in truth. Without proper data management, they'd be impossible to tell. As you continue building your analytics skill set, I'm excited to imagine all of the stories underneath the numbers you've gathered. You started by learning about data storage and connections, types, and structures. Then you moved on to table schemas and batch and streaming data processing. Then you explored denormalized data, data governance, metadata, data catalogs, the key components of data lakehouse architecture, and more. Then you discovered Dataplex and how it can be used to identify data sources in BigQuery. You learned to identify and trace data lineage and access data libraries. Finally, you explored data reference architectures, how to manage tables in BigQuery, add and export data, and query tables, and integrate Dataproc. Then, you explored the benefits of partitioning and managing Dataproc clusters. You now have a solid foundation in organizing and structuring data, which will be important for your role in cloud data analytics. Congratulations on finishing this course. I'm excited for your next steps.
Hello there. You're making great progress on your path to becoming a data professional. Congratulations. Throughout your learning expedition so far, you've explored the basics of cloud data analytics and how to store and manage data in the cloud. Next, you'll learn how to work with the data to prepare it for analysis. In this course, you'll learn to identify the quality of the data you're working with and explore methods for transforming and processing that data. It's important to keep in mind that the cloud data professional will transform and process data before analyzing it, which makes the steps you're about to get familiar with essential. Hi there, I'm Alex. I'm a data and analytics customer engineer. This means that I lead a customer or prospective customers' data and analytics technical projects, which can be anything from technology advocacy to architecting solutions. I first learned about data transformation in my first job out of college. In my role, I was tasked with identifying fraudulent transactions on the company website. Since the website had millions of visitors a day, it was important to cut through the noise and transform the data in a way that was useful and applicable for our analysis, ultimately keeping bad actors off the website and creating a positive environment for our users in the process. Learning about data transformation in my first role laid down the foundation for the rest of my career. Now, let's get back to what you'll learn. We'll start with an overview of the data journey and its importance, including collection, processing, storage, and transformation of data. Next, we'll explore the data pipeline and various methods for extraction, transformation, and loading. Then, you'll discover how to use Data Transformation Plan to meet the business needs of your organization. You'll also learn transformation strategies. Learning data transformation is key to preparing quality data that will lead to actionable insights. Don't forget, I'm here to help you every step of the way. You can work at your own pace, so review videos and resources anytime you need. You've got this. By the end of this course, you'll know how to process and transform data into a consistent, workable data set. Let's get started. Hi there, I'm Alex. I'm a data and analytics customer engineer. A typical day for me may include demoing solutions, working with customers to develop their analytical strategies, and helping solve data problems. I've been interested in STEM for as long as I can remember. I studied science and engineering throughout school. I especially loved being able to stay up late and use the campus telescope for my research on planets and stars. I started my career as an academic researcher working with astronomy and physics. I love the analytical aspects of that work. My pivot to the tech industry was a huge period of growth for me as I was moved into a field I didn't have much experience in, but was able to learn, grow, and thrive. One of the biggest challenges I faced early on was learning how to write SQL to query data. While the language was new to me, I was familiar with problem solving and was able to pick it up with enough practice and studying. Writing SQL to answer analytical questions has been the foundation for my career in tech. Now, I love serving as a data practitioner, helping companies and learners like you to apply strategies to learn the most insights from their data. All aboard! Let's steam ahead with the data journey. Coming up, we'll introduce the data journey and how it relates to your role as a cloud data analyst. First, we'll review the data journey process and its role in improving data-driven decision-making. Next, we'll review data collection techniques. Then, we'll explore data transformation and the different methods used for transforming data. Finally, we'll introduce you to a variety of methods and tools for data processing and storage. When you're ready to get started, get your passenger ticket and meet me in the next video. In this video, we'll explore how data moves through the cloud using a process called the data journey. The data journey begins when you, as a cloud data professional, locate data, and the journey ends when you present the data analysis to stakeholders. The data journey has 5 stages: collect, process, store, analyze, and activate. In this course, we'll cover the first 3 stages: collect, process, and store. The last 2 stages, analyze and activate, will be covered in a separate course. Understanding the data journey is important because organizations need a structured way to collect data to prepare for analysis and inform data-driven decision-making. It is equally important to understand the unique role of each stage of the data journey. The first stage is to collect data. During this stage, you'll find and gather the data you need. The second stage is to process data. This stage can also be called transformation because it is the process of transforming data into a usable format. During this stage, you'll review and explore the data to identify issues. You'll also clean, organize, and standardize the data. The third stage is to store data. Once you've located and processed the data, you'll need a place to keep it. You'll have several options to choose from depending on your business needs, including storing data locally or in the cloud. The fourth stage is to analyze data. During this stage, you'll identify trends and patterns to uncover insights your users need. The fifth and final stage is to activate data. This is the final result where you'll present your visualizations to your stakeholders and use the insights from the data to make decisions and take action. As you move through the stages of the data journey, it's important to know that the process isn't linear. The data journey is an iterative process, meaning you may move back and forth between the stages. For example, after you collect the data and move forward into the processing stage, you may realize you need to go back and find more data to answer the stakeholder's business question. Also, the data journey isn't a one-time process and is instead repeated. You'll need to go through this process multiple times. And the data journey is tailored to each project. You'll likely find differences between projects that change the process. For example, if the data requires extensive cleaning, you may need to spend more time in the processing stage. It's important to call out that the tools you use can also affect the process. For example, with some tools, storing data happens before processing, or it can be the other way around. Together, the stages of the data journey represent a foundation you can build on to analyze your data and provide insights for your users. So, imagine as a cloud data professional, your current project is to create a dashboard for a sales team. Where do you start? Well, you start a data journey. The first step of the data journey is collect. You might also refer to this as the gathering stage. Data collection is the process of identifying and finding the data that can be used to meet a specific business need and bring it all together. Because it's the first stage of the data journey, data collection is essential for creating a solid foundation for your data, analysis, and visualizations. There are 4 steps within the collection stage. Before you can find the right data, you need to know what you're looking for. So, the first step is to identify specific questions you want to answer with your data. To do this, you'll work with your stakeholders to determine their needs. Once you've figured out the questions you're trying to answer, you can move into the second step, data discovery. During this step, you'll find the data you need. Data is usually stored in various formats and in different sources. You'll also need to explore how the data sources you select relate to the things you are trying to measure and understand to identify the data you need to gather. The third step is data gathering. Keep in mind, you'll likely be looking for data in multiple locations. Also, the data will be in different formats, so you will have to find how to work with each data source and evaluate how often you will need to update the data. This can be a time-consuming process. When you identify the data's location, you can collect it into a single, usable staging area. The final step is data staging. Once the data has been gathered, you will need to find a way to bring together the data into a single, usable staging area. Once the data has been brought together, it is ready for the next stage in the data journey, process. As the first stage of the data journey, good data collection is essential. Become comfortable with this process so that you can begin to create a good foundation for your data, analysis, and visualizations. At this point in your journey as a cloud data professional to create a dashboard for a sales team, you've identified what data you need, you've collected the data, and you think you're ready to move forward to the second stage, process. But not so fast. You're going to need to work with the data before you can use it for analysis. Raw data can be in different formats and have a lot of problems that need to be fixed. For example, during the collect stage, you might find data that's incomplete or missing. You might also find duplicated or incorrect data. These issues will cause errors in your analysis. So, it's important to identify them now in this process stage and correct any errors and make sure the data is in a format you can use before moving forward to the third stage, store. Data transformation is the process of taking raw data and converting it into a usable format. Basically, it's changing inconsistent data formats into a consistent format that you can use for analysis and visualization development to ensure that the data is error-free and in a format that you can use. Sometimes the term data processing is also used to refer to data transformation, but they are not the same. Data processing is a big term that covers a lot of different things. It can include collecting data, cleaning it up, transforming it, analyzing it, and visualizing it. Data transformation is a more specific type of data processing. It's the process of converting data from one format to another or from one structure to another. The goal of data transformation is to provide your data team with data that you can all access and use. This includes addressing issues like correcting errors, adding new information to the data, and reducing unnecessary data detail. While there are many different ways to transform data, there are 6 basic types of data transformation, including data smoothing, attribution construction, data generalization, data aggregation, data discretization, and data normalization. The exact method you use will depend on the type of data you're transforming and how it will be used. There are 2 basic methods to approach data transformation. You will either perform data transformation manually with SQL or another common language, or you'll use an automated pipeline. The method you choose will vary by project and the type of data you're using. Now, you're set to move on and decide whether to perform data transformation manually or automatically so that you can create a solid foundation for your data analysis. Taking time here to make sure your foundation is solid will help ensure the success of your future data visualizations. Okay, so as a cloud data professional, you're well on your way to completing a project to create a dashboard for a sales team. It's time to transform your data, and you'll have to figure out the best method to use. You can select either manual or automated data transformation. Both data transformation types have the same goal, to prepare data for your analysis. Let's explore both methods. Manual transformation is the use of coding languages to effect data transformation without the aid of software programs. This includes languages like SQL, Python, and R. SQL, or Structured Query Language, is what you'll be working with for the remainder of this course. SQL is used to get data out of relational databases. Python is a high-level, general-purpose programming language that works with libraries like Pandas to analyze and visualize data. Pandas is an open-source data analysis and manipulation library that can be used with Python. And R is a programming language used for statistical computing. The packages in R provide a variety of methods for implementing data simulations to transform data, like arrange, filter, and select. While you can use manual transformation on datasets of any size, it's best for smaller datasets because of the time, effort, and accuracy involved to code. Not only does the code have to be created, but you'll spend additional time testing, troubleshooting, and maintaining it. Automated transformation is the use of processing and scripting tools with less or no programming compared to manual transformation. These processes are usually combined to create an automated workflow. These tools make working with your data so much easier than manually transforming data alone. Although you don't have to use much code with these tools, you might still end up using coding languages, like SQL and Python, to make modifications within the tool. Automated transformation tools are best for large or high-velocity datasets and can be local or in the cloud. The tools you use will be based largely on the needs of your organization and the goals you're trying to reach with your data. So, which transformation method should you use? There are several factors that will influence your decision. The size of the datasets is probably the most important. The larger the dataset, the harder and more time-consuming it will be to transform manually. Manually transforming a larger dataset also increases the chances for errors. It's also important to consider how long it will take to process the data. If speed is important, you might choose to use automated transformation so that you can more quickly and accurately transform the data. The use of automated transformation tools is also dependent on tool availability. Since these tools cost money, they might not always be available, so the manual process could be your only option. You might also want to use a combination of transformation methods. Even with access to automated transformation tools, you may have to manually use programming languages to make some changes to your data. Each method of data transformation has its advantages, and you'll likely use both over your cloud data professional career. You've made it through another topic. During this course, you learned about the steps in the data journey and its importance in your role as a cloud data analyst. First, you reviewed the concept of the data journey and its role in improving data-driven decision-making. Next, you learned about data collection techniques and explored additional details for data collection. Then, you explored the critical importance of data transformation and the different methods for transforming data. Finally, you learned about the various methods and tools used for processing and storing data. Good job on your progress so far. We've come to our last stop of this section in the data journey, and the train is ready to move to the next station. Hi, and welcome back. Congratulations on your progress so far. Recall the 5 stages of the data journey: collect, process, store, analyze, and activate. Once you've started a data analysis project and you're in the midst of the process stage, it's time to explore how data pipelines can help you address business needs. Let's cover the 3 main stages of a data pipeline: extract, transform, and load. We'll start by discussing how data pipelines convert raw data into a format that's ready for storage and analysis. Then, we'll dive into the stages of a data pipeline in more detail. We'll begin with the extract stage and discover how data is collected from various sources and ingested. Next, we'll discuss the role of the transform stage in the pipeline process and how data is cleaned and manipulated. Finally, we'll review the load stage, the stage where data is loaded into destination storage and made available for storage and analysis. Let's get started. In cloud data analysis, you can think of data like a set of raw materials that determines how a project moves forward. The data needs to be produced efficiently and in a consistent way. As you may already know, a data pipeline is a series of processes that transports data from different sources to their final destination for storage and analysis. There are 3 main stages in a data pipeline: extract, transform, and load. Let's consider an example. A toy factory uses an assembly line to make toy cars. In the first stage, one worker gathers all the parts they need to make a toy car and puts them on a tray. Then, they pass the tray down the conveyor belt to another worker who assembles the car. After the car is assembled, the third worker packages it. As a cloud data analyst, instead of toy cars, you'll be working with data. Let's explore each step in a data pipeline. Extract is the stage of retrieving data from one or more sources in a data pipeline. In this first stage, the team gathers raw data from various sources and moves the data to a temporary staging area. Here's an example. An animal rescue organization has a mission to locate and protect missing and lost pets. The data team for this organization wants to create a data pipeline. They have 2 sources of data. One is a CSV file that includes the registration number of each animal's microchip. The second is a database that includes information about pet owners, including contact information and the registration number for each pet. During the extract stage, the raw data from both of these sources is copied and moved into a staging area using techniques that are specific to each source. Once the data team collects all the data they need into the staging area, the extract stage is complete and the data is ready to be moved to the next stage, transform. Transform is the stage of taking data, cleaning it, and putting it into a standard format in a data pipeline. Before the data team can convert, store, and use the data for analysis, they check the data for duplicate entries or obvious errors. Once the data has been transformed, it's ready for the final stage, the load stage. Load is the stage of inserting data into the target database, data store, data warehouse, or data lake in a data pipeline. In the case of the animal rescue organization, the transformed data will be loaded into a data warehouse. This will enable the data team to store the data for future analysis and visualization. Pro tip: data pipelines can be complex, and not all data pipelines work exactly the same. Just like a factory assembly line, a data pipeline is tailored to the specific task needed to get a specific data job done in an efficient and consistent way. For this reason, the stages in a data pipeline may not always happen in the same order, and the processes within each step may change depending on the data. But one thing that all data pipelines have in common is that they're like data assembly lines. They're a valuable tool for automating the process of extracting, transforming, and loading data. Data pipelines can also help organizations save time and resources, improve data accuracy, and get more value from their data.
What I love about this career path is that every single day is different. Hi, my name is Alyssa, and I am an account executive here at Google with a background in data and analytics. I get to work with all different types of organizations to help them figure out how do they solve their challenges with data. So basically taking any sort of complex data problem and helping make those connections. I've always been a very curious person. You can ask my parents. I was constantly asking them questions. And so being able to lean into that in this role has been awesome. But I also had to develop my skills over time. So when it came to any of those more technical skills, I had to lean into being more formalized with my learning and being more systematic about my approach. But having that underlying curiosity and hunger for learning has really served me well. One of my very first jobs was working as an attendant at tennis courts. I was in charge of cleaning up the courts, I was in charge of making sure that everyone was sharing very effectively, and I was also in charge of managing all of the lessons and activities that would happen on that court. When you look at that now, you might say, how does that relate to data and analytics? And what I found was that I was constantly collecting information about all of the people who were participating in the courses, all of the people who were trying to get time on the courts, and then I was trying to figure out, how do we make this more efficient? When you look at any type of problem, it all comes down to what is the information we're trying to gather and what is the goal outcome that we're trying to achieve. When I first was graduating, I didn't know what I wanted to do, and the first role I went into, I was very fortunate where I got to spend a little bit of time working with all different cloud technologies. But I definitely gravitated towards the data and analytics solutions because I could see so tangibly how we were solving problems with them. When I was starting out, I would have loved to have known that nobody has all the answers. And so that ties into my whole ethos around asking questions and being curious. You might feel sometimes like you should know the solution right off the bat, but nobody does, and if they are, they're probably pretending. So I found that if I had been more comfortable earlier on with just going in as a learner, that you'll get the better outcome. The best advice that I can give you is to stay persistent. There are going to be times when the problems are really hard to solve or you'll have no idea where to start. But if you stay persistent, you will figure it out and you will continue to progress.
As a data analyst, how you organize your data pipeline can have a huge impact on the efficiency and effectiveness of your data storage and analysis. To start, choose an integration technique that works best for the business and its data needs. The data pipeline integration techniques we'll discuss here include extract, transform, load stages, or ETL, and an alternative order of those stages, ELT. Let's dive in and briefly review what each of the stages entails. E stands for extract. Extract is the stage of collecting data from one or more sources. T stands for transform. Transform is the stage of taking data, cleaning it, and putting it into a common format. L stands for load. Load is the stage of inserting that formatted data into the target database, data store, data warehouse, or data lake. Extract, transform, and load are all stages in a pipeline process that data analysts use to move data from the source and get it ready for storage and analysis. Now that you know what E, T, and L stand for, it's time to dive into how ETL and ELT pipelines work. ETL, or extract, transform, and load, is a type of data pipeline that enables data to be gathered from source systems, converted into a useful format, and brought into a data warehouse or other unified destination system. ETL has been around for decades as a way to integrate and manage large amounts of data. But recently, data teams have adapted their process, moving their data sources and storage solutions to the cloud. ETL brings data from various sources together in one place. This makes it possible for data teams to analyze the data and identify trends and insights that can help drive data-driven decision-making. For example, a university might use ETL to integrate data from its student information system, financial records, and course catalog. This allows the university to track student enrollment, financial trends, and course performance, so the university can make informed decisions about which courses to continue, which courses to expand, and how many faculty to employ each semester. An alternative to ETL is the ELT pipeline, where the loading and transformation stages are swapped. ELT, or extract, load, and transform, is a type of data pipeline that enables data to be gathered from data lakes, loaded into a unified destination system, and transformed into a useful format. The ELT pipeline is a popular option for organizations that need to process large data sets in the cloud. But why load data before transforming it? There are 3 reasons: save time, enable scalability, and increase flexibility. Transformation can be time-consuming, especially if you have a lot of data to process. When speed matters, like with streaming data and near real-time analytics, ELT may be a better choice. Loading your data first is also a great way to take advantage of the scalability in the cloud. And in some cases, you may not know exactly how you will need to transform your data. In this case, ELT gives you the flexibility to load your data first and then transform it later. For example, a manufacturing company wants to track their production data as soon as it's available, or in near real time, so that they can make data decisions quickly. A manufacturing company's data comes from a variety of sources, including a production control system, machine sensors located around the manufacturing floor, and a quality control system. The company's data team could use the traditional ETL pipeline to extract the data from each source, transform it into a common format, and load it into a data warehouse. But that would be slower and could impact performance. If the company uses the ELT pipeline instead, they can load the data before transforming it. Then, they can make the data available in near real time. This gives the data team more flexibility, since they can change the way transformation is done as needed. To wrap, ETL and ELT are both data pipelines that move data from one location to another. As a cloud data analyst, you'll decide whether to use either the ETL or ELT pipeline depending on when you need to transform data. When organizations need to make decisions, they rely on a variety of sources to get the data they need. The range of possible data sources is tremendous. Just a fraction of potential data sources includes websites, point-of-sale systems, social media, and even machinery sensor data. It's important to call out that each individual source only makes up part of an organization's data needs. To have a more complete understanding, organizations must have a way to bring their data sources together. This is where data ingestion can help. Data ingestion is the process of collecting data from different sources and moving it to a staging area. As a data analyst, data ingestion is an important first step in a data pipeline to get your data ready for further processing and analysis. But not all ingestion techniques work the same, so it's important to choose the technique that works best for your data. And one important factor that you'll rely on when deciding which ingestion technique to use is whether the data is time-sensitive. Time-sensitive data is data that must be acted on within a specific time frame, or it loses value. When planning a time-sensitive travel itinerary, you might consider which mode of transportation you're going to use to get from one destination to the next. And you will probably also consider how quickly you need to arrive at each location. Buses are a great and economical option if you don't mind waiting a bit. You can show up at the bus stop at the scheduled time, wait with other riders, and the bus will take you to your destination. But if you need to get somewhere in a hurry, a taxi is a faster option. In a taxi, you can go straight to your destination without waiting or sharing your ride. As a data analyst, the same is true for how you plan data ingestion. Like the bus example, if your data can wait a bit before you process it, batch ingestion is usually the best option. But if your data is time-sensitive, like the taxi example, you'll probably use streaming ingestion. Let's dive into how each technique works in more detail. Batch ingestion is a method of collecting data over time and processing it in groups, also called batches. During batch ingestion, when data becomes available, it's not immediately processed. Instead, the data waits over a period of time before it's processed as a group. This processing happens on a regular schedule, which makes it a good choice when working with a high volume of data, or when it's not critical for data to be ingested right away. As an additional benefit, this processing schedule also makes batch ingestion the more economical choice because it requires less computing power and storage space. Here's an example. A large international nonprofit organization uses batch ingestion to collect data on donations made to its website and over the phone. On average, it receives over 1,000 donations a day, and these donations come in around the clock. Once a day at a scheduled time, the nonprofit uses a batch ingestion tool to collect the donation data received in the past 24 hours from both sources, sort and group the data into a single batch, and load it into a staging area. Once in the staging area, the data is ready to be processed, stored, and used for analysis. The nonprofit can use this data to generate reports on donation trends, like the number of daily donations, the average donation amount, and donor count by country. The second main way to ingest data is streaming ingestion. Streaming ingestion is a method of collecting and processing data as soon as it becomes available. Streaming ingestion is best for data teams that need to process and act quickly. Here's an example. A pharmaceutical manufacturing company uses sensors to monitor the temperature of their dryers. The company's data team uses streaming ingestion of the sensor's temperature data as soon as it becomes available. This allows the company to track temperature changes in near real time to prevent any issues in their pharmaceutical products. If the dryer temperature starts to rise or fall below a safe threshold, the company can respond quickly to return the dryer to a safe temperature. By monitoring the temperature of the dryer in near real time, the company can ensure the quality and safety of its products and keep their equipment in working order. Now you understand the data ingestion techniques and how to consider time sensitivity when you choose a technique. Choose batch ingestion or streaming ingestion to get the data you need when you need it. Data mapping is a key part of the data pipeline and can be a complex process, but you may have done something similar before. For example, let's say you're an avid bird watcher. While at a park, you spot a bird species that you've never seen before. So, how do you identify it? Well, first you closely observe the bird and identify its size, shape, color, markings, behavior, and call. Then, you can compare these features that you observed to descriptions of known bird species using a field guide. By matching the bird's features to the field guide, you can try to identify the bird. That's what data mapping is like. Data mapping is the process of matching fields from one data source to another. And like identifying birds with a field guide, data mapping compares information to a known entity. Data mapping can use an entity like a schema to make an identification. Data mapping is also a critical part of the data pipeline. As a data analyst, once you ingest your data, you can map the data so you can easily understand and analyze it. This ensures the data is consistent and standardized. Here's how it works. For example, the data team from a large public library wants to combine data from two sources to track the 12-month history of their book circulation and number of new requests patrons make. The first data source is a library catalog that includes the International Standard Book Number, or ISBN, title, author, publisher, and publication date for each book they own. The second data source is a circulation database that includes the barcode, title, author, and due date for each book in their collection. To combine the data team will need to find a way to match the fields between data sources in a way that makes sense. To do this, they can use data mapping. First, the team identifies the fields that need to be mapped. In this case, the ISBN, title, author, publisher, and publication date fields. Next, the data team standardizes the naming conventions for the fields. For example, the title field in the circulation database is named book title, while the title field in the library catalog is just called title. But both fields mean the same thing. So, the data team decides on one name, in this case, title, to use for both fields. Next, the data team creates their data mapping rules. The data mapping rules are a set of instructions that define how the fields will be matched. For example, the library team defines a process for converting the barcode in the circulation database to an ISBN number. This is because the two fields need to match when the data team begins to test and analyze the data. Once the data team defines data mapping rules, the data team will next test the rules on a small subset of data. This will ensure the rules are working correctly before applying them to all of the data. Next, the data team creates a map that defines how the data fields relate to one another. Finally, they take all of the data from the two sources and combine it into a single data set. Now, the data team can process and analyze the data set. Of course, this is just a simple example. Data mapping is usually much more complex. Data mapping can also be challenging to do manually and may be time-consuming and error-prone. That's why many data teams rely on data mapping tools that can automatically match one field to another. When a data team is deciding between manual or automated data mapping, the choice will largely depend on the structure of the data team needs to map, the size of the project, and the tools they have available. No matter how an organization maps their data mapping is a key part of the data pipeline. It ensures that data is standardized and consistent, making it easier to use and analyze. This can lead to better data quality, which can help organizations make better decisions with their data. When you go to a store, the shelves are full of items of all shapes and sizes. But how does the store's management track all these items? Stores regularly conduct inventories. This is the process of counting items, making sure everything is in order, and ensuring the expected number of available products are either on the shelves or in the warehouse. Profiling and cleaning data is like taking inventory of a store's items. Data profiling is the process of exploring data to identify quality issues. It gathers information about the data structure, format, values, and relationships. Some quality issue examples might include missing values, duplicate records, inaccurate data, and inconsistent data formats. Once data profiling has identified quality issues, data cleaning can begin. Data cleaning is the process of fixing or removing data quality issues. This ensures that the data is accurate, consistent, and complete. To understand how data cleaning works, consider an on-the-job example with a data analyst named ARPA. ARPA is a data analyst for a retail chain. Every month, each store in the chain sends ARPA data about the items in stock. ARPA's job is to get this data ready for storage and analysis. The tasks to fulfill ARPA's job include profile the data and clean the data, which includes fixing any data quality issues. First, ARPA profiles the data. This is important because it helps ensure the data is accurate and complete before it's transformed, stored, and used for analysis. Data profiling can be done manually, but it's usually more efficient and effective to use a data profiling tool. A data profiling tool can gather information about the data structure, format, values, and relationships. For example, ARPA might use a data profiling tool to identify the different columns in the dataset, like item name, description, price, and quantity in stock. ARPA might also determine the data type for each column, like a string for the name and a number for stock level. ARPA might also consider missing or duplicate values. Now, ARPA has a profile of the data and can start to clean it. This involves fixing or removing any data quality issues identified during the profiling process and to ensure the data is accurate. For example, ARPA might find that there are a number of duplicate item names or that some prices are missing. Finally, ARPA needs to fix any data quality issues to make the data complete. So, to recap, data profiling and cleaning are important ways to prepare data to help improve data quality. By regularly profiling and cleaning data, cloud data analysts can ensure a business has the best possible data to make informed decisions. When you think of a data pipeline, you might imagine a linear process where data is collected, processed, and analyzed in a specific order. But this isn't always the case. In reality, data pipelines can be more complex and flexible. And the order of the processes and techniques a data analyst uses in a data pipeline varies depending on the specific needs of the project. For example, consider you're a data analyst for a large school district and you have a data set of student data with errors in different formats. In general, it's best to clean the data before manipulating it. But if the data is full of errors, you might want to use data manipulation to remove the most obvious errors first. This can help speed up the data cleaning process and improve the accuracy of the results. The techniques that you use and the order depend on the specific data. That is why, as a cloud data analyst, it's important to have an understanding of the techniques available to you and how you can use them in various ways to get the data results you need. Let's dive into an example using 3 common ways to manipulate data and make it usable for storage and analysis: data standardization, enrichment, and conversion. Data standardization is the process of ensuring that all the data in a dataset is in a common format. This makes the data consistent and reliable, so it's easier to process and analyze. Here's an example. Kyle is a data analyst who is responsible for managing the product catalog for a large online retailer. When adding new products to the retailer's database, Kyle notices the product names are inconsistent. Some of the product names are in all uppercase letters, while others are in lowercase letters. To standardize the data, Kyle decides to use a data standardization tool to check the format of the product names and make all names in lowercase letters. This will make the data more consistent and easier to process and analyze. Kyle also wants to add the stock keeping unit, or SKU number, to each product to help track product stock quantities. To do this, Kyle needs data enrichment. Data enrichment is the process of adding additional information to data. This can be done by adding new fields to the data or joining the data with other data sources. Kyle uses the data enrichment tool to join product names from the database to SKUs in a product catalog. This will add an SKU for each matching product in the database. Kyle then uses these SKUs to help the retailer better track inventory and manage sales. Once Kyle standardizes the data to make it consistent and enriches it with new information, Kyle then needs to format the data in a way that works with the destination storage. Data conversion is the process of changing the format of data to improve compatibility, readability, or make data more secure. This can be done for a variety of reasons, like to make the data compatible with a different system or application, saving storage space, or to make it easier to understand and use. Because the data is large and complex, Kyle needs to compress the data before moving it to the destination storage. So, Kyle uses a series of tools to read the CSV and convert it into Parquet. Parquet is an open source file format that sorts data as columns and optimizes the data for efficiency and analysis. So, to recap, data standardization, enrichment, and conversion are 3 techniques you can use to manipulate your data and make it more useful. And, as a cloud data analyst, ultimately the techniques you use will depend on your data and your business needs. Understanding the different options and how you can apply them will help you choose the best way to prepare and manipulate your data. This will ensure that your data is in the best shape possible for storage and analysis. When data moves through a data pipeline, it typically goes through 3 stages: extract, transform, and load, or ETL. In the extract stage, data is collected from various sources. In the transform stage, data is cleaned, manipulated, and enriched. And in the load stage, data is moved to a new place where it can be used for analysis. To help you better understand what happens during the load stage, let's start with an example. Let's say you want to donate some items to a local charity. First, you sort through your belongings and collect what you want to donate. Then, you clean up everything to make sure all the items are in tip-top shape. Finally, you load the items into a charity truck so they can be used by others. Collecting the items to donate is like the extract stage in a data pipeline. Cleaning up the data is like the transform stage. And the loading the items onto the charity truck is like the load stage. The load stage of the data pipeline moves the data into the destination storage. While the load stage is typically the last stage of a data pipeline, this is not always the case. In an ETL pipeline, which stands for extract, transform, and load, the load stage is the last stage of a data pipeline. But sometimes as a data analyst, you will load the data before you transform it. When this happens, it's called an ELT pipeline, meaning extract, load, transform. But no matter when the load stage happens, the load stage has the same goal: taking data from a staging area and putting it in storage. Here's how it works. Before loading data can be put into storage, you first need to prepare the destination storage. This will ensure the destination is ready to receive the data. Depending on the data, this might involve creating new tables or directories, or configuring the destination so it can accept the data. Then, once you prepare the destination, you're ready to load the data. Common ways to load data include batch loading, streaming loading, and incremental loading. Batch loading is a method where data is moved to a destination storage in groups called batches at a predetermined schedule. Batch loading is the most common way to load data. It's efficient for large data sets, but it can overload the destination storage if the data volume is high. Streaming loading is a method where the data is moved to destination storage in a continuous stream as soon as it becomes available. Streaming loading can be a good choice for time-sensitive data. This is because streaming loading ensures that the data is available in near real time, which can be critical for making timely decisions. Streaming loading can also help prevent the destination system from being overloaded. Unlike batch loading, the data in streaming loading is processed as a continuous stream, even one record at a time. Incremental loading is a method where only the data that has changed since the last load is moved to destination storage. Incremental loading is a great way to save time and resources when loading data, especially for large data sets that change frequently. How often data needs to be incrementally loaded will depend on a few factors, like the size of the dataset, how frequently it changes, and the performance requirements of the destination system. After loading data, it's important to verify its integrity and accuracy with a final check. This ensures the data is ready for analysis. When you work with large data sets, you may find data loading is a complex process. That's why many data teams use automated tools to help load data efficiently and avoid data loss and errors. Even if your team uses automated tools, it's still important to understand how the data loading process works. The data loading process impacts the quality of the data that you'll analyze and helps drive decision-making across your organization. An important role on any assembly line is the quality control inspector. The quality control inspector's job is to make sure that all the products meet the required standards and are ready to be sent to consumers. For example, a quality control inspector on a toy car assembly line may inspect each car for mistakes, like missing or damaged parts. They may also compare each car to pre-written specifications to ensure they meet the required standards. All of this is done to ensure that each product meets quality standards and is ready to be used by consumers. An assembly line inspection is a lot like data validation in a data pipeline. Data validation is the process of checking and rechecking the quality of data so that it's complete, accurate, secure, and consistent. Data validation is a part of the extract, transform, and load, or ETL stages, in the data pipeline. The data analyst can do this at any of these stages, but it's especially important in the load stage, when the data analyst moves the data into the destination storage. That's because it's the last chance to fix errors before the data is used for analysis and reporting. Like other processes, the exact technique a data analyst uses to validate data will depend on the data they process and the organization's business needs. Some common ways to validate data that a data analyst can use include checking for type, format, uniqueness, correctness, and null values. Let's explore each in more detail. For example, consider working as a data analyst for an international nonprofit organization that collects data on donations made to its website and over the phone. The nonprofit's data team stores this data in a donor database that includes information such as donor name, donor zip code, and donation amount. For the donor zip code field, you want to make sure that it's a number data type and not a string. You can use type validation to make sure the data is the right type. You can use format validation to make sure the data is in the correct format. For example, if the values in a field should be formatted as dates, your validation process should check to make sure they're formatted in the same way. You can use duplicate validation, also called uniqueness validation, to check that there are no extra copies of records in the dataset. For example, if you have a table of donor records, you want to make sure that there aren't two donors with the same name or with the same email address. You can use range validation to check that the data is with a valid range. For example, if you have a field for the donor's age, you would want to make sure that the age is a number that is between 0 and 130. You can use null validation to check for null values in the dataset. Null values are empty or missing values, and they can cause problems with data analysis and reporting. So what happens when you can't validate data? That depends on the validation rule. Validation rules are a set of instructions that specify the standards that must be met for data to be valid and how to handle data errors. Sometimes, you may discard the data you can't validate. You might do this if the errors are too complex to fix or if the data isn't critical. For example, if a donor's age is outside of the valid range, you might remove this data. You may also load the data into storage as flagged. Flagging data that you can't validate alerts users that need to fix the data before use. For example, if a donor's email address is misspelled, you might flag the data and fix it manually. Finally, your data may be corrected automatically. For example, if a donor's zip code is invalid, the address may be matched against the database to correct the mistake automatically. To sum up, data validation is like quality control for data. As data moves through a data pipeline, it's important to make sure the data you're analyzing is complete, accurate, and consistent. This will help ensure that when you use the data for analysis, the insights are reliable and you can get the most out of your data. Hi there! Congratulations on completing this section on data pipelines. As a data analyst, now you know how data pipelines can help you address business needs and can put them to work. During your journey, you learned the importance of data pipelines and how they can help you address your business needs. Let's review what we covered in more detail. To get you started, we reviewed data pipelines, their place in the data journey, and their role in transformation. Then, we explored the 3 stages of a data pipeline: extract, transform, and load, or ETL. First, you learned about the extract stage, including the differences between batch and streaming data ingestion. Then, you explored the transform stage and how data is cleaned and manipulated for storage and analysis. Finally, you reviewed the load stage of a data pipeline, including data validation and monitoring. Data pipelines can be complex, but learning about how data is collected, transformed, and made ready for storage and analysis is important for a cloud data analyst. Congratulations on continuing your journey through cloud data analytics. Hi there, and welcome. Now it's time to make some room in your toolbox for some new data analytics skills. In this section, you'll explore the challenges of data transformation in the workplace and learn the strategies you can use to get the most out of your data. You'll also be ready to apply these strategies to meet businesses' needs on the job. Just like a fine craftsperson, first, you'll take steps towards measuring the benefits and challenges of data transformation. As a cloud data analyst, you'll work with the volume, velocity, and variety of data that large organizations generate daily. And you'll consider a blueprint on how you can help organizations make use of that data. Next, you'll learn the importance of designing a data transformation plan that uses effective strategies to find the value in these vast volumes of data being generated every day. After that, you'll dive into how data transformation is used in the workplace. This includes how to extract meaningful insights using aggregations and deduplication strategies to handle duplicate data. Finally, you'll learn strategies to join and derive data effectively. Data transformation is a key skill for cloud data analysts in organizations of all sizes. Are you up for the challenge? Hi. In this video, you will learn about the challenges that face data teams when transforming data in the workplace and why it's important to have a reliable and high-quality data transformation plan. Data is an essential raw material that drives business decision-making. But in recent years, the amount of data being managed and stored by organizations has grown tremendously. As a cloud data analyst working with large data sets, you'll uncover the value of the vast, ever-growing intake of data to help provide critical insights to you, your data team, and your stakeholders. But implementing a data transformation plan can be challenging, especially when it comes to resources and data integrity. Let's break these two challenges down. Data transformation can be resource intensive. First, you'll need access to enough computational power to process large data sets. In the past, this meant investing in expensive computer hardware that could perform a very large amount of calculations, also called computational loads. With the advent of cloud computing, you can now access computational power virtually. This is a game changer for data teams, as they can now perform data transformations without having to invest in expensive hardware. But even though cloud resources are easy to use and cost-effective, you still have to include the cost of cloud services when planning your project. Data transformation can also require a lot of storage. Extract, Transform, Load, or ETL, and its counterpart, Extract, Load, Transform, or ELT, are pipelines for data transformation. As a cloud data analyst, you use pipelines to take raw data from various data sources, process the data, and then store it in a warehouse or a lakehouse for use in analysis and visualization. But sometimes you don't use all of the data stored. This can cost organizations unnecessary storage fees. To prevent these fees, you must effectively manage storage usage. This means regularly reviewing the data that's stored and deleting any data that you no longer need. Finally, it can take a lot of time and effort to transform data. Data transformation requires many people with the right skills to execute the data transformation plan. For organizations with smaller budgets, this can be a challenge. So, it's important to utilize the resources of cost-effective cloud services. Not all the tools you use for data transformation are the same. Some tools are better for certain tasks than others. As a cloud data analyst, you'll need to learn about the different tools available when you work with data in the cloud and how to use the right tools for your specific needs. While resources are usually the largest cost for any organization, data integrity may be the most significant ongoing challenge for a data team. This is because even a small error in data can have a big impact on the results of a data transformation project. Data integrity is the accuracy, completeness, consistency, and trustworthiness of data throughout its lifecycle. Errors in the data can impact data integrity before and during the transformation process. Errors can occur in three primary ways. Mistakes, like typos and other data entry errors, can introduce issues into data. And machines can also insert bulk reading errors into the data. These errors can cause data integrity issues if the data is not cleaned before transformation. Errors can also be introduced during the data transformation process. For example, converting data from one format to another can introduce errors like incorrect data types, missing values, and incorrect formatting. Likewise, using the wrong aggregation method can cause misleading results. If these errors aren't caught before the data is stored and assessed for analysis, mistakes can end up in the data used for reports and dashboards. And this can compromise the integrity of the data used for decision-making. While you can never eliminate errors completely, it's important to have an effective plan to help manage data integrity and minimize mistakes. This will help ensure that stakeholders have the best data they can to make the decisions they need to drive the business forward. As a cloud data analyst, you'll be responsible for finding value in the increasingly complex and massive amount of data that flows into your organization. This can be a daunting task, so it's essential for making informed decisions and driving business growth. To do this, you'll need to have a data transformation plan. This plan will help you manage your resources and ensure data integrity so that you can provide critical insights to your data team and your stakeholders. Hi. In this video, you'll learn how to use data aggregation. Aggregation is one of the most common transformation techniques you can use to gain meaningful insights from your data. Data is coming from everywhere. Smart devices and machines, websites, social media and videos, and more of it's arriving in near real time. All this data is an opportunity to foster a more data-driven culture. But it's also a challenge for data analysts because of the sheer volume, variety, and velocity of this data can be overwhelming. One technique that can help you get control of that data is data aggregation. Data aggregation is the process of gathering data and expressing it in a summary form. Aggregation can help you extract meaningful insights from data in 3 ways: by managing data, by making data more accessible, and by helping you observe data trends. Let's break down each one. Due to an increase in the volume and velocity of data in recent years, businesses around the world face a rising need to acquire more and more data storage. In reality, businesses don't actually need all the data they store. And here's a pro tip. Not all data is relevant or should be stored forever. Irrelevant data takes up storage space and makes it more difficult and labor-intensive to find the data insights you need. To reduce the data clutter and reduce irrelevant data, you can use aggregations. Let's explore an example. Every time a person clicks a link on a company's website, multiple data points are generated, including the exact time the link is clicked, the IP address, and the browser type, to name just a few. On a busy site, this can create a massive amount of data being generated. But not all of the data generated is relevant and useful. Aggregation can help you clean the data so that only meaningful data is stored and irrelevant data is removed. To return to our example, 2 important metrics the business's data team wants to track include the number of times a specific link is clicked per hour and the date and time of each click. This data will help the marketing team plan their ad buys and forecast future traffic. The rest of the data generated each time the link is clicked is not relevant to the business question. So, by scheduling an aggregation to count the total clicks each hour, the raw data is reduced to a single data point, the average number of clicks. This aggregated metric can then be stored instead of the raw data. Using this strategy allows you to better manage the amount of storage needed while providing a metric that's useful for analysis. Aggregation can also help make data more accessible to the data team by reducing the amount of data they need to work with. For example, since the single data point, the average number of clicks per hour, is stored, the data team can simply query that metric without performing calculations. This can save time and effort. Aggregations also make it easier to spot trends in data. Knowing the data trends helps data teams provide analysis and visualizations so the business can make informed decisions. For example, since the data team can easily query the average number of clicks per hour, they can chart the data to better understand how the data changes over time. The marketing team can then use this insight to determine when the website link receives the most clicks. They can use this information to better plan their ad buys and forecast future traffic. Of course, that's just one example of how data teams can use aggregation to manage storage, make data more accessible, and help users spot trends. Aggregation is a versatile tool to use in an organization's overall data transformation plan. The possible benefits to a business are endless. Hi. In this video, you will learn about one of the most common errors you'll deal with as a cloud data analyst: duplicate data. Duplicate data is a record that repeats the information, in whole or in part, of another record. There are 2 types of duplicate data: partial duplicates and exact duplicates. Partial duplicate is a record where only part of the data repeats another record. Let's explore how this works with an example. A science organization database holds information about members from around the world, but they may have a duplicate. 2 records have the first name Eli, the last name Arnaz, and the exact same Madrid address. But one of the records has the phone number 1223555, and the other one has no phone number listed at all. Exact duplicate is a record where all the data repeats another record. For example, let's say the organization's data analyst reviews the database and notices that one entry was entered with exactly the same information, including name, address, and phone number, twice. No matter how the duplication happens, partial and exact duplicates can damage data integrity. This can lead to inaccurate reporting, wasted resources, and increased storage costs. Let's consider another example. In this case, the organization's data analyst wants to know the average price of merchandise sold in the last month. But when they aggregate the monthly sales, the result is higher than expected. What went wrong? They take a closer look at the database and spot the error. There were duplicates. One shirt that sold for $20 had been entered 3 times. This overrepresentation of that value skewed the data. Ultimately, when the data was aggregated using average, the results were skewed. But once they remove the duplicate data, the data set is no longer skewed and they can get the accurate metric. Duplicate data can also cause wasted resources for organizations. Next, consider an example of wasted resources. In the hopes of improving merchandise sales for the next quarter, the head of the science organization's marketing team wants to send an advertisement with a list of all the merchandise available to each member. They know that each time an address appears in the dataset, the member will receive an advertisement, and if the member's address appears more than once in the dataset, the member may receive multiple ads. So, they ask the organization's data analyst for help. Good thing too, the data analyst knows what to do. They find and remove any duplicates in the data before the ads are sent out, making sure that each member receives only one ad. This action preserves the organization's marketing budget for avoiding extra costs. Of course, in these examples, the data sets are small, making the errors easy to spot and the cost of wasted resources negligible. But imagine scaling these errors to the size of big data, where there may be millions of rows and many duplicates hidden in the data. With datasets of that size, finding duplicates can be tricky. Duplicates also take up storage space, which can lead to redundant data that bloats your storage and increases storage costs. Deduplication is the process of eliminating a dataset's redundant data. And deduplication is an important part of an organization's data transformation plan. Data analysts can perform deduplication manually, but they usually use automated deduplication tools. Data analysts use manual deduplication to compare rows of data to identify duplicate values. This is a good option to fine-tune small datasets, but it can be time-consuming and inefficient for large datasets. Deduplication tools use algorithms to compare chunks or blocks of data. This is a more efficient way for data analysts to find duplicates in large datasets, especially partial duplicates. Whether working with small datasets or big data, duplicates negatively impact data quality and can cause inaccurate insights. That's why it's so important for data teams to have a plan to deal with duplicate data. Hey there! In this video, we'll explain joins, a powerful tool that data analysts use to combine data from different tables. As a cloud data analyst, joining tables efficiently can be tricky. Two common challenges you may find when joining tables are missing data and null values. Missing data is when the rows you expect to be returned do not appear in the join table. But not all missing data is a problem. Missing data is usually the result of the type of join that a data analyst selects. This is why it's important to understand the inner and outer joins and their impact on the data returned. An inner join is a join that returns the rows that match in both tables. Let's consider an example to find how this works. Kenji, a data analyst, wants to join an inventory and information table. Both tables are related by a shoe ID column, which contains the shoe inventory number. To find the matching data, Kenji chooses an inner join. But when Kenji reviews the join table, some rows are missing. This is because an inner join only returns rows that match in both tables. Any rows that do not match are omitted from or dropped from the join results. For example, the row with shoe ID of 3 appears in both the inventory and information tables, so it's included in the join table. But the row with the shoe ID of 9 only appears in the information table, so it's dropped. To drop fewer rows and return more data, Kenji can use an outer join instead. An outer join returns both matched and unmatched rows from one or both tables. There's 3 types of outer joins. Left outer joins return all the rows from the left side of the join clause and only match rows from the right. Right outer joins return all the rows from the right side of the join clause and only match rows from the left. Full outer joins return all the rows from both sides of the join clause. Kenji decides to use the most common outer join, a left outer join. Kenji places the inventory table to the left of the join clause to return both matched and unmatched rows from that table. Kenji then adds the information table to the other side of the join clause. Only the matched rows return from this table. The left outer join results in more rows being returned, including both matched and unmatched rows, but it also introduces a new challenge for Kenji. Some rows in the join table will have null values. The unmatched values in the inventory table are represented as null values in the join table. Let's explain what these null values are. A null value means there's no available value for a field. In the case of an outer join, a null means that no match could be found, so the value for that field is absent. Here's a pro tip. Null values are not zeros or blank data. It's also important to remember that null values are also not the same as zeros. This can actually be useful to you as a data analyst. For example, when you return all the data from one table, even if there's no match in the other table, you provide a placeholder for a value that you have yet to determine, or collect and add to the table data. While null values are the intended behavior of outer joins, they can be confusing. For example, it can be hard to tell the difference between null values that are a result of no match with the join and null values that existed in the data before the join was done. This can impact your results. When using an outer join, it's important to think about how your specific data set and how null values may impact your analysis before deciding on an outer join. So, there you have it. While joins can be tricky, understanding the why behind missing and null values will help you, as a data analyst, join data more efficiently and provide useful insights. But Like all data transformation strategies, the best approach is the one that makes the most sense for your data needs. To find the answers to tough data questions, sometimes you need to combine data in a new way. For example, say you want to find the total points earned by the top 3 players in a chess tournament. You have the points of each player, but to find the answer, you need to find the top 3 players' scores and then combine these scores to create a new metric, the total points scored by the top 3 players. In data analysis, to unlock insights like this, you can use data derivation. Data derivation is the process of combining and processing existing data using an algorithm to create new data. The data derivation process starts with raw data, sometimes called base data, that already exists in the dataset. This base data is then transformed using an algorithm, which is a process or set of rules followed for a specific task. The algorithm derives new data. Data analysts can use this new data to uncover insights that aren't available directly from the base data alone. Let's explore how this works. Anya, the manager of a large shoe company, has a business request for the data team. The accounting department has identified that shoes that stay on the warehouse shelf too long are usually only sold at a steep discount, cutting into profits. To help track how long shoes stay on the shelves, Anya has asked Kenji, the data analyst, to create a daily report of the shoes that have been on the shelf for 30 days or more. But that raw data does not currently exist in the dataset. To provide Anya with the data she needs, Kenji will need to use data derivation. To start, Kenji explores the existing data. Kenji's goal is to find and transform the base data to create the report Anya needs. Kenji learns that warehouse workers scan and date timestamp each pair of shoes when the shoes reach a warehouse shelf. Warehouse workers record this information as the arrival date timestamp. Kenji realizes that it's possible to use this arrival date timestamp data to create the new derived data. In this case, the algorithm that Kenji needs is a simple calculation that uses the shoe inventory number and the arrival date timestamp to calculate how long each pair of shoes is on the warehouse shelf, and then convert the calculation into a formatted report to help Anya make decisions. Using this algorithm, the arrival timestamp value for each pair of shoes is processed, resulting in derived data. Kenji can then query the derived data as if it were an actual table in the database to analyze and visualize the data as a daily report for Anya and her team. This daily report gives Anya a simple way to interact with the most up-to-date information about the warehouse shoe stock so she can make timely, data-driven decisions. Anya will know which shoes in the warehouse should move to the sales floor before they lose value. While working with derived data is a great way to increase performance and provide more in-depth insights to stakeholders, data derivation does pose some challenges for you as a cloud data analyst. One of the challenges of derived data is accuracy. Derived data is processed data and is not always as accurate as the original base data. This is because when you create derived data, you take raw data and apply an algorithm to it. If the algorithm has an error, it can insert errors into the data. Also, the base data itself can have errors or may even change after the data is derived. So, while you can use derived data for analysis, you need to be careful when using derived data to create new derived data. You should also be aware of data ownership and privacy issues when working with derived data. For example, let's revisit the shoe company. When Anya hires a new worker to staff the warehouse, the worker provides personally identifiable information, or PII, as part of the hiring process. At that time, the new hire was aware that the data was being collected and consented to its use. But this consent does not apply to future uses of the data. This makes it essential that any derivations involving PII are handled with the utmost care and follow all existing policies and regulations. So, to recap, transforming existing data into new data is a valuable tool for cloud data analysts. It can help you, as a data analyst, unlock insights that aren't readily available in the existing data alone. And, when done with care, it can be a powerful strategy for answering more complex questions with data. Congrats, you've made it. In this learning journey, you've delved into the challenges of transforming data in the cloud and how to get more value from your data. You learned about different strategies and practice using them. First, you focused on the benefits and challenges of data transformation for organizations that work to find value in huge volumes, velocity, and variety of data. Then, you applied what you learned to design a data transformation plan that helped a marketing team solve a job-ready business problem. Next, you dove into data transformation strategies, including ways to extract meaningful insights using aggregation and data deduplication strategies. You also explored ways to create new insights with derived data, work with nulls, and effectively use joins to gain a more holistic view of your data. Congratulations on your progress so far.
Confidence is very important, and something that one of my first managers ever told me is it's not what you know, it's how you say it, and it's something that I continue to tell myself day after day. My name is Lauren, and I'm a cloud sourcing lead. What that means is my team is responsible for reaching out to candidates for our open roles within the cloud organization. The 3 top things that a candidate should do when updating or creating their resume is first, tailor your resume to the job description. You want to make sure you're pulling out keywords and key indicators that match your experience to ensure that the recruiters can see pretty quickly the experience that you have that's relevant to the job description. Secondly, do not exaggerate or do not lie on your resume. That probably goes without saying, but anything on your resume is technically fair game. It can be asked in an interview, so you want to make sure that you're being as accurate as possible. My third tip would be keep it concise, keep it short. We definitely want to make sure that we can get all of your experience, but you can cut things out. That's okay too if it's not relevant to the job. What makes a resume stand out for a recruiter or a hiring manager is an organized resume. You want to make sure you have clear headers, it's in chronological order, and you have short and concise bullet points. Some ways that candidates can demonstrate their technical skills in interviews is to talk out their thought process and the answer to the questions they are asked. The process of how you get there is just as important as getting to the correct answer. Some common interview question types are problem-solving based questions, experience-based questions, and also leadership-based questions. The best way to answer a hypothetical question is really just talking through your thought process. You're going to get a scenario, something that you may or may not have experienced before, and your interviewer just wants to see your thought process, how you're connecting the dots as you're talking through your answer. The best way to answer a behavioral-based interview question is really leaning on your own personal experience. This could be a personal experience from a previous job, from school, from a class, and talking through that experience and that thought process. It's very important to ask follow-up questions throughout the interview. First and foremost, you want to make sure you're understanding the question that's being asked. You have a very limited amount of time with your interviewer, and you want to make sure that you're spending it as productively as possible. I think some candidates worry that it's bad to ask questions. I love when candidates ask me questions. I want to make sure that my candidate knows what I'm asking so we can get to the best solution. Workplace skills are absolutely important during the interview process. These are skills that can't be taught. Are you kind? Are you empathetic? How are you showing up? Do you have that eagerness to learn or to thrive in ambiguity? We really want to see candidates that have that self-drive and that self-determination. A candidate can best position those workplace skills just on how they're simply answering their questions, especially in those behavioral questions. Like lean on those examples that show your grit, that show maybe a struggle that you had and how you overcame it. I'm not looking specifically for something that happened perfectly the right way. I'm looking for someone that maybe had to overcome some obstacles to get to the right solution. Candidates hold a lot of power in the interview process. We want you to be successful. We want reasons to say yes. So please show up, be your authentic self, be confident, and show us all the amazing skills that you could bring to the company. Hi, I'm Lauren.
Hi, I'm Ella.
Let's step into an interview room and watch an interview that's in progress. In this interview, the questions will focus on cloud data analytics topics related to the data journey, from collection to insights.
We hope this will give you some tips for your next interview.
What interests you in a job in cloud data analytics? What are you looking for in a role?
I'm really fascinated by the way that cloud data analytics is going to transform businesses. So the ability to access and analyze massive data sets and datas and gain a deeper understanding about customers, organizations, and markets is going to revolutionize different industries. And one thing that I'm really passionate about cloud data analytics is how it plays a role with machine learning and artificial intelligence. Imagine having access to large amounts of data with very powerful algorithms. You can develop sophisticated models that can help you predict outcomes, automate some tasks, and also create personalized recommendations for customers. For my next role, I'm looking to be in more challenging projects and use my cloud data analytics skills to solve real-world problems.
Tell me about a cloud data analytics project that you worked on. What did you like most about it, and what were some challenges?
The most interesting cloud data analytics project that I worked on was a project with a large retail company. The goal of the project was to gain a deeper understanding of the company's customer base and how we can create targeted marketing campaigns. The project involved collecting and analyzing data from a variety of sources. This would be their demographics, online behavior, their purchase history, and we used a variety of data analytics tool sets to retrieve and clean and prepare this data. And our results was understanding that there are distinct customer segmentations within this company, and we provided them with a set of recommendations on how to target these segmentations and how to create relevant marketing messages. And because of what we did in this project, the company was able to increase their conversion rates and customer engagements because now they're able to relay a little bit more targeted messages to their customers. The most enjoyable aspect of the project was the ability to have access and work with large amounts of data sets and learning along the way new cloud data analytics tools and techniques.
Let's suppose you're working on a project to help a cloud data team combine data from different sources. What considerations would you think about to make sure users got the most out of their data?
There are a couple things that comes to mind. One is data consistency and data quality. The second one would be data schema and relationships. Third would be data security and governance. And lastly would be data accessibility and usability.
Tell me about a time when you had to derive data from a raw data set that you received. Describe your process and any challenges that you experienced.
I worked with a large e-commerce company. The raw data included product clicks, page views, and their online behavior. The process included me using machine learning techniques like natural language processing to understand the customer behaviors in different segmentations and based on the product reviews. And then later, I use clustering algorithms to put customers based on their behaviors into different segmentations. And because of the machine learning techniques that I use, I was able to automate some tasks. This really accelerated the process and increased the accuracy of our results. We wouldn't able to get to the results that we did without these techniques.
Great. Do you have any questions for me?
What are some key attributes that would make me successful in this role?
Great question. Some key attributes to being successful in this role is really just bringing that natural curiosity, problem solving, and determination into your day-to-day. This is a very collaborative role, so you'll be working closely with your teammates to get to the right solution. In this scenario, Ella demonstrated how to explain impact with answering questions. When interviewing, make sure to explain the beneficial effects of any process, concept, or tool discussed.
Congratulations on finishing this course. I hope you're ready to use the new data analytics tools in your toolbox and put your new skills to work. My favorite part about working in cloud data analytics at Google is helping customers get to that aha moment while analyzing their data. This moment usually comes from finding a key insight they previously didn't know about before, which can drive really impactful decision-making and have a positive impact on their business. While it might seem daunting at first to find the key insight in the massive amount of data businesses produce every day, the techniques we're learning can help accelerate your insight investigation and lead to truly transformative work. Now, let's go through all the things you learned in this course. You started by learning about the data journey, including data collection, processing, storage, and transformation. Next, you explored the data pipeline and the various methods for extraction, transformation, and loading. Then, you discovered how to meet business needs with a data transformation plan and transformation strategies. You now know all about data transformation, the key to preparing quality data that leads to actionable insights. Great work throughout this course. Congratulations on this milestone.
Welcome. In your work as a cloud data analyst, communicating your findings to all different kinds of stakeholders is an essential part of your job. One key form of communication is data visualizations. Visualizing data in the cloud is critical for you and your data team to best understand the data. Then, you can effectively influence stakeholders so they can make the best business decisions. Let's scope how you might turn seemingly mundane numbers and text into vivid illustrations that provide a business with engaging inspiration through the power of data visualization. Data visualization is the graphical representation of data using charts, graphs, and other visual formats. These visualizations help users interact with the data, understand what it's telling them, and make data-driven decisions. Before starting this course, you should have some familiarity with how data is stored and accessed on the cloud, and a basic understanding of how it's transformed for analysis. It's also helpful to know some SQL, which is structured query language. This is the most common way that humans talk to relational databases. Having some familiarity with querying foundations is important too. But before we get too deep into it, let me introduce myself. Hi, I'm CJ. Here at Google, I'm a cloud customer engineer. This means that I act as the technical expert on account teams that sell Google Cloud data and analytics services to some of the largest retailers in the world. I've worked in the data and analytics space my entire career. In my current job, I help companies to understand how Google Cloud can help them to leverage their data assets to derive insights and drive business outcomes. As a cloud data analyst, you'll work with a variety of tools that simplify the process of creating data visualizations. But don't worry, no artistic background is necessary. The tools you'll learn have a variety of great features designed to help you communicate your data insights effectively. So, we'll start this section of the course with data storytelling and how to captivate your audience using insights from the cloud. Then, we'll get into the basics of user experience, or UX, and user interface, or UI, designed to create compelling communication. Next, you'll explore how to translate a data story and create a visualization plan that meets business needs. You'll start by learning the implications of data types on design. For example, we'll cover how data types inform a data analyst's visual representation choice. You'll then learn how to examine common design patterns used in business intelligence dashboards. Then, you'll focus on ways to work with stakeholders to translate stakeholder requests into visualizations that get results. You'll also apply what you've learned about communicating with visualizations by taking your first steps towards accessing, exploring, and reporting on data in the cloud. To accomplish this, you'll discover how to access a data set for visualization and explore that data. Then, you'll learn about dimensions and measures and model data for visualization and work with Looker, a visualization tool, to build a simple dashboard. Next up, you'll work with large data sets and use business data visualization tools that can work on a large scale, integrated security features with robust functionality that fits within the IT infrastructure. This involves strategies for fostering a data-driven culture among organizations of all sizes and keeping data organized and secure. Finally, you'll step into the role of a developer who works with data modeling languages and advanced tools. You'll explore the developer environment, model data with a data modeling language, learn tools to write dashboards as code, and use a data modeling language to address complex business needs. Learning how to visualize data in a way that's helpful and comfortable for both technical and non-technical users is a foundational step for your role as a cloud data professional. Providing visual data that everyone can understand also helps to improve data literacy across your organization. Impressive, right? Okay, let's get started. Hi, I'm CJ. Here at Google, I'm a cloud customer engineer. This means that I am part of the technical arm of the sales team. I help Google Cloud customers understand how our data and analytics products work, and more importantly, how they can work for them to deliver value for their specific use cases. My primary job responsibilities include building and delivering customer demos, leading proof of concept engagements, hosting technical information sessions, and collaborating with our product teams to relay and interpret customer feedback. This feedback loop is critical in shaping the evolution of our products and delivering a better experience and more value to our customers. A typical day for me may include reading up on and trying out new cloud products or features. I may also meet with customers to share information or learn more about challenges they are trying to solve. And then I might collaborate with colleagues to design and build a new demo. This is all in addition to internal tasks I take on to help grow the organization in various ways. This role is very dynamic, and that's one of the reasons I really enjoy it. In my role, I talk a lot about the value of data and the potential value that some of these tools can unlock. At some point, you've got to stop talking and take action. I recently had this experience with a customer. After several conversations and a couple of demos, they said, "That's great, but what can you show me with my data?" I replied, "Give me 30 days. During those 30 days, I used the techniques and tools discussed in this course to explore and model their data and bring to life several stories in the form of dashboards that were hidden in the disparate data sources. The customer was amazed at seeing their data presented in such novel ways. It's those types of reactions that motivate me to do this work. What's your motivation? I don't know everything, but I've learned a lot in my career. So for you aspiring cloud data analysts, here are a few pieces of advice. Break tasks into small, manageable pieces. You will undoubtedly be assigned a task that feels daunting at some point in your career. By breaking large tasks into smaller pieces, you ensure you can deliver with confidence. Set realistic expectations for delivery. This ultimately helps both you and your stakeholders be successful. Work iteratively. Let the first draft be just that, a first draft. Get something out there. Get feedback and improve on it. Always be learning. In this field, change is constant. Keeping up with advancements in tools and best practices is key to staying relevant. Know your audience. How much you know is usually less important than how effectively you can communicate it. Imagine a cloud data analyst that is rising in the ranks within their data team. They've just received an exciting opportunity to grow their skills in storytelling with data. Let's turn to the first page. In this section of the course, you're going to discover some great strategies to become a storyteller with cloud data. Along the way, you'll encounter the basic principles of UX and UI design and how those concepts influence your role as a cloud data analyst. This might include creating a dashboard your stakeholders will love interacting with, or designing a simple chart to convey a complex idea. After that, you'll explore the foundations of visualization layout, organization, color, usability, and accessibility, along with how each of these elements combine to create effective design. Finally, you'll identify how to communicate through design for both technical and interpersonal concepts to convey interesting and valuable data stories to any audience. All right, let's begin. A great story needs captivating characters and an intriguing setting. With fiction, we can use our imaginations and experiences to create a thought-provoking message. But to tell a data story, we need, well, data. Using cloud data to craft your narrative provides you with more options than working with local data alone. Let's find out how. Before the introduction of cloud data and cloud data analysis tools, data analysts would only have the ability to work with data that was locally available, meaning they would have to collect, track, and manage everything they needed to do their analysis. But today, centralized, organization-wide cloud data warehouses make it possible to capture the entire context, rather than in individual data sources in isolation. One of the biggest benefits of working with data in the cloud is access to a greater variety of data sources, including external and public data sets, along with application data, like Salesforce and Google Analytics. Data professionals can harness all of this data to add depth to their analysis and enhance data storytelling. Let's consider an example with a clothing retailer. Their sale and inventory for each location is kept in a database on site. Additionally, the marketing team enters all their campaign data locally in Google Sheets. Because the databases are not connected, there's no way for one store to know the inventory of another, or for the marketing team to learn what brands are selling or not selling. These various and distributed storage locations are called data silos. A data silo is a collection of data held by one group at a central location. Data teams have used data silos as their traditional approach to storing local data. Because data silos store data locally, silos limit access to data organization-wide. As a result, data silos make robust data storytelling and collaborating across teams challenging. Plus, data silos can contribute to a lack of data integrity because they tend to get out of sync and can cause widespread discrepancies. You can think of these as gaps or inconsistencies in your data story's plot. Now, with cloud-based data analysis, Data professionals across the globe can pull information from multiple data sources and combine them into a single, cohesive report or visual that conveys a clear data message. This helps teams craft fascinating data narratives and understand data trends in the context of the broader organization. Returning to the clothing retailer example, the clothing retailer's cloud data team can use cloud tools to connect each store's database. Then, the data team can access all data across the organization. So, when marketing needs to know which shirts are selling in each store and which ones aren't, they can use a well-designed report or dashboard that showcases the data for informed decision-making. And when the purchasing department needs to know which brands to buy and which should be discontinued, they can use the visualized data to spot trends and make well-reasoned choices. Meanwhile, the clothing retailer's store managers are no longer limited to their own sales and inventory data. These managers can now collaborate with other store managers to share data between stores and foster growth across all their locations. Say you're a cloud data analyst working for the clothing retailer. You can take your analysis a step further by connecting to external data sources like publicly available datasets, social media, third-party tools, and lots more. This flexibility enables you to create even more context and build even more detailed and expressive stories. For example, your cloud data team can connect to an external database that has information about clothing trends from around the world. This provides context for whether the retailer should spend more time developing or marketing their new collection of sweatshirts, or if they should focus on their existing line of hats instead. The clothing retailer can also utilize the shared data resources to identify opportunities for different store locations to provide better service to their customers. For example, you might find that stores in a specific area aren't benefiting from a promotion because the primary language in that community is different from the marketing language. Because of your analysis, the clothing retailer will be able to better identify how to reach communities that weren't accessible before by offering marketing promotions in the locally used languages. Another awesome cloud data feature is running Google Ads reports. For example, you could show your retail client the regions where their ads are clicked the most, along with that region's historical sales data. This cloud data gives the retailer immediate feedback about which locations are most likely to respond to their advertising efforts. There's so many ways to add value to projects as a cloud data professional. When you incorporate data from multiple sources into your data storytelling, you provide effective and essential context and thought-provoking data insights. The different teams you'll work with, like sales and marketing, will thank you. As a cloud data analyst, you know that it's important to only build a data visualization after studying the data and developing a clear narrative plan. After all, planning data visualizations is fun. And creating data visualizations without a narrative plan would be like setting out on a road trip without having directions to your destination, or packing for that trip without knowing what you'll need when you get there. In this video, you'll learn all about the essential planning phases of the data visualization workflow. You'll discover unique cloud features that support digital consumption, the user experience, and data governance and security. This understanding will help you develop effective visualizations. All right, let's begin with digital consumption. First and foremost, digital consumption is all about understanding the medium through which the cloud data team will interact with the data. Next, it's important to know your audience, who you will share your data visualizations with. But when it comes to digital mediums, you also need to consider how your audience will interact with the data and what they expect from their interactions. As a cloud data analyst, your audience uses information from many places. It's a digital world, and users expect the information to be current and interactive. They also probably want to filter the data to only display the content that's important to them. For example, if you build a dashboard for a large company with multiple locations, the team in each location will be most interested in sales insights from their region. Meanwhile, the product team at the central office will need to compare product sales across all locations. Digital users expect their user experience to be intuitive, easy to use with little or no instruction or explanation. So, your goal is to create visualizations that help digital users quickly and instinctively understand the meaning and purpose of what they're interacting with. An intuitive user experience, along with all of the other key principles of user experience design, help people get comfortable with using digital tools. Finally, utilizing effective data governance and security policies are critical when working with data over the internet. The very nature of pulling information from the internet means opening up the possibility of data breaches, viruses, and malware. So, before building a visualization, it's critical to have a strategy for keeping your data safe. Let's return to the example where you're a cloud data analyst for a clothing retailer. Each store's sales data includes the names and contact information of the sales staff. This is considered PII, or personally identifiable information, and must be handled with exceptional care. So, when you design a visualization that displays the sales data, you'd want to be sure to include only the numbers and not any personal data. Additionally, it's essential to control who has access to information. Maybe an individual store location's team supervisor has privileges to view the most granular information, but team members using the same dashboard would only have access to summary level data. You want to make sure that the dashboard displays what its audience needs to know without including the parts only meant for a few. All right, we've now reached our destination, the end of this video. And because we had a plan for exactly where we were going, we reached our destination without any hitches. Keep in mind, you want to apply the same principles when designing data visualizations in the cloud. And when you do, you'll be on the road to success. As you begin to build dashboards, you'll use a variety of technical skills and tools. But it's important to keep in mind that the purpose of dashboards isn't the technology involved. Rather, it's the communication. What do I mean by that? You're going to use all sorts of technical tools, programs, codes, and markup languages to show the data. But your goal with dashboards isn't to show off your technical skills. Your goal is to communicate the story the data has to tell. To do that, you will end up communicating a couple of different types of concepts. The first is the technical information you convey. At the forefront, dashboards communicate a very specific data story. Think of the different sections of the dashboard or the different visualizations presented as chapters in a book. Each section has something to say, but only by putting the pieces together can your dashboard tell the full story. It does this by building on what has come before and providing context for what comes next. Also, each piece of the story has to advance the narrative in some way, or just clutter. Another important aspect is that each insight is consistently understood by all users. In literature, people usually have different reactions to the same story, but in data analysis, everyone must understand the data story in the same way. Next, pay attention to the size of your visuals. Making one graph bigger than others directs the user's attention to the larger graph. You could do this for visualizations that are more important than the others. It's also good to keep in mind that you're not just communicating technical information. There are many other ways that your design communicates non-technical information to your users. For example, the words and tone you use are important. More complex terms communicate a more formal or professional environment, whereas a casual tone sets a more relaxed and formal feel. Likewise, your graphics can range between simple to sophisticated to playful, depending on the tone you're trying to set. Also, be sure to align your visuals with your organization's brand. This means using your design to support the organization culture and environment through official colors, tone, and graphics. This helps your dashboard become a cohesive part of the corporate toolset. Finally, good design communicates your level of professionalism. An effective dashboard demonstrates all the hard work you've invested in ensuring that users can quickly gain the insights they need. Remember that the purpose of dashboards isn't the technology involved. Rather, it's the communication. This will better prepare you to effectively communicate with your users and create visualizations they'll understand. Designing your dashboards to look professional and be easy to navigate is important, but don't forget that it also communicates so much more. Harness that knowledge to become an even more effective and communicative data analyst. The professional world is full of people who specialize in certain jobs or have unique talents. Teachers know all about educating others. Musicians read music and produce beautiful sounds on their instruments. And coders create applications for people to interact with and perform activities. It would be a very different situation if we all had to learn how to teach, play the trumpet, and code our own apps. It's good to know that users can rely on data professionals to create effective user interfaces that lead to positive experiences. And that's what we're going to learn about in this video. Let's start with some definitions. The user experience, or UX, is the overall experience a user has with a product or service, especially in terms of how easy or pleasing it is to use. The importance of this concept continues to evolve as technology advances to make human-to-computer interactions easier and more intuitive. And a user interface, or UI, is the means through which a user and a computer system interact. So, everything the user experiences on a screen or device is part of the UI. And on a foundational level, the UI allows people to interact with computer software and hardware without needing to understand how to program code. Both of these design approaches are about the user and what they need. As a data analyst, you'll frequently encounter these terms combined in the acronym UX/UI, or sometimes the other way around. Either way, these design approaches are key to your work with cloud visualizations. After all, if the solution you give to stakeholders is difficult to learn, cumbersome, confusing, or they just don't like it, they won't use it. And the goal of data analysis is to provide people with information they can use, especially with data visualizations. Here's an example. Consider a website or app you've used where you couldn't find what you wanted, or it took a long time to find, and it was a frustrating experience. There might even be a website you just didn't like, and you couldn't quite describe why, but you had a negative reaction to it. Now, think about a website or app that was visually appealing to you, and the information you needed was quick and easy to find. The difference between these two scenarios is all about the UX and UI. Having well laid out, well-designed dashboards and reports isn't just about making data look good. It's also about ensuring that users understand what options are available to them, how they can access these options, and what insights they can gain. And it's about keeping your users at the forefront of everything you do as a data analyst. The more you can concentrate on their needs as your ultimate goal, the better you'll be able to design effective, powerful visualizations that bring data to life. If you want each section of a dashboard to be clickable so users can drill down into more detail, there needs to be an indication that lets users know that's an option. In this example, there are no indicators in the first row to let the user know headings are clickable. The second and third rows demonstrate several visual alternatives to indicate a difference between the information section and the other sections. In the second row, the text is bold, and that indicates a clickable link. In the third row, the text is underlined, and there's an icon that both help you to indicate a clickable link. You might also use formatting tools to indicate the ability to act on a particular item, like images, arrows, bolded text, stylized text, and so on. One final point. While the previous UX and UI examples describe visual design choices, keep in mind that as a data analyst, there are other important aspects of design. For example, some people use other types of interfaces, like screen readers. That's why it's essential you consider users with different accessibility requirements in your design. All right, I hope you had a great experience while using this video. Keep investigating UX and UI and considering the many ways that you can enhance the experiences of others when presenting data insights. As you begin developing data visualizations in the cloud, you'll be confronted with a lot of important design decisions. Examples of visualization decisions include, is it insightful? Does this layout and organization make sense? Is it accessible and intuitive for everyone to use? Well, as a cloud data analyst, the answer to all of these questions is always, what's the best for the audience? When creating visualizations, everything you do is for the benefit of your audience or users. For example, you could create a dashboard that looks really nice, but if it's not organized logically, your users will have a hard time using it. And even if your dashboard is well organized, it won't be as engaging if your visuals are distracting. Logical organization is so important. A pro tip to organize your dashboard logically is to work backward, starting with picturing exactly what your audience needs and wants. This information will help you make successful design decisions, because when you know what your audience needs, you can develop your design around their goals and objectives. In the research phase of the data visualization planning process, you'll learn what your users need. This is also referred to as usability studies or user research. There are a variety of ways to learn what's important to your users. Which method you choose depends on a variety of factors, like the type of business or industry, the budget, and what tools and resources are available to you. All right, let's turn our attention to workflows. I'm sure it's no surprise that you'll also want to keep your audience in mind as you begin to develop the more technical aspects of your design. The main point with workflows is to only present what's necessary to achieve the objectives. Consider this scenario. You call a market to check their inventory for a recipe you're making. You dial the option for the meat department, but instead get routed to the produce department. This is an example of a bad workflow. You can also experience complications in technical dashboard designs. So, whenever possible, work backwards to plan around the methods you uncovered during your usability study. This will help you to develop a logical workflow and optimize the user experience. Okay, now prioritize the information to make sure that you're only providing your audience with the information they want or need. For example, you might have uncovered a new feature in the dashboard system, but if it's not going to add value to your dashboard, don't implement it. Adding features that aren't helpful can end up distracting your audience instead of adding value. And that's a wrap. Keep in mind, when you design using great attention to detail, you'll capture your audience's attention and communicate what they need to know, and keep them coming back for more valuable data insights. Hello, and thanks for joining me for this video about turning great data into great visualizations. As a cloud data professional, one of your most important responsibilities is communicating data insights to others. So, let's get started learning about the many factors that influence your design decisions. First, it's important to consider how the solution you're developing will be accessed. For example, will your users primarily be on laptops and desktops, mobile devices, or a combination? For example, if your users mostly use mobile devices, there are a lot of implications to consider to ensure your designs work in the mobile world. The display has a limited size, and too many visualizations can be difficult to manage on a small screen. Instead, you might prioritize the most important visualizations that the display can accommodate. Of course, other visualizations may still be important, so you'll want to find ways to provide access to them through links, tooltips, pop-ups, and menus. Once you implement your solution, another fairly common task is to request user feedback. The first thing to consider here is what method you'll use to collect feedback. You might include a feedback button that links to an online form or email pop-up. Once you collect the feedback, you can incorporate it into your plans for future development. And then you'll decide how to respond to the feedback. The second type of consideration is what type of feedback you want to receive. Are you only interested in being notified of technical issues that need resolution? Or are you also open to receiving development requests? No matter the answer, you'll want to consider how to make the process as easy and efficient as possible. All right, this leads us to the final point. One of your key goals as a data professional is to create a solution that doesn't need any explanation, instruction, or help. Even so, it's always good practice to provide help features and clear, concise, accurate documentation. This helps ensure you've been thoughtful about how your users will experience your data visualization. Great data visualizations offer significant value when they convey meaningful stories and provoke thought. In other words, when your data visualizations are effective, you're playing a valuable part in turning your organization's data into relevant, actionable insights. Attention to detail is a data professional's superpower. It's spotting the little things that others might miss, like finding tiny errors in a dataset, or noticing the subtle differences between two potential project plans. In this video, you'll learn how to apply this concept to data visualization design, so you can also be a data superhero. Let's cover a few strategies that will help you get there. Okay, the first strategy is to keep simplicity and clarity as central design goals. Let's use dashboards as an example. As a reminder, a dashboard is a data visualization tool that visually displays data in one place. When constructing dashboards, you'll want to avoid cumbersome menus, layouts, and workflows. The second strategy is to map a structure that's organized, logical, and intuitive. Also, distribute your visualizations and avoid overcrowding. Dashboards can very quickly become cluttered, making it difficult for users to find what they need. The third strategy is grouping similar data types together. This leads to effective visual inferences that indicate relationships or connections between the information. On the other hand, it also helps create visual separations between data that isn't related. This provides important context and meaning for your users. The fourth strategy is to prioritize usability and accessibility principles in your designs. After all, you want everyone to be able to use and understand your dashboards. You can't rely solely on visuals to convey concepts, as many people use screen readers and other assistive technologies. Accessibility must be an essential part of every data visualization you create. The fifth strategy is to establish a plan for consistently applying colors and textures throughout your dashboard. It's likely to confuse a user if one red visualization means warning and another red visualization means success. Labels should all be the same color as well, unless that color is intentionally signaling a difference between types of items or groups. The sixth strategy is to apply labels and be intentional when constructing them. Poorly worded labels can cause users to miss helpful information or spend time on the wrong part of a visualization or dashboard. As with many areas of design, consistency is key. For example, maybe users refer to a sales dashboard to forecast and identify trends in the marketplace. The first visual is a bar chart that shows the comparison year over year. Just naming it sales doesn't help people understand what the chart is and what information they can gather from it. A better title would be Year Over Year Comparison. Provide clarity when labeling to ensure your axis labels and legends are clear and consistent. This helps the user understand that years are being compared. Also, you may notice that this image is incomplete. There isn't a reference for what the numbers in the y-axis represent. Does this reference dollars, units, thousands, millions? These types of details are essential, so you'll want to be sure that they're clearly defined. Here are some pro tips for achieving consistency in your data visualization design. First, document all terms and definitions in a legend. Then, for consistency, ensure that all visualizations use the same legend definitions. If you find a need to break this rule, make sure it is clearly noted. And lastly, use the same terminology across all parts of your solution, including department names, groups, and teams. Follow these strategies and tips to become a true data superhero. Your dashboard users will love your attention to detail. And just like a true superhero, you'll demonstrate how much you value the needs of others. Hello, advancing cloud data analysts. Congrats on learning how to design and communicate stories with cloud data. In this section, you learned about how to grow your skills in storytelling with cloud data. You can now describe the strategies of user experience, or UX, and user interface, or UI design, plus how those concepts affect your role as a cloud data analyst. You understand the foundations of layout, organization, color, usability, and accessibility, along with how each of these elements interact to create good design. Finally, you now have the know-how to identify the many ways to communicate through design and share both technical and non-technical concepts with your users. Congrats again on your amazing progress so far. Hi there. Welcome to this section of the program all about visualization planning and design. I'm really looking forward to guiding you through these topics about the impact that you can make on data insights. Together, we'll explore the many aspects of design that can influence your choices about dashboards and data visualizations. You'll learn about data type implications on design, which will help you make good decisions about how to present data when creating visualizations. Next, you'll check out business intelligence dashboard types and consider how to select the right type of dashboard visualizations based on user requirements. Then, you'll learn more about working with stakeholders, including how to ask questions that unpack stakeholder needs. Finally, you'll discover how to translate stakeholder requests into a design plan and test its functionality through the use of wireframing. These topics will prepare you for the planning and communication aspects of design and help you create a design plan that you can implement with confidence. Let's get started. Hi, and welcome to this video all about data types. There are many different types of data, and each one has its own unique properties and purposes. Knowing the type of data you're working with is important, especially when designing data visualizations, because it helps you communicate data insights more effectively. So, let's begin by exploring the two basic types of data: categorical data and numerical data. Categorical data, also referred to as qualitative data, is a subjective and explanatory measure of a quality or characteristic. Put in simpler terms, it's data that describes the categories or qualities of the data being collected. Think of things you can name, like countries, industries, or products. Numerical data, also referred to as quantitative data, is a specific and objective measure, like a number, quantity, or range. So it's data that can be quantified, and it describes things that you can count, order, or measure, like ages, test scores, and prices. When it comes to data visualizations, understanding whether your data is categorical or numerical affects your decision-making and design processes. For example, categorical data can be displayed in bar, column, and pie charts to show relationships between data. But this won't work for numerical data, which is best suited to line charts, histograms, scatter plots, box plots, and bubble charts. These visualizations are effective at displaying changes over time, values, distributions, and summaries. Now, there are 5 common ways to visualize data based on data type: single value, comparison, composition, distribution, and relationship visualizations. Let's consider each one of these in detail. First, a single value visualization is simply a query that generates one value that will be used in a visualization. For example, you could display the average points per game of your favorite football player. As the name suggests, comparison charts compare 2 or more values. This type of visualization is displayed in bar, column, and line charts. For example, it's easy to compare the population of the top 10 largest countries with any of these chart types. Next, composition charts compare individual parts to a whole, usually equaling 100%. You'll usually find this information displayed as pie charts, stacked columns, or bar charts. For example, an age distribution chart shows the percentage of people in each age group for a single country where the total percentage equals 100. Comparison and composition charts are the most commonly used in data visualizations. They're also the only charts that effectively display categorical data. Next up, distribution charts. These are great for illustrating if and how data correlates among different data points. 2 variables correlate if they have a relationship and therefore tend to vary together in some way. These charts are very detailed and are useful for displaying differences in averages, means, medians, minimums, and maximums across different variables. Finally, relationship charts also demonstrate correlation. Here, it's between 2 or more variables. These relationships are depicted in scatter plots and bubble charts. This bubble chart shows the growth rate versus median age as a correlation. Distribution and relationship charts are the only charts that effectively display numerical data. One quick final point. Some types of graphs can be used in a couple of different ways. For example, a line chart can show comparison or distribution, depending on how the user should interpret the data. There are tons of programs for designing charts and graphs, so you'll have your choice of several tools to use when creating these different data visualization types. And as you work to figure out which visuals will be most effective for your audience, always consider the data first. When it comes to what transportation we use, people's needs vary depending on many things. For example, some people may travel by bicycle or public transit to run a few errands. Other people may use a car. But if you have a lot of cargo and need to be able to haul heavy loads, you'll probably need a truck. Just like choosing a way to get around, as a data analyst, you'll base the type of dashboard you design on what your users need and how they're going to use the information you present. This video will provide you with many great strategies to address each of these important considerations. Okay, First, there are 4 basic types of business intelligence dashboards: strategic, operational, analytical, and tactical. A strategic dashboard is a very high-level visualization. Typically, corporate executive users prefer a strategic dashboard to focus on long-term organizational strategies and key performance indicators, or KPIs. This type of dashboard usually displays corporate financial performance and revenue trends. Next, an operational dashboard is more detailed and is typically helpful for junior-level decision makers and their teams. These dashboard users are more concerned with shorter time frames, operational processes, and monitoring performance. So these dashboards display business metrics like sales activity, marketing performance, or customer support status. Then, an analytical dashboard is helpful for assimilating large amounts of data for historical analysis to identify trends, make comparisons, create predictions, and establish future goals. Most commonly, middle managers or data analysts working on e-commerce, sales, or website analytics will use this type of dashboard. Finally, a tactical dashboard is highly detailed and usually used to analyze social media ads or sales manager KPIs. Tactical dashboards might be used by any of these stakeholders to track initiatives and performance. Here are 2 things to keep in mind in regard to dashboard selection and user groups. First, each of these types of dashboards might use the same data sources. As a data analyst, you might use dashboards to present that information in different ways, based on your particular user's needs. Second, you'll likely encounter certain user groups that need to use more than one type of dashboard, depending on the questions those user groups ask. And this can change over time. While the various dashboards generally have different purposes and goals, they're also flexible. You can use visualizations in multiple dashboard types, and you can choose the dashboard style based on a variety of factors, like your user, their job role, and the business goal. Understanding the different dashboard types is essential to your work as a cloud data analyst. Just like picking transportation for quick rides to the store, or finding a big truck for moves across the country, the dashboard you design must be driven by the user needs and company objectives. Let's hope you get a lot of mileage out of your dashboard know-how. While playing sports or a board game, people keep score for a number of reasons. It provides a fun sense of competition that can be a motivating factor for players to play their best. It helps track player progress over time, and it lets the players know who won. Keeping score is also something that many businesses do, with scorecards. A scorecard is a statistical record used to measure achievement or progress toward a goal. It compares multiple points of data to help stakeholders make decisions that will help them meet objectives. Like dashboards, scorecards are also a type of visualization, but while the purpose of a dashboard is to monitor progress, the purpose of a scorecard is to track the progress of metrics. Scorecards enable users to easily spot actual results and compare them against goals. This helps them quickly decide if they need to take action. For example, consider a data analyst who is working with data for a call center. The center has a goal to increase revenue by 20% this year. A dashboard could highlight their annual sales to date, but it wouldn't offer any context showing whether they're on track, or know how to adjust if they aren't. So the data analyst creates a scorecard that displays the relationship between the call center's sales goal and the actual current sales data. This gives them a quick and easy way to determine if they're on track to meet the 20% growth target. And if not, they can adjust their performance. This call center might also like to know how many people are calling in for the first time versus how many have called in before, or how many incoming calls have been converted into customers. The data analyst can design another scorecard, which the business can use to compare the data results to department goals. This example demonstrates both the number of calls received and the relationship the data results have to the department's key performance indicators, or KPIs, for the last complete week. In this instance, the call center data reveals a decrease in its average number of calls, but an increase in the call duration. Comparing current numbers to desired performance also helps the call center management quickly notice any problems and react accordingly. As another example, if call hold times are longer than the target because the number of calls are increasing, then the call center management can hire additional staff to reduce the queue back down to the target range. Or, if the call center notices the number of issues is increasing more than the average, a supervisor can help answer calls for a bit to get things back on track. In these instances, the scorecards have given life to the data, transitioning it from interesting information to a specific call for action. While dashboards definitely have value on their own, incorporating scorecards in dashboards adds helpful context and valuable insights. Just like a championship sports match or a highly competitive board game, knowing the score helps motivate everyone to perform their best. Some of the most accomplished people throughout history are famous for asking effective questions. The Greek philosopher Socrates was known for his method of inquiry, the Socratic method. It involves asking questions to help people to think critically and draw out new ideas. Physicist Marie Curie, who conducted pioneering research on radioactivity, was always asking why and how, and she bravely asked questions that challenged conventional thinking. Some of these questions even led to the development of X-rays and breakthrough medical treatments. As a data professional, you can also accomplish great things by learning how to ask effective questions. To do this, ask SMART questions based on the SMART goal methodology. This is a method you can use to determine a question's effectiveness based on whether the question is specific, measurable, action-oriented, relevant, or time-bound. Make sure each question you ask utilizes at least one of these components to prompt your stakeholders to provide you with the level of detail you need to fully understand the request. Let's go through each of these now. First, questions should be specific. For example, instead of asking what kinds of employees will be using this system, you could ask, will this solution be used by entry-level teams, project teams, or middle managers? Even if the answer isn't one of those options, it will prompt your stakeholder to provide you with a more detailed answer. Next, ask questions that will provide measurable answers. So if your stakeholder tells you they want to increase sales, this alone is not measurable. Instead, it'll be necessary to ask questions that lead to more tangible results. Questions like, what are your current sales? And by how much do you want to increase that? The answers will create specific, quantifiable, and measurable objectives. Now for the A. If you're familiar with SMART goals, you'll see this is where SMART questions differ slightly. You'll want to make sure your questions are action-oriented. This means phrasing your questions in such a way that stakeholders can provide responses that you can act on. For example, the question, will you use market and industry benchmarks, can be answered with just yes or no. And that's not helpful for building a conversation. But asking an open-ended question like, which market and industry benchmarks will you use, prompts both a detailed response and an opportunity to grow the conversation. Of course, you'll always want to make sure your questions are relevant. There are certain questions that you'll ask during every project, including, what problem are you trying to solve? And which key performance indicators will you use to measure success? Other questions will vary based on the type of project you're working on. But either way, ensure they're relevant to the project and business objectives. Finally, you'll want to specify the time period to be analyzed. This limits the range of possibilities and ensures you focus on relevant data. So, ask if the data should come from the past quarter or the past 2 quarters, if you should analyze information from this calendar year or fiscal year. And there's another way to think about time-bound questions. This involves considering project time constraints. With this in mind, ask questions like, what is the time frame for this project? Or, what are the top 3 priorities that need to be accomplished during this time frame? All right, now one last thing to consider. After asking your SMART questions, it's a good idea to start setting realistic goals and expectations. If your stakeholders ask for a dashboard that includes every possible data point, this is probably unrealistic because you have a limited amount of time in dashboard space. But when you set realistic expectations, you're more likely to meet your goals and provide your stakeholders the data they need. Asking SMART questions can help you learn new things, solve problems, and be a more effective cloud data professional. One day, It may even lead you to some amazing life-changing discoveries. You're probably most familiar with the word translate when it comes to translating words from one language to another. As a data professional, this will be a critical component of your job to define stakeholder requirements before you can create tangible visualizations, such as reports and dashboards, to meet stakeholder needs. So, in this video, you're going to learn exactly how to do that. While the language analogy works well here, maybe a better way to think about this process is as a facilitator. You're going to take the needs and goals of your stakeholders and turn them into data that their teams can use to make informed business decisions. Okay, first of all, to translate a stakeholder request, you'll want to get to know and understand your stakeholders. In this role, you will work with many different people from lots of varied backgrounds and specialties. What are their areas of expertise and experience? Maybe you might like to identify their personality type or how they best like to communicate. It might also help you to identify their comfort level when discussing data-related concepts. Any effort you take to better understand the stakeholder will help improve your ability to communicate with them and deliver the solutions they need. You'll also ask detailed questions to identify their business requirements. For example, you might find yourself working with someone who likes to stay with what's familiar to them. They might even be very specific about the request, right down to the exact number of columns a report should have. It seems like they've given this request a great deal of thought and know just what they need, but you still want to use smart questions that are specific, measurable, action-oriented, relevant, or time-bound to get to the root of what they really need or are trying to accomplish. The response to each question is an opportunity for you to better understand their needs and provide them with a solution that is as concise and effective as possible. Asking why and other effective questions may also enable you to identify needs that your stakeholder hasn't considered yet. Keep asking questions to get the full scope of the project. It can be incredibly rewarding to apply translation skills, whether you're communicating in another language or collaborating with a stakeholder to determine their business needs. And this is just one more key to unlocking how you will be effective in your role as a data analyst. There are many great reasons why professionals create first drafts before they put their plan into action. An architect draws a sketch of a new building design prior to starting construction. A graphic designer provides mock-ups of new logos before creating the final logo. And a data professional presents a wireframe in advance of actually building a user interface. In all of these cases, a simple example called a prototype allows the creator to communicate their ideas and get feedback before investing a lot of time and resources into the project. As a data professional, your role in design goes beyond providing a report or dashboard to your users. You'll also use design during the planning stages of a project to communicate with stakeholders and ensure product functionality. As a cloud data analyst, you can create these prototypes, also known as wireframes. A wireframe is a visual representation of the structure and functionality of a user interface or product layout. For dashboards, this means creating the basic layout and design of the dashboard. You can use wireframes during project planning phases to ensure that the user interface or product you're designing is complete and satisfies the stakeholder request. Wireframing in the early stages of the development process is critical for two main reasons: to align with stakeholder needs and simplify the feedback process. First, visual examples tend to be easier to understand than verbal or written communications. So, when you mock up your vision into a wireframe to share with stakeholders, this helps everyone understand if they're in alignment. In this way, you're much more likely to develop a finished product that reflects your stakeholders' needs. The second benefit of using a wireframe while planning a deliverable is that it speeds up and simplifies the feedback process. Providing stakeholders with easy-to-review materials helps them to quickly and easily review your plan. As a cloud data analyst, there are a variety of wireframe programs that you may use in your work. These programs will help you create products or user interfaces like websites and dashboards. Additionally, these programs offer a variety of features to aid in your draft design, and they highlight how your charts will interact to tell the data story. This helps you have a complete and actionable data story. Wireframes are also very effective at helping you improve the accessibility of your design. For example, you can arrange design elements like navigation, images, and text to help ensure users can easily gain insights based on their abilities. Now, you might find yourself working in a situation where you don't have access to a wireframe program. In that case, there are a variety of other apps you can use to create a visual draft of your plan, like Google Slides or Google Docs. While these programs won't have the full functionality of some wireframe programs, you'll still be able to visually document the general layout and plan for your stakeholders. Here's the bottom line. No matter which wireframe program you choose to design your prototypes, your wireframes will help you align with stakeholder needs and simplify the feedback process. By sharing your wireframes with stakeholders during the planning process, you'll receive valuable feedback to help you save time and effort while identifying potential challenges, design opportunities, and ways to improve the accessibility of your design.
One thing that gets me super excited about this industry is that I really love solving new problems and thinking and stretching my brain around them. And because the customers I work with are so varied, I get to stretch myself by thinking about problems and industries and solutions that I wouldn't have ever gotten exposure to without it. My name's Latifa. I'm a customer engineer here at Google Cloud with a data analytics specialty. And essentially what I do is help companies build apps and move them to the cloud. So when I was in high school, I took my first statistics course, and I was never fantastic about math. I was pretty good. I won't sell myself short, but when I got to university, I added that as a degree major. During that process, I also was a waitress part-time in college, and I realized I liked interacting with people. And I also tutored, and I was like, I like teaching people about things, especially when they didn't get it before. And so customer engineering is kind of the melding of all of that. I'm teaching customers about cloud that they didn't know before. I'm teaching them about their own products that they might not have known or sat down to discover, but I'm also being able to implement my statistics knowledge, my data analytics knowledge with people and not just behind a screen all day. To build my skills, the first thing I did was I took an online course, and then I also got a professional data engineering certificate for Google Cloud, which is where I work now, as well as really just getting my hands dirty. There's no other way to replace experience. Sometimes that's finding new projects, sometimes that's volunteering for like a local community organization that needs data analytics help. Just anything where you can put yourself in a situation you haven't been in before. By being able to show real time that I could do the work and I had experience that translated, I was able to make my way in. Soft skills that are important for my current job are communication, and by communication, I mean the ability to listen, to understand, as well as communicate complex concepts back to somebody, as well as project management skills. So think about creating a timeline, helping people stick to that timeline, and being able to react quickly if anything comes up. If there was something I could say to anybody starting out for the first time, it's okay if you don't understand things. It's okay if it's confusing. But now, 3 years later, I realized most of the problem was my inability to stop and really think about it and chew on it because I was always like raring to go. And I think you guys will probably all experience this at some point. You just want to be done so fast, get into your next career so fast. Take the opportunity to understand what's going on and then also recognize that it's okay to try something and then try something else. You'll get there eventually.
Congratulations on finishing another section of this program. You now know tons of useful information about visualization planning and design. You started off by exploring the impact data types have on your design decisions, and you learned how data types influence the types of visualizations data professionals can create. Then you considered the various types of business intelligence dashboards and how keeping your user needs in mind can help you select the right type of dashboard visualization for each particular project. After that, you gained some key insights into working with stakeholders. You discovered how to ask questions that get to the heart of what's really important by uncovering stakeholder needs. You also identified different ways to use design to translate stakeholder requests into a solid design plan. Finally, you learned how to use wireframes to align with stakeholder needs, simplify the feedback process, and improve the accessibility of your designs. Wonderful job on your progress so far. I can't wait for you to keep up the momentum in the next section of the course. Hey there, Future Data Pro. Welcome to this section of the program, all about accessing, exploring, and reporting on data in the cloud. we'll be focusing on the last two stages of the data journey, analyze and activate. You're going to explore some really amazing data visualization tools and discover how to select the right tool for each phase of the data analytics workflow. You'll also learn how to access, explore, and analyze cloud data that's stored in data lakes, data warehouses, and other sources. Along the way, you'll explore data sets using data visualization tools. Then, you'll learn about data types, dimensions, and measures to better understand the data model. You'll also use data modeling to customize how data appears. Next, you'll model data for visualizations, which includes modifying, blending, and aggregating the data. You'll also learn how to manipulate and organize data in a way that best yields insights. Finally, you'll understand report analysis for visualizing and sharing information with stakeholders. You'll also get direct experience with Looker Studio, where you'll connect to a data source, explore a data set, transform fetch data, and create a report. Now that you have a roadmap for what's coming up, let's get started. As you likely know, the data journey consists of 5 stages: collect, process, store, analyze, and activate. This video is about the last 2 stages of the data journey, analyze and activate. During the analyze stage, you identify trends and patterns in your data to uncover insights that your users need. Cloud-based data visualization tools provide a variety of features that make it easy to explore and analyze data, such as filtering data, drilling down to uncover more granular insights, and creating custom visualizations. These features help you spot trends and patterns in data and develop deeper insights. During the activate stage, you present your visualizations to your stakeholders and use the insights from the data to make decisions and take action. Visualizations created with cloud-based data visualization tools can easily be shared with others to inform decision-making. These visualizations can be used to communicate insights from data in a clear and concise way, helping teams make the most of their data. Let's look at an example of analyze and activate at work. As a data analyst, you can use cloud visualization tools to analyze data about national sneaker sales trends from a publicly available dataset and sales data from the company's own local sales dataset. This allows you to create a single graph that compares the 2 datasets. This visualization can then be used to activate the data by providing the team with a visual representation of how the different regional sales compare against national averages. The sales team can then use the findings to help them develop more effective sales strategies. There are many benefits to using cloud-based data visualization tools, such as flexibility, time savings, and user-friendliness. Cloud-based data visualization tools can be used to analyze and activate data from a variety of sources, including local databases, spreadsheets, public datasets, and cloud-based databases. This enables data professionals to combine multiple data sources with huge amounts of data into a single visualization. Cloud-based data visualization tools can also save hours of manual processing and analysis. These tools empower your users to interact with and explore the data in a user-friendly way. This encourages them to ask more questions, leading them to make data-driven decisions. There's so many benefits to using cloud-based data visualization tools to harness data and share compelling data stories. When you use these tools to discover, access, and visualize data, you'll be creating awesome new opportunities for yourself and your teams. One of the exciting things about the cloud data profession is the fact that there's so much data available to use. Having more access to data means you can find answers to questions that you may not have been able to before. In this video, we're going to review some of the different types of data sources and various considerations for connecting to cloud data. As a cloud data analyst, there are 4 common types of data sources that you will likely use in your work. First, data professionals can collect public data from businesses, government, and private organizations. As the name suggests, this data is publicly available. This has the potential to advance education, social causes, economic growth, innovation, business and government accountability, and so much more. Second, the cloud also has all kinds of product-specific data across industries like retail, nonprofit, and finance that can be accessed by data management systems. Third, software platforms are a great source of data. These contain user relationship management, social media, advertising, human resources, and financial system information. Fourth, the cloud also has company-specific sources, like Salesforce, proprietary databases, and spreadsheets. These systems typically have their own unique formats, so it's important to be aware of those implications for visualization and analysis. As a cloud data analyst, there are many different ways to connect to the different data sources we just covered. There are also a lot of helpful solutions to help you find what you need, including Looker and Looker Studio, to use internet-accessible data in the cloud. Now, no matter where the data comes from, you will need to pay attention to the data freshness. Data freshness refers to how current or up-to-date the data within a report or dashboard is. For example, if the data in a dashboard is updated once every 24 hours at midnight, and a user accesses the dashboard at 5 p.m., then that information is outdated by 17 hours, and it won't reflect any of the current day's data. The importance of data freshness will vary by visualization and business need. In some cases, users access the data infrequently, and so data freshness is not a priority. For example, when company executives review annual numbers in a high-level strategic dashboard, the data typically does not need to be updated regularly. But a sales team's dashboard with up-to-date sales trends likely does need to be refreshed in near real time. Another aspect of working with cloud data tools that you'll need to consider is data security. This means being aware of user permissioning groups and what they can do. These groups are usually broken down into 4 types: admin, developer, user, and viewer groups, but may vary by product. Let's understand each of these. Administrators, sometimes called admins, are the highest level within any system. These users will have the ability to do things like manage the workspace, assign roles, and update the database. This is a very important role. Next, developers work with data modeling languages to create data models and manage dashboards. Then, users generally explore the data and perform functions like creating visualizations, custom fields, and table calculations. Lastly, the most limited role is the viewers. They can access and interact with visualizations that have already been created, but not edit them. To fully understand the various groups and roles, review each specific tool's documentation. Also, keep in mind that every user with more access can do everything those with less access can do. As an example, consider developers who can also perform functions as users do, and they can interact with visualizations just like viewers. Now, one last thing. When setting user permissions, be aware of not only what users can access, but also when and how. So, make sure you're prepared to protect company data that users have access to. This entails protecting data from malicious actors, or people who try to access the data without authorization, whether users are on a mobile device in a public place or using a work laptop at home. As a cloud data professional, there's a lot to consider when accessing open data from a range of data sources in the cloud. The information that's available anytime, from anywhere, is truly staggering. But it's your job to make sure it's used responsibly and safely. By thoughtfully handling these critical details, you'll be able to create dashboards with data from publicly available and/or company-specific sources to help your stakeholders make insightful decisions. When we come across something that's unfamiliar, like a place we've never visited, we may first try to identify details and characteristics to help us better understand the world around us. This can be a landmark, like a building or body of water, or even a street sign. This type of exploration is important when learning about new things and using them for decision-making and problem-solving. It's also an essential element of data analytics, and that's what we're going to explore in this video. Exploration is what this video is all about. Data exploration, that is. As a cloud data analyst, data exploration is the process of understanding a data set by inspecting its characteristics, identifying patterns, and asking questions. This includes qualities like size, quantity, distribution, and accuracy. Knowing about these attributes can help you comprehend the essential nature of their data. Let's get into why data exploration is so important. First, it's essential for you to have an understanding of the dataset's structure. This will give you a better foundation for the size, quantity, and type of data you'll be working with. Think of this like a filing cabinet. You rely on the labels of the folders to understand what types of files you're working with and where they're located. Data exploration is mostly about defining what a column includes, so it's important that you correctly label these columns. Using the filing cabinet example, if one folder is named Finances 1 and another is named Finances 2, it's not clear what information is inside. If the folders have similar names, this can lead to issues when you're trying to find a specific piece of information. And even with effective labels, it's still necessary to open the folders to know what they contain. Data exploration is like opening the folders in a filing cabinet to understand what data you have to work with. Data exploration is also an opportunity to experiment with ways to visualize data. It helps you refine your plans for how to create visualizations that are easy to understand. You'll likely tailor your questions and hypotheses as part of your data exploration. Finally, data exploration enables you to confirm the data quality and the distribution of data values. This benefits you and your data team because you can identify outliers and data errors. And you can decide to address these issues before you design your visualizations. Now, there are a variety of tools available for exploring data. You can explore the data using code with Python, SQL, and R. Or, if the data set is small enough, you can use spreadsheet programs like Google Sheets or Excel. You can also explore the data visually with a tool like Looker. Tools like these are great because they help you visually explore the database and data relationships, making it easier to quickly identify potential issues before they become problems. Understanding how to characterize data will help make you a highly effective data professional, especially when it's time to learn about new data sets. Great work, and thanks so much for joining me on this exploration of exploration.
Hi, my name is Nicholas. I'm a business analyst at Google. Some people call me Klaus. It's kind of an interesting nickname that I picked up, mostly because my name has a U in it, so it's Nick Klaus. I'm responsible for reporting business metrics to leads, very specifically operations within Google. So anything that has to do with inventory, anything that has to do with IT interactions, anything that has to do with platform health, et cetera, et cetera. I also do a lot of machine learning type work. So I do a lot of advanced analytics and trying to figure out how we can apply machine learning and AI to find good opportunities within the business to optimize. I grew up in Santa Cruz, California. I struggled in school, did not like school whatsoever. School was not for me. I had a troubling home life. The result of that was me dropping out of school very early. Roughly around 15, 16 years old, started washing dishes. I was part of a program that a chef was doing at a hospital, local hospital. Great guy, Chef Sean. And he was working with juvenile kids who were at-risk youth, in and out of the juvenile system, et cetera. And he was teaching them how to do culinary arts work. I found myself at 21, 22 years old feeling a little bit like, I didn't have a choice in the career path that I had chosen. And I wanted to try something different. I didn't know exactly what it was going to be. Maybe I'll try to go back to school just to see what happens. And at the time I wanted to be a writer. And I said, maybe I'll be a writer. I'll tell my story. And then I changed my mind. That's the wonderful thing about school is you can change your mind and you can really just, try on different things. So maybe I'll be a nurse because I really wanted to help people. I took a class called Mathematics for Healthcare Professionals. And the professor in the class said, hey, you seem to have a real aptitude for this. I was able to get a full scholarship to go to New York University where I double majored in math and computer science. Especially at these types of schools like NYU, these private universities, it was very atypical for someone to be an undergraduate and be my age. I remember a couple of times I was mistaken for either a professor or DoorDash delivery person, especially with all the tattoos. I stuck out like a sore thumb in there. I arrived at Google in 2016. I moved from New York City to Mountain View at the time. And I was arriving with a very different tool set and a very, very different set of life experiences that the rest of my colleagues had. And that really allowed me to really shine. I think a lot of people that I've met here within the company actually have a lot of interesting stories. And it's actually those interesting stories that makes them qualified to be Googlers. My org is related to the cloud kind of somewhat indirectly, but we do use our data warehouse is primarily built with cloud tools. So I use cloud tools kind of constantly, as they apply to business internals within Google. Depending on what you're into, depending on what you like. If you like to work with massive data sets, there's a place for you in cloud. If you like to work on use cases and be interfacing with customers and understanding how you can apply cloud tools within a business, embedded in a business, there's a place for you. If you like to work in an advanced analytics space and want to deploy huge scalable machine learning algorithms, there's a place for you. The cloud ecosystem and the cloud universe is really large. And I think if you find a place, if you find something that's interesting to you, that gives you that spark, you can have a really great career. I think that anybody who's going through the process is obviously thinking about, okay, what is the next step for me, right? If I'm going to do this, if I'm going to sacrifice my time to do this certificate, how is this going to affect my future? And I guess what I would say is that the certificate itself is going to not only give you some sort of artifact that's going to unlock a lot of doors for you when someone from Google or someone from a business is looking at trying to assess your skills, but it's also going to open a door for you. It's also going to start to expose you to subject matter that you might not be familiar with before. And that exposure itself is worth something. That exposure to new concepts and new ideas, because it's very associative. I didn't start with a computer science degree, right? I started with something totally different, and through being open and through exposure to new ideas, I found my way to what I do now, which is data science work and business analytics work. It was only through giving myself that freedom to be exposed to new things that allowed me to find my way to something that I'm truly passionate about today.
Hello, data enthusiast. I can't wait to take you through this video all about the value of data models and attributes, like dimensions and measures. Let's start with data models. A data model is a concept for organizing data elements and how they relate to one another. It can be visually represented to show how the data is structured and how it relates to each other. Every data source has a data model, even if it's not explicitly defined. For example, consider a simple table of data. This table has a data model that defines the columns and rows of the table. A more complex data source, like a snowflake schema, has a more complex data model that defines the relationships between different tables. As a data analyst, you create data models to structure and organize the dataset and determine how to define data attributes. Dimensions and measures provide a flexible way to explore a dataset's attributes and ask meaningful questions of the data. And they're an important part of how cloud data analysts work with visualization tools. But what exactly are data attributes? Well, that brings us to dimensions. Dimensions are unique attributes of the data that help you to describe data. Here's a simple data model made up of rows and columns that contain information about books. The table has dimensions like title, genre, price, date published, and whether the book is in stock. Each row in the table represents a single book and contains the values for the dimensions that describe that book. These values are lined up so that the dimensions form columns. For example, the title of the book is stored in the title column. The genre of the book is stored in the genre column, and so on. Since dimensions group values together, you can use them to ask questions of the data to gain insights. For example, the bookstore owner could ask about which genres their store has in inventory by using the genre dimension to find that value in each row of data. Dimensions can even be combined to ask more complex questions, like what genres are available and which of the books within each genre are currently in stock. The bookstore owner would do this by using both the genre and in-stock dimensions. But what if you want to know how many books are in the entire bookstore? For that, you need a measure. Measures are aggregations of one or more dimensions, like count or average. Returning to the bookstore dataset example, each row in the data model contains the individual characteristics of a single book. If you want to know how many books are in the entire bookstore, you need to use a measure to perform a mathematical operation, count. Since every row equals one book, you'll need to count the rows to find out the total number of books in your inventory. One way to do this is by counting the values in a single column or dimension, like the unique identifier column, to find the total number of rows. Measures can also aggregate dimensions in other ways, like finding the sum or average value of all the books. Dimensions and measures are two of the most important concepts in data analytics, especially when visualizing data. They provide valuable information and are essential for understanding data relationships. Keep investigating the use of dimensions and measures in your data models to maximize the power of any dataset you encounter. Welcome back. As a data analyst, you'll often find that you need to prepare your data before it's ready for reports and dashboards. As you prepare your data, you need to perform a process called data modeling. There are a couple of reasons why you might need to model data. For example, if you're working with multiple data sources, you'll have to do some preparation to bring them together effectively. Another reason to model data is to understand the data better. Data modeling is the process of designing, structuring, joining, and transforming data to prepare it for reporting. Really, it's a form of manipulating data so that it's much easier to work with and understand. For example, through data modeling, you can define a join between two datasets and format a column so values are uniform. Or you could define metrics or key performance indicators, also known as KPIs. There are several ways to model data. One option is filtering. By filtering data, results are limited to focus on a specific subset of the data. Filtering can either include data that matches specific criteria or exclude data that doesn't. For example, in this movie database, you could filter by genre to only show comedies. This is an example of include. Or you could filter to show everything except horror, which is an example of exclude. All right, now another example of modeling is blending data. Data blending is the process of combining data from multiple data sources to create a single report visualization. This greatly enriches your dataset and gives you more flexibility. While this is a great feature, it's important to note that blends aren't reusable across reports because they use multiple sources. Okay, another useful data modeling process involves aggregations, like sum and average, to group and summarize data. Other aggregation examples include count, minimum, and maximum. Each of these functions changes how the data is displayed within a visualization and can be modified as needed. There's one final consideration to keep in mind. When modeling, it's common to encounter a situation in which the data doesn't appear as you intend it to. When this happens, you'll need to make some adjustments. For example, if the original column title isn't clear, then you need to modify it to be more descriptive. You can do this in a single instance by updating the label for that specific visualization. Or, if the change should be universal, then change the label in the data source itself so it's clear for all instances of potential use cases. This is also true of more advanced situations, like calculations. You can modify a column within the model to a sum or average just for a specific visualization, or change the calculation in the data source to make the change reusable for future models. Modeling data is an excellent way to get closer to the key details of any dataset. Keep learning and exploring data modeling, and soon you'll know how to effectively inform your data visualization decisions and prepare to share even greater insights. Hi there. Welcome to this video that's all about blending data. You're going to learn about the exciting ways that data from different sources can be put together for helpful data insights. When you join, merge, aggregate, and connect other important data relationships from separate data tables, the final, fully integrated dataset becomes that much more powerful. Data blending is the process of combining data from multiple data sources to create a single visualization. This means that you can pull data from different locations and combine them into a single table. By putting disparate data together in a single place, you'll be able to create visualizations for your reports that provide additional guidance to users' analysis and decision-making. For example, a company could use data from its local database, a public cloud data source, and a software application, then combine them into a single effective visualization. When data is easily available, users have more information and context, and so user insights will be broader, deeper, more diverse, and more informed. Okay, now let's go through some important data blending steps and considerations. First, while blending data may seem similar to creating a dataset, there are some key differences. Most importantly, blends are embedded into the report from which they were created. This means that they're only available to use in that specific report. One way to get around this is to copy the report. Then, the blend will be copied along with it. Second, it's also important to call out that a blend's data freshness relies completely on its underlying data sources. In other words, the data will only be as current as its source. Now, there are a variety of business intelligence tools for quick and easy data blending. But in general, the process will go something like this. First, connect the data sources. Most programs will have the ability to combine more than 2 data sources. Next, define joins. You join data to combine the data into a single dataset. Keep in mind that each dataset must have at least one column in common. This is how the business intelligence, or BI platform, understands those essential data relationships. Finally, clean data by deleting any unnecessary data. Correct data entry errors and design the optimal format. This sets up any analysis project for some very effective graphs, charts, tables, and single value visualizations. Blending is a powerful tool for users to gain greater insights into the data. Blending enables you to create a more comprehensive view of the data, identify patterns and trends, and make insights accessible to users. It's a valuable solution for data analysts, and it provides all sorts of useful data applications. As a data analyst, you'll often use both reports and dashboards when you need to develop data visualizations. They're the most common visualizations you will create. In this section, you'll learn more about data reports, how they're used, their benefits, and some basic differences between reports and dashboards. You've likely already spent a bit of time learning about dashboards. But what about reports? Reports is one of those terms that you might think you already understand, but how it's used in data analysis might be a bit different than what you expect. Unlike text-based reports similar to a news article or science publication, a data report is a visualization of detailed business intelligence data for making business decisions. Data reports visually present data insights with a focus to take action on business needs or objectives. Data reports inform and educate, whether it's a research report presenting the findings of a study, a progress report with project status updates, or a financial report highlighting business performance. Let's consider the similarities between reports and another visualization type you may be familiar with, dashboards. First, both reports and dashboards are ways to visualize and activate data. They can be built with the same tools and may even look similar. Both can use multiple sources to present data insights. And they make data more accessible to users who will use them to make decisions with the data, collaborate with colleagues, and share critical insights. Yet, there are important differences between reports and dashboards. Let's consider these differences and clarify how each is used. The first thing to understand about reports as a data analyst is that they're usually a curated static representation, meaning, unlike dashboards, the data doesn't change once you generate the report. Think of reports as a snapshot of a specific point in time. In other words, there's an expiration date to a report's effectiveness. This is different from dashboards that may be updated in near real time. One example of how you can use data reports is for project-specific reporting. Take a large hotel construction project, for example. You could create a report of the construction cost to date, and that information would only be pertinent for that particular point in time. Another key difference is that data reports have more detail than dashboards. Reports typically have more content and more explanation about that content, so they're much longer. So while dashboards can fit within the confines of a single screen view, reports might require scrolling through many pages. This combination of length and detail also means it can take users longer to review reports and fully understand what the report includes. This is also a big contrast from dashboards, which are meant to be understood more at a glance and without additional context. Both data reports and dashboards have their place within data analytics. Reports are a great tool for users to collaborate and answer specific business questions, especially for one-time questions that require more detail. Dashboards are best for repeated, ongoing, up-to-date data insights. As always, prioritizing your users' needs will be essential as you determine which type of visualization will work best for each situation. Check out your new Cloud Data Professional skills. You've put in great efforts with this section of the program about accessing, exploring, and reporting on data in the cloud. Recently, you spent time identifying the ways in which data visualization tools vary and how to select the best tool for each phase of the data analytics workflow. You also learned how to make the most of cloud data stored in data lakehouses, data warehouses, and other sources. You explored data sets using data visualization tools, and you identified data types, dimensions, and measures in the context of data modeling. Next, you modeled data for visualizations to modify, blend, and aggregate data using data visualization tools. You also considered how to manipulate and organize data in a way that best visualizes insights. Finally, you transitioned into reports to better share data and key insights. You checked out Looker Studio, connected to a data source, explored the dataset, transformed data, and created a report to visualize data insights. Awesome job on your progress. Keep it up. Greetings, Data Superstar. I'm happy to welcome you to this section of the program all about using enterprise-grade visualization tools used by large, data-driven organizations. You're about to explore the needs of enterprise users and some cool tools for helping them visualize insights from large datasets. Along the way, you'll gain practical experience building a dashboard to meet a business need. Next, you'll use visualization tools to explore large datasets. Then, you'll learn how to work with a real dataset to build a dashboard that meets a specific business need. Finally, you'll discover ways the cloud data analyst role is evolving thanks to cloud technologies. All right, it's time to enter the world of business analytics. Enterprise-grade visualization tools can help businesses of all sizes make sense of large amounts of data. In this video, we'll consider what these tools are and how they can be used. But first, let's get a quick definition. An enterprise-grade data visualization tool is a type of data visualization software used by large data-driven organizations to explore, analyze, and share business analytics. These tools are designed to handle large amounts of data securely, and they make it easy for users of all levels to work with data. Some common features of enterprise-grade visualization tools include performance optimization, metadata management, data cataloging, organization-wide metric definitions, self-service analytics, and data governance. Let's dig a little deeper to explore each one. When it comes to data visualization tools, performance optimization matters. Organizations working with high volumes of data need to quickly access information and view reports in near real time. Enterprise-grade visualization tools are capable of meeting this performance standard with advanced features that allow users to efficiently access and interpret large amounts of data. Next up, metadata management. Metadata is data about data. It describes data resources and helps users discover, interact with, and learn about the data they're working with. Examples of metadata include the name of the dataset, description of a data asset, the user permissions to access the data, and the history of changes made to a data asset. Metadata management is the process of managing, accessing, and organizing metadata. This is essential for businesses that need to find data quickly and collaborate effectively. By managing metadata, organizations can create a standardized way to describe data, which can help teams across the organization collaborate and streamline communication. Next, a data catalog is a centralized inventory of an organization's data assets. Data catalogs collect metadata about these assets, which includes information like the data's meaning, where it came from, its quality, and where it's stored. Data analysts can also use data catalogs to track and manage data assets. Data catalogs list who has access to data, how often it's being used, and if it's being used in accordance with the organization's data policies. Organization-wide metrics are another way enterprise-grade visualization solutions help to make it easier for teams to collaborate and work efficiently. Organization-wide metrics are metrics that are defined and shared across teams. They're typically used to define key performance indicators, or KPIs, like revenue and user satisfaction. Once an organization-wide metric is defined, an entire organization has access to the same metric, helping to ensure everyone in the organization is speaking the same data language and using the same indicators to gauge impact. Let's cover the self-service analytics features that help make it possible to empower users to work and collaborate with data more effectively, as well as make it possible for an organization to empower teams to make the most of their data. Self-service analytics is an approach to business intelligence that allows both technical and non-technical users across an organization to access data, perform ad hoc data analysis, and generate reports. In traditional guided analytics, users rely on data analysts to produce reports. But with self-service analytics, team members from across an organization can directly interact with data and even create their own reports. Finally, as more users interact directly with data, data governance becomes increasingly important for keeping sensitive data safe and ensuring that each person has access to only the data they need. Data governance is a process for ensuring the formal management of a company's data assets. An important feature of enterprise-grade data visualization tools, managing data is key to ensuring the safe and efficient use of data across an organization, especially when users across the organization are working with and communicating about data. So, to recap, enterprise-grade data visualization tools offer a variety of features that make it easy for organizations to make sense of large amounts of data securely. So as you move forward as a cloud data analyst, you're now in a position to know when it's appropriate for the business to recommend enterprise-grade visualization tools. Hi. In this video, you'll learn about 2 ways to empower users to make better decisions with data: self-service and guided analytics. Organizations of all sizes are increasingly relying on data-driven decision-making, but this has created a new challenge for data teams. More and more people need access to the data, and they want insights fast. To meet this demand, many organizations have turned to self-service analytics. But what is self-service analytics? Self-service analytics is an approach to business intelligence that allows both technical and non-technical users across an organization to access data, perform ad hoc data analysis, and generate reports. Self-service analytics is often contrasted to a more traditional approach, guided analytics. Guided analytics is an approach to business intelligence where solutions, like reports and dashboards, are created by an analyst or developer to meet a specific business need. Both guided and self-service analytics play an important role in helping organizations deliver meaningful insights to users across teams. The right approach will depend on your specific data needs. Let's check out both. Consider this scenario. You're hiring a tour guide to take you around Paris. Your tour guide plans out an itinerary for you, including the most famous sites, like the Eiffel Tower and the Louvre Museum. Because you have an itinerary, you don't need to worry about details. You can just enjoy the experience. Guided analytics works in a similar way. It provides you with a predefined set of tools and visualizations that help you explore your data and identify insights. With guided analytics, the user identifies a business need that they want addressed with data. The data team then determines the best approach to address the business need and develops a solution. The data team then delivers the solution to the business, ready to help guide their decision-making. Guided analytics is a useful approach because with the help of an expert guide, the data team, users can easily access specific, actionable insights. Since the data team is responsible for the data, issues of data governance and privacy are more easily addressed. But organizations that only use guided analytics often run into 2 problems. First, handling every request can strain the resources of the data team. They may not have the time or capacity to create solutions for everyone who needs them. Second, waiting for a solution can take too much time, delaying the user's access to the insights they need for data-driven decisions. Self-service analytics addresses these concerns by allowing business users to interact with and analyze data directly. Instead of hiring a guide, imagine you decide to explore Paris on your own. You have a map of the city and a list of the sites you want to visit. Then you're free to explore at your own pace and in your own way. Self-service analytics is like a self-guided tour of your data. With self-service analytics, users have direct access to datasets. They can perform ad hoc analytical tasks like creating visualizations and running reports. They can explore different ways to utilize the data. This gives users across teams more control over their data analytics and allows them to make data-driven decisions faster. But self-service analytics also has its challenges. One challenge with self-service analytics is that users may only be working with the data in the context of their jobs and responsibilities. This means that they may not be aware of how the data applies to other users, or how it can be used to answer broader questions. Another challenge with self-service analytics is that the self-service solution needs to be user-friendly. If the solution is too difficult to use, users will be less likely to adopt it. That's why it's so important for data teams to work alongside self-service users. They can help users understand the data, identify the right questions to ask, and use the self-service solution effectively. In the end, both self-service and guided analytics can add value and promote data-driven decision-making across the organization. As a cloud data analyst, the approach you choose will depend on the data and needs of your organization and its users. Putting together a huge puzzle can be challenging. You start with a bunch of pieces, and it's not immediately clear how they all fit together. So you examine each piece, looking for patterns to see how they fit together. But the more you examine the characteristics of each piece, the way to solve the puzzle becomes clear. Data exploration is a lot like putting together a data puzzle. Data exploration is the process of understanding a dataset by inspecting its characteristics, identifying patterns, and asking questions. And when you explore data with a visualization tool, you'll understand how you can start to answer questions about the data. Let's check out how this works with an example. This is Arjun. He's a data analyst at a large clothing company. Because the company's database is huge, Arjun needs to better understand the data structure in order to effectively analyze the data. To do this, Arjun decides to use a data exploration technique called sampling. Sampling is the technique of selecting a segment of a dataset that is representative of the entire dataset in order to better understand its characteristics. Using sampling, Arjun can use a more manageable amount of data to review and start honing in on the specific questions and answers using the dataset. Next, Arjun decides to visually explore the sample of data by graphing the data in a histogram and scatter plot. With this technique, Arjun can spot patterns in the data that may be useful to further analyze the larger dataset. Arjun can also use data visualizations to find outliers and anomalies that may affect data quality and deal with them prior to performing data analyses. Finally, Arjun decides to go one step further by digging into the details of the data using a technique called data drilling. This allows Arjun to explore the attributes that make up the dataset at a more granular level, which helps Arjun further fine-tune any questions to answer using specific queries. By exploring the data, Arjun is able to put the pieces of a data puzzle together to understand the big picture of the dataset and get more from the data. One important takeaway: as a data analyst, you will not always follow a linear path like Arjun to get the results. Data exploration is actually an iterative process that can vary depending on the data and may even require you to go back and forth between different steps as you learn more about your data. But no matter your approach, data exploration is a critical first step in the data visualization process that will help you understand the data better, save you time and resources, and make sure your analysis is accurate, insightful, and meets your data goals. Hi, and welcome to this video on filtering with dimensions and measures. Filtering is the process of limiting the data returned from a query based on specific criteria. It's a powerful tool that can be used to narrow your focus on a specific part of your data. When working with data visualization tools, filtering is usually done on dimensions and measures. Let's explore how filtering works with each one. Dimensions are unique attributes that help you to describe your data. Filtering with dimensions is a great way to narrow down your results and get the insights you need because it lets you limit your results to only the data that has the specific attributes you're interested in. Let's dig a bit deeper with an example. In this simple 10-row dataset, each row represents a single book. The book attributes include title, author, and price. These attributes are the columns of the dataset. They can also be used to filter the data. To filter on a dimension, you first need to identify the dimension and then set the criteria that must be met. For example, if you want to filter on the author dimension, you could set the criteria to return only the author values that match Chad A. All rows that do not meet this criteria will be filtered out. In this sample dataset, this will return 2 rows since Chad A is the author of Cash Me If You Can and Data Mapping for the Slightly Curious. It's also possible to filter on multiple dimensions, like author and title, using a logical operator. For example, let's say you want to answer the question, which rows have both the author name Chad A and the title Cash Me If You Can? To answer this question, you would first need to identify the author and title dimensions. Then, you would use the AND logical operator to set the criteria so that only the rows where the author value matches Chad A and the title value matches Cash Me If You Can would be returned. In the sample dataset, this will return only 1 row because only a single book meets the criteria. Another useful logical operator to use with dimensions is OR. The OR logical operator is valuable if you want to ask questions like, which books have an author of Chad A or have the title of To Join or Not to Join? In this case, the dimensions used are author and title, and the criteria is set to match author values that match Chad A or titles that match To Join or Not to Join. In the sample dataset, this will return 3 rows. In this case, the dimensions used are author and title, and the criteria is set to match author values that match Chad A or titles that match To Join or Not to Join. In the sample dataset, this will return 3 rows, since Chad A is the author of 2 books and To Join or Not to Join is the title of 1 book. When you filter on a dimension, the filtering happens first on the raw data before any calculation. This means that the filter will only be applied to the rows that match the criteria, and the calculations will be performed on the filtered data. But the opposite happens when you filter using a measure. Measures are aggregations of 1 or more dimensions, like count or average. Measures can be filtered to answer questions like, which authors have an average book price of more than $10? In this case, the filtering happens after the calculation. This means that the filter will be applied to the calculated results. Let's return to the book example. To return the authors that have an average book price of $10 or more, first, the rows are grouped by author. Then the average is found for each group. Next, these results are filtered based on the criteria, authors with an average book price of $10 or more. This returns 2 authors, Amy T., who has an average price of $12, and Beatrix P., who has an average price of $20. Even though the average was found for the other authors, that data is filtered out because it doesn't meet the criteria. As a cloud data analyst, filtering data using dimensions and measures is a powerful skill that can help you uncover insights in your data. Filtering allows you to focus on the data that's most relevant to you, which can help you answer specific questions and make better business decisions. When you take a picture with a camera, you can zoom in on things to focus on details up close, or you can zoom out to get a wider perspective. To do this with data, you can use data drilling. Data drilling is a process that allows users to explore data in more detail by revealing additional levels of information. There are 3 main ways of data drilling: drill down, drill up, and drill through. But before we dive into how each one works, it's important to understand dimensional hierarchies. A dimensional hierarchy is a way to define the levels of detail in a dataset that a chart can display. For example, a dimensional hierarchy for time might have the following levels: year, month, week, day, hour. Each level in the hierarchy represents a more granular representation of the data. For example, the year level represents the most general level of detail, while the hour level represents the most granular level of detail. The order of the levels in the hierarchy is important because it defines how users navigate when they drill into the data. For example, click on the specific year level to drill down to the month values for that year. By understanding dimensional hierarchies, you can create charts that allow users to drill up and down to explore the data in more detail. Drilling down is a technique that reveals additional levels of detail within a chart by moving down the hierarchy from more general to more granular data. Let's use an example to explore how drilling down works. Sam, a data analyst at a local community kitchen, looks at a chart that shows the total pounds of food donated by community members each year. To get a more detailed view of the data, Sam uses drill down to view the pounds of food donated by month. The chart now shows the pounds of food donated by month, and each month is represented by a bar. Sam notices that the most food was donated in December, followed by November and October. They also noticed that there was a dip in donations in the summer months. By drilling down into the data, Sam is able to get a more detailed view of the pounds of food donated than was evident when looking at the data group by year. This information can help Sam to understand how the donations vary over time and to identify trends and patterns. The opposite of drilling down is drilling up. Drilling up is a technique that reveals fewer levels of detail within a chart by moving up the hierarchy from more granular to more general data. So, back to Sam. Sam reviews a chart that shows the number of people who visit the community kitchen each week. They want to learn how the data changes over a longer period of time, so they drill up to see the data for the entire month. The chart that Sam is viewing shows the number of people who visit each week, so when they drill up, Sam's moving to the month level. This gives Sam a more holistic view of the data. Drilling up and drilling down are great ways to explore the different levels of detail in a single chart. But if you want to get a more holistic view of data found in multiple charts, use drill through. Drill through is a technique that allows users to navigate to related visualizations. Sam is working with a visualization that shows the different types of food donated by category over the last month. One of the categories is cereal, a popular food for community members. Sam wants to know how many pounds of cereal have been used by people who visit the community kitchen, so they click on the cereal label. This takes them to a new report that is pre-filtered to display only information on cereal and helps them quickly find the information they need. This makes it easier for Sam to find the data they are looking for and spot trends in the data. Drilling up, down, and through are all great ways to understand your data from different perspectives. But, like always, the best technique for you will depend on your data and your business needs. When a traffic event occurs, traffic analysts are on the clock. They need to keep track of a ton of constantly updating indicators from traffic cameras, GPS data, and weather reports to help them predict the flow of traffic and make decisions that will advise people to plan their commutes. A live dashboard is a data visualization tool that provides near real-time updates. This can be a valuable tool for traffic analysts who want to keep the traffic moving and commuters informed. But live dashboards are not just for tracking traffic flows. Organizations in many different industries use live dashboards to help them make quick decisions when time is of the essence. 3 key features of live dashboards are time-sensitive data, automatic refreshing, and alerting. Let's break these down. Time-sensitive data, also known as perishable data, is data that must be acted on within a specific time frame, or it loses value. An example of time-sensitive data in action is a stock ticker. A stock ticker is a tool that financial investors use when trading in financial products and stocks. The ticker constantly updates with the latest stock prices. Investors, traders, and brokers monitor this steady flow of information to spot trends in the latest data and make decisions about whether to buy, sell, or hold. The data in a live dashboard works in a similar way. A live dashboard uses charts and graphs to present time-sensitive data, helping decision makers identify trends and get answers to urgent business questions. A second key feature of live dashboards is automatic refreshing. Automatic refreshing is a process that enables dashboards to be automatically updated at regular intervals. This gives users an overview of the current state of their metrics at a glance. Next up is alerting. While live dashboards present time-sensitive data that is frequently updated, few teams have the resources to monitor a dashboard all the time. Alerting is a feature that enables dashboard users to receive a notification when predetermined conditions are met or exceeded. Alerting is useful on a live dashboard because it can help data teams detect problems early, even if data team members are not actively monitoring the dashboard, and keep everyone informed when important changes in the data occur. Time-sensitive data, alerting, and monitoring are 3 features that make live dashboards especially helpful for users to monitor urgent, time-sensitive data like key performance indicators, or KPIs. Let's check out how this works with an example. Joe, Zara, and Chang are responsible for their business's web page, and they use a live dashboard to help keep tabs on their website's KPIs. Joe monitors the average time spent on each page by the site visitors. One day, Joe notices the time website visitors spend on a page is decreasing. To get another opinion, Joe shares his findings with Zara. Meanwhile, Zara notices page load time increasing. Both insights are based on the most up-to-date data available, so Joe and Zara agree something may be wrong. They decide to share the dashboard with Chang to discuss what to do next. Using the shared dashboard, Chang is able to quickly compare the charts and notices that the changes Joe and Zara observed in the data started at about the same time. Chang agrees that there may be an issue with the website, so the team investigates further. By monitoring their data in near real time, the team can spot trends in the data and act quickly. Soon, they found the source of the issue. Now the data team can apply a fix to keep website traffic flowing. But what would happen if the team was away at the time? Alerts have them covered. To make sure they get notifications when they're away, the website data team has set up an alert in the dashboard that will notify them when the web traffic exceeds or falls below a certain threshold. This threshold is a value that, if exceeded, indicates that there may be an issue that needs their attention. This way, the team can react quickly to any potential problems, even when they're not actively monitoring the dashboard. Dashboards offer data teams a range of useful applications, from tracking traffic patterns to monitoring website activity. A live dashboard can be a powerful tool that can help teams across an organization have the data they need to make important, time-sensitive decisions and stay on top of trends. In your role as a data analyst, you will be sure to find dashboards a great asset to your work too. Hi, in this video, you'll learn about the changing role of a cloud data analyst. Organizations have access to so much data that it's revolutionized the way teams across organizations think about and use data to drive decision-making. In the past, data teams were gatekeepers. They managed their organization's data sets and determined how the data could be analyzed. But with the rise of self-service analytics and the increased use of data-driven decision-making across more teams in an organization, the role of data teams is rapidly changing. Today, instead of gatekeepers, data teams serve as facilitators. Data teams work cross-functionally to ensure the safe, uniform, and efficient use of data for decision-making across an entire organization. The new role has also brought new responsibilities for data teams to improve data literacy across the organization, establish data governance policies and procedures to keep data secure, promote a common data language, and foster collaboration across teams. Let's dig deeper into these responsibilities. Data literacy is the ability to understand and use data. In many organizations, non-technical employees are being asked to work directly with data. This has increased the need for data literacy across teams. As part of an organization's data team, you might help define the skills employees need to be data literate to fit a specific role and train them to use their data effectively. You may also serve as a resource for teams to help them understand the data and get the most from their data insights. Another way you may help facilitate a data-driven culture in your organization is by working with your team to ensure solid data governance standards are in place. Data governance is the process for ensuring the formal management of a company's data assets. As more team members have direct access to data, data governance has become an important part of a data team's responsibilities. One way to govern data is by defining and assigning user roles and responsibilities based on how team members will interact with the data. This makes sure that everyone has the data they need to get their jobs done while also keeping the data safe. As more people work with data across an organization, it's also important to have a common data language. This means that data teams should create definitions so that the entire organization universally understands the terms used to describe the data. As part of an organization's data team, you may be tasked with optimizing and structuring data in a way that promotes the use of a common data language. This will avoid ambiguity and improve data quality. Finally, a data-driven culture is a culture in which both technical and non-technical workers collaborate and feel empowered to make decisions with data. As a cloud data analyst, you will use your data expertise and experience working with various teams to foster collaboration and help teams share data resources, work together with data, and drive decision-making. The role of a data analyst in today's businesses is changing. While an organization's data team was once thought of as a gatekeeper for the data, today the data analyst's role is increasingly becoming one of facilitator. As a cloud data analyst, not only will you work with data directly, you will also work across teams in an organization to help foster a data-driven culture and help others make decisions with data. Hi there. You've completed another section of this course and are getting even closer to your goal. Great work. As you've been discovering, organizations regularly work with high volumes of data. So they require tools and methods for effectively exploring large data sets, then helping teams realize the full value of that data. With this in mind, you found out how to identify enterprise-grade visualization tools, key features, and how they're used to meet business objectives. Then, you discovered why it's so important to explore large data sets with visualization tools. Next, you learned how to work with a real data set to build a dashboard that met a specific business need. Finally, you dove into how the role of a cloud data analyst is evolving and the importance to share and collaborate in the modern business environment. Big congrats to you on your progress. Hello, and welcome to this section of the course all about developing data models and addressing complex business needs. As a data analyst, when you create visualizations with a user interface, you can build key components with a click and not have to worry about writing code. But to meet more complex business needs, a data modeling language is very helpful. You'll learn all about that coming up. First, you'll learn about data team members who work with data sets and data modeling languages. These data team members are known as developers. You'll explore the developer role and environment and the tools developers use to work efficiently. Next, you'll get into data modeling languages and how they help meet business needs. You'll also gain experience working with a modeling language to define dimensions and measures. Then, you'll learn more about how developers view and work with dashboards as code. Finally, you'll explore ways data modeling languages are used to address complex business needs, including derived tables and caching. Exploring data modeling languages and the underlying code are great ways to better understand what's going on behind the scenes when you build a visualization. With this new knowledge, you'll be able to make your dashboards and reports work even better for your stakeholders. Let's get started. When working on a project, it's useful to have a user-friendly set of tools that you can use together to help you get the job done efficiently. For example, you're writing a note to a friend, and you want to draft this personal correspondence with a typewriter. You may need to use a dictionary to check the spelling and find and correct any mistakes. This can be time-consuming and error-prone. These days, using a word processing app is a popular way to write a letter. This software often has automated features that can check the grammar, spelling, and formatting. This saves time and prevents mistakes. Like word processing apps, an IDE can help developers get their job done. An IDE, or Integrated Development Environment, is an application that brings together the tools needed for development in a user-friendly environment. In this video, you will learn how to use an IDE to develop your visualization projects efficiently. Let's dive in with an example. Min is developing a visualization project using a data modeling language. To improve workflow and help save development time, Min uses an IDE that's integrated into the developer interface of our enterprise-grade visualization tool. To develop the model, Min enters code directly into a code editor. Like a word processor, an IDE's text editor makes it easier to write in a specific language and includes editing and formatting options. So, when Min enters code in the data modeling language LookML, the code editor's autocomplete predicts the code Min may want to use. This saves time and helps Min write more efficiently. Min can also check and fix her syntax quickly thanks to a built-in syntax highlighter that's designed specifically for the language she is using. An IDE is also useful for debugging code. The IDE's built-in debugger highlights possible errors in the code and suggests fixes. This makes it easier for Min to track down errors in the code quickly and spot issues that may otherwise be hard to find. This helps Min write cleaner, better functioning code. Min is also able to easily find the metadata she needs because the visualization tool is integrated into Min's development environment. This gives Min information about the model's structure and helps Min write code efficiently. Min can also use the IDE to access files for the project, all in one place. This is helpful because it saves Min time and effort and keeps the project organized. Finally, When Min wants to track code changes and deploy the code, Min can use the version control tools integrated within the IDE. Version control makes it easier for Min to collaborate and share code with other members of the data team for feedback. While the exact features vary depending on the IDE used to develop your project, an IDE is a great way to more efficiently work with code and have all the resources you need to do your job in one place. Using a data visualization user interface, or UI, can be a quick and easy way to make changes directly to a deployed dashboard. But it's not always the easiest way to manage dashboards. When you make changes to the deployed dashboard, it can be difficult to track down any bugs that may be introduced. Additionally, if 2 or more developers are making changes to the same dashboard at the same time, they may accidentally overwrite each other's work. To prevent errors from reaching the deployed dashboard and to make it easier to collaborate, some development teams use a process called version control. Version control is a process to track changes to your code, data, or other files over time. Using version control can be a great way to manage changes for a complex visualization project. To start, let's break down the parts of a version control project. First, a repository is a central location for storing and managing the files and history of a project. When developers use version control to store a visualization project, creating a repository is usually the first step. This can be done locally, but repositories are often hosted on a remote server. This repository becomes the central location or single source of truth for all the changes developers make to the project. In a repository, developers make all changes to a project in branches. A branch is a working copy of a repository. Like a tree branch that splits off the trunk, a branch in version control splits off the main project code. This allows the branch to grow in its own way and form an independent development path. When a developer creates a new branch, it's a duplicate of the main project code. The developer can then use this copy to make changes to the code. But since the branch is independent, any changes the developer makes to the copy do not impact the main project or other branches. Instead, the changes are local to that branch. This makes version control a really powerful tool when developers need to collaborate on large-scale projects and want to review changes made to the dashboard before it goes live. Let's explore an example. Min and Carl are part of a team building a complex dashboard. They've each been assigned an important feature to work on. To start, they each create their own branch in the shared repository. This creates a separate copy of the code that they can work on independently. This way, they can work on their assigned features without impacting anyone else's work. They can also use their branches to collaborate. So, let's say Carl gets stuck and needs help deciding how to implement a feature. Carl shares a branch with Min, who can then comment on Carl's code and provide feedback. Min can help Carl get unblocked and move forward. Min and Carl can also share their branches with other team members to test the code and spot potential bugs or errors before the code goes live. This is a great way to collaborate and ensure the code is high quality. When the work in a branch is complete and tested, the changes Min and Carl made can then be merged back into the main project code and deployed to the live project. Using branching then allows teams to independently work on features, collaborate, and test their work before the dashboard goes live. Developing complex visualization projects like dashboards can be a lot of work. And if you're working on a team, it can be even more challenging to keep track of changes and make sure everyone is on the same page. But with version control, you can track changes over time, collaborate with others, and keep your projects organized. Hey there, and thanks so much for joining me in this video on data modeling languages. First, some quick definitions. A data model is a concept for organizing data elements and how they relate to one another. It can be visually represented to show how the data is structured and how it relates to each other. But what is a data modeling language? A data modeling language is a tool used to create and represent semantic data models. And to dig a little deeper, a semantic data model is a type of data model that uses everyday language to represent data. This makes it easier for users to understand the meaning of the data and how it relates to each other. As a cloud data analyst, you have many data modeling languages available to build semantic data models, and each one is unique. But there are 3 common modeling language features that make data modeling languages a good choice for building data models, regardless of the language you choose: abstraction, modularity, and efficiency. Let's explore each one. Abstraction is a concept used to understand complex concepts and ideas by focusing on the most essential parts. Working with data can be complex, but data modeling languages use abstraction to reduce this complexity. Using a data modeling language, developers can focus on the essential parts of data modeling, designing a model that is accurate, efficient, and reusable. Having an easy-to-use data model also helps end users interact with data without having to worry about the complexity of accessing it. Instead, they can focus on getting their work done. Let's take an example to see how this works. As a developer, when using the data modeling language LookML to create a dimension, you describe the name, type, and the SQL statement needed, but you do not need to know exactly how to implement it. LookML can help. The underlying LookML engine uses this definition and determines how it will work. That's why data modeling languages are easy to learn and use. Plus, when developers use LookML to define their business logic as user-friendly dimensions and measures, it makes it easier for users to explore the data with confidence. Data modeling languages are also modular. Modularity is a concept that breaks down a system into smaller parts that can be easily separated and reused. For developers, a key benefit of modularity is having parts that can be separated into smaller, self-sufficient chunks. Modularity makes it easier to work on large projects, especially when working as a team. Reusable components can also save time and keep both definitions and projects consistent. For example, when using LookML, you can create a measure once and then reuse it as many times as you need in the same project or even in another project entirely. Reusing a measure saves developer time and ensures business users have a single source of truth. Better yet, the measure works the same way each time it's used. Finally, data modeling languages can provide efficiency to your workflow. The ability to reuse measures and even entire data models saves time and effort when developing new systems. Many data modeling languages include built-in validators that allow you to check code syntax and catch errors before the code is deployed. Data modeling languages also allow you to generate documentation for the models. This helps to communicate important information about the data models and other components to data team members who may need to reuse elements that you've built. As a developer, the data modeling language you choose will depend on the task at hand and the tools you're using. But no matter which language you pick, data modeling languages are a valuable tool that can help you improve data quality and build more effective models. Hi, and thanks for joining me. In this video, you'll learn ways a data modeling language can be used to address on-the-job problems and help users make the most of their data. Data modeling languages can help improve data quality and increase efficiency. But to be useful to an organization, data modeling languages must help meet business needs. A data modeling language is a tool used to create and represent semantic data models. As a data analyst, you'll work with enterprise data and use data modeling languages. These languages offer you three primary advantages. They can be used to define fields in the semantic layer in a user-friendly way, create a single source of truth, and build visualizations that meet specific business needs. Let's examine examples of each benefit. First, use a data modeling language to add a semantic layer on top of the data. A semantic layer is a set of definitions and logic that helps ensure that everyone in the organization understands the data in the same way. The semantic layer defines fields describing the structure of data. For example, a data team for a large nonprofit can use a data modeling language to define dimensions and measures to create common definitions across their donor data. This means that everyone in the nonprofit who needs to use the data will share the same vocabulary, which can help prevent misunderstandings and errors. It can also make it easier for users across teams to communicate about the data. Second, you can use a data modeling language to easily create a single source of truth so users throughout the organization can access the same data at the same time. For example, a hospital data team can use a data modeling language to build a data model that brings patient data together into one place. Then, using that data model, they can create interactive dashboards to allow doctors and nurses from the hospital to have access to all the information they need. This allows the nurses and doctors to share the same information about patients and their care, enabling them to make timely informed decisions and help improve patient outcomes. Third, data modeling languages allow you to build visualizations for a specific purpose. that can help lead to data-driven decision-making. For example, say a financial services team needs to track the performance of their investments in near real time. Using a data modeling language, the data team can define the structure and layout of a dashboard and any interactive features and visualizations to help financial services find the information they need swiftly. The data team can provide financial services a dashboard with visualizations that meet the needs of the financial services team. This dashboard helps financial services access and interact with the information they need to make data-driven decisions quickly, maximize returns, and protect their clients' investments. Whether you're part of a nonprofit, hospital, or financial services firm, as a cloud data analyst, you will be tasked with using data to meet business needs and help teams collaborate more efficiently with their data. Data modeling languages are a great way to do this because they help teams better communicate and understand data. This keeps everyone on the same page. Welcome to this video on Dashboards as Code. The Dashboards as Code approach is a hot topic in the data visualization world, and for good reason. Data visualization tools have made it simple for even non-technical users to create dashboards and other visualizations with ease. But as the number of dashboards within an organization grows, dashboards can be a challenge to keep track of. That's where the Dashboards as Code approach comes in. Dashboards as Code is an approach to managing dashboards by defining them in code. This makes it easier to track changes in your dashboards, test your features before making them live, and reuse entire dashboards again and again. Why manage dashboards using the Dashboards as Code approach? The simple answer is that the approach enables data teams to deliver visualizations that users can trust because, like a software product, the visualizations do not go live before the data team iterates, reviews, and tests the dashboard. Consider, for example, a user makes a change to a dashboard with a visualization tool's user interface. Every time the user makes a change, the change goes live immediately. And if the change introduces an error, there's no way to easily revert it back to a previous version. For large teams that work with multiple dashboards, this can make it hard to maintain dashboards and fix mistakes when they happen. In contrast, Dashboards as Code works with the underlying code that makes up a dashboard. Using a Dashboards as Code approach means that developers build a dashboard using a language of their choice, store the code using version control, and then deploy the dashboard when they're ready to go live. Then, when developers need to change the live version of the dashboard, they make changes to the underlying code in a developer environment. This allows the data team to track and peer review any changes before the changes go live. There are 3 advantages when developers track changes and review dashboards. First, since developers are tracking changes, they can easily roll a dashboard back to a prior version if a problem arises. Second, developers can easily comment on and review changes to reduce dashboard errors. And since the dashboards are stored as code, developers can reuse dashboards across different tools easily just by importing the code. Third, developers can test and validate features, or even entire dashboards, to make sure dashboards work as intended before going live. Ultimately, this ensures only dashboards of the highest possible quality reach users. It's important to call out 3 potential challenges with the Dashboards as Code approach. First, as a data analyst, the approach can have a steep learning curve if you're not familiar with coding. Second, if you're using a visualization tool that doesn't support Dashboards as Code, you'll need to find a different tool or learn how to code in a different language. Third, it can be time-consuming to build entire dashboards using code. Dashboards as Code is a powerful approach that can help organizations manage their dashboards effectively. But before deciding on a Dashboards as Code approach, it's important to weigh the pros and cons to decide if it's truly a good fit for your organization and data needs. Hey there! In this video, I'll demonstrate how to solve complex data problems using derived tables. As a cloud data analyst, you usually write queries to request specific sets of data from existing tables in a database. But sometimes these queries can get complex. And what if the data you need isn't readily available in a table that exists in the database? That's where derived tables come in. A derived table is a query whose results are used as if it were an actual table in the database. But derived tables aren't independent queries. They are nested within an outer query, which means that they cannot be executed on their own. The outer query uses the results of the derived table to create its own results. A derived table's job is to gather the specific data you need to answer the question posed by the outer query. The data is stored as a virtual table and the outer query can use the information just like it was a regular stored table in the database. And once the outer query is finished running, the virtual table is usually deleted and is not stored in the database. Let's explore how this works. Liz is a data analyst at a large nonprofit. To better understand donor behavior, Liz was asked to identify two types of donors. First, mega donors, who gave more than $10,000 total in the past year. Second, frequent donors, who donated more than 3 separate times during the same period, regardless of the amount. But this exact data does not exist in a table in the donor's database. So, to get the data she needs and make her query easier to read, Liz decides to use a derived table. First, she identifies the data she needs to run the outer query successfully. Then, she writes the query for the derived table. This query gathers only the information that is useful for the outer query. In Liz's case, the query they write for the derived table groups the donations by donor ID and then aggregates the data to count the number of donations and total amount donated for each donor. Liz then writes an outer query that uses the results of the derived table to find the information. The derived table query is nested inside. When Liz runs the outer query, first the nested query executes and gathers the information needed into a derived table. Then, the outer query uses that information just like it would an actual stored table to answer a data question. In this case, the outer query uses the information from the derived table to identify both mega donors and frequent donors over the last year. Once the outer query is completed, the derived table is usually discarded. So, every time the query is executed, the virtual table is created again. Derived tables have both limitations and benefits. First, we'll cover limitations of derived tables. Because a derived table must usually be created from scratch each time the outer query is run, it can potentially impact performance, especially if the derived table is complex. Derived tables are not usually persistent, meaning they are not stored in the database and not reusable in other queries. Instead, if you want to use the results of a derived table in another query, you need to recreate that derived table as part of that query. But despite the limitations, derived tables offer several benefits for data professionals. Derived tables simplify complex queries and break down complex queries into modular parts. This makes the queries easier to write, read, and execute. You can also use derived tables with enterprise-grade visualization tools. This enables users to perform complex calculations on data and even create custom views and reports. Needless to say, derived tables provide a powerful way to work with data using data visualization tools. As a cloud data analyst, derived queries can help you solve complex data problems and ensure your queries are simple but effective. Although derived tables are a great tool, it's important to use them wisely. Make sure you weigh the trade-offs between the performance of the derived table and how to best meet the business need with your data. When it comes to data visualizations, speed and accessibility matter. Slow load times can hurt users' ability to make timely decisions with data and meet their business goals. So, to make sure people have access to the data when they need it, cloud data analysts leverage caching. Caching is the process of storing data in a temporary location so it can be accessed more quickly in the future. As a cloud data professional, you can use caching to keep frequently used data in memory. Caching has 3 benefits that improve the performance of your visualizations: reduce traffic to the data source, minimize load time, and maintain availability. Let's explore each of these benefits. The first benefit of caching is that caching stores a query's results in memory for a period of time to reduce traffic to the data source. This reduces the number of queries sent to the data source, reducing traffic. For example, a large warehouse data team uses a dashboard to monitor time-sensitive inventory data. Without caching, every time a data team member interacts with the dashboard and requests information about the inventory, a query is sent to the data source for the specific inventory information. The results return and refresh and populate the visualization. But this can cause a lot of requests being made to the data source, especially when there's many users or if the data is accessed frequently. Plus, the same data is likely to be requested and returned more than once. That's inefficient. To help reduce traffic to the data source, the data team may enact a caching policy. A caching policy is a set of rules that determine how long cached results are stored in memory and when they are refreshed. With a caching policy in place, The data team decides how often the database should refresh the dashboard data. This reduces the number of queries issued to the database. Here's how it works. Before sending a new query to the database, the memory is searched to determine if the results have been cached or stored in the memory. If a cached copy of the data is available, it's used for the visualization and no query is issued to the database. If not, then a query is sent to the data source and the results are used in the visualization and stored in memory for a period of time. So, instead of running a query directly against the database every time the data is requested, a query is run once and then the results are stored in memory where they can be quickly accessed again. The second benefit of caching is that it can help minimize load times. Caching can also minimize the load time of visualizations because the data can be loaded from memory, not the data source. This can save significant time, especially when working with a lot of data. The third benefit of caching is that it can help maintain the availability of data visualizations by storing results in memory. This can be helpful in situations where the data source is unavailable or when the internet connection is unstable. But while caching is a great way to reduce traffic to the data source, minimize load time, and maintain availability, as a cloud data professional, there are some considerations you should keep in mind. First, caching can lead to stale data. To prevent this, it's important to set a time limit for caching, meaning the time frame is long enough that the retrieved data will actually be used in a visualization, but not so long that the data will be out of date. Second, you need to monitor caching. This means you need to make sure users are accessing up-to-date data and the cache is working properly to store data and delete it when it's expired. Caching can help improve the performance of your visualizations, reduce load time on the database, and help make sure data is always available to your users. But not all caching policies are the same. So when considering a caching policy, it's important to make sure that the policy works for your organization's data needs. Wow, you've achieved another milestone in your journey to becoming a cloud data analyst. You're really showing your dedication to the field. You've learned all about how developers work with data modeling languages to build custom data models and meet complex business needs for their users. You also explored the role of a developer on a data team and the tools developers use to get the job done, including IDEs and version control. And you delved even deeper into data modeling languages and learned about building custom dimensions and measures. You also explored ways developers view and work with dashboards as code. Finally, you discovered ways developers can use a data modeling language to address complex business needs by creating derived tables and enabling caching. Congratulations again. It's been awesome sharing these lessons with you.
Hi, I'm Lauren.
Hi, I'm Andrew.
It's time to take a look at another interview that's in progress. In this interview, the questions will cover cloud data analytics topics related to data visualization in the cloud.
We hope this will help you know what to expect in your next interview.
What interests you in cloud data analytics? What are you looking for in your next role?
What really interests me about cloud data analytics is really diving into the raw data and telling a story. There is such a gratifying experience from really digging into the levers that happen in real life that you can then see reflected in the data, and then using that to tell a story to then really drive like an actual change to the business or to a process that you're working on. That kind of impact, basically using numbers and code, is something that's always been very interesting to me. So in a new role, I'm definitely looking for a challenging environment where feedback and iteration are abundant. I think the more learning I'm exposed to, the more excited I feel.
Imagine this scenario. A stakeholder made a request to create a dashboard to meet key performance indicators. What are the steps you would take to ensure the dashboard could be used by the stakeholder?
First, I'd really want to get familiar with the stakeholder, understand their familiarity with the data, understand their specific business needs, all while using the SMART approach, so specific, measurable, action-oriented, relevant, and time-bound, in hopes of uncovering needs and considerations that that stakeholder hadn't yet thought of in this exploratory process. The positive takeaway would be a visualization that the stakeholder could then use to drive meaningful and impactful change in their project or process.
Tell me about a time you created data visualizations. What visualizations did you create, and how did you decide what visualizations to use when representing the data?
I decided to create dashboards embedded with pie charts because I took the time to understand my audience and I realized that they weren't very technical. And so a lot of the metrics and data I needed to present in this visualization needed to be high level enough and easily filterable so that the stakeholder or the user could be able to take all the insights that they needed to in that. And I specifically chose to use reputable and strong data sources with adequate access control so that the people viewing that dashboard could only see the data that was relevant to them. The takeaway I had was to really focus on the audience or the user, because then that would, in a sense, retroactively inform all of the visualizations I would end up making.
What are some common visualization types and when would you use them?
Some common visualization types are pie charts, bar charts, line graphs, waterfall charts, and the context of how I would use them would really depend on the stakeholder and their needs. So if we really want to represent change over time, that might mean a line graph or a bar chart. If we want to say what pieces make up a whole, then a pie chart might serve a better purpose in that sense. But it really has to start with understanding the stakeholder.
Great. Do you have any questions for me?
A question I have is, if you had a disagreement between a junior analyst and a manager, how would you manage it?
That's a really great question. It's very important to me that everyone on our team and everyone within our working group feels comfortable and safe working together. So the first thing I would do is talk to both the junior analyst and the manager separately. I'd gather the facts. There's always two sides to every story. I'd really want to get a better understanding of what actually happened. I would encourage them to speak with each other privately, but of course offer my support if they would like me there. Everyone has different working styles. Everyone has different ways of doing things. And my hope is that through discussion and through open conversation, we could get to the right resolution. In this scenario, Andrew demonstrated how to end responses with positive takeaways. You too can talk about challenges that you faced and end with the positive takeaways that you had.
A huge congratulations on finishing this course. I love telling stories with data. One of the most satisfying parts of my job is hearing customers say, "Wow, I had no idea that was happening," or, so now it makes sense. As a cloud data analyst, you'll have the opportunity to tell your own data stories and teach others to leverage the power of data. Let's revisit all the cool things you learned in this course. You started by learning about storytelling and how to captivate your audience using insights from the cloud. Then we got into the basics of user experience, or UX, and user interface, or UI, designed to create compelling communication. Next, you learned about the implications of data types on design, including how data types inform design choices and examine common design patterns used in business intelligence dashboards. Then, you explored ways to work with stakeholders to translate requests into visualizations that get results. You then discovered how to access and explore data for visualizations. You learned about dimensions and measures and how to model data for visualization. You also learned to work with a visualization tool to build a simple dashboard. Next, you learned how to work with large data sets and use business data visualization tools that can work on a large scale, integrated security features with robust functionality that fits within the IT infrastructure. This involves strategies for fostering a data-driven culture and keeping data organized and secure. Finally, you explored the developer environment, practiced how to model data with a data modeling language, learned tools to write dashboards as code, and use a data modeling language to address complex business needs. You are now prepared to champion data literacy across your organization by knowing how to visualize data in a way that's intuitive for both technical and non-technical users. Congratulations again.
Congratulations! You've arrived at the final course. Put it all together. Prepare for a cloud data analyst job. You'll first gather your experiences with the basics of data analytics, cloud storage and data management, data processing and analysis, and visualizing data in the cloud. And then you'll learn how to put all of this together to prepare for a cloud data analyst role. This course is going to help you develop a resume fit for a data professional and provide you with some tips and tricks to prepare for an interview. You'll also learn how to create a portfolio project to demonstrate your skills to potential employers or clients. By the end of this course, you'll have a greater understanding of the job application process, what skills, as a data professional, are expected for data professionals to have, and how to tailor a resume specifically to the field. Additionally, you will have a concrete demonstration of your new cloud data knowledge that you can use to discuss with potential employers during interviews. Let me introduce myself. My name's Christine. I work as a cloud architect at Google. This means that I work with customers to design cloud solutions to address their business challenges. I work alongside our customers to help them understand the art of the possible with Google Cloud. I help them adopt our products and services from a technical standpoint, as well as introduce them to the latest and greatest of our technology, since we are constantly developing and improving all across the board. We have a large number of services in our vast portfolio, from compute infrastructure to artificial intelligence. And really, it's my job to help our customers figure out which architectural pieces work best for their puzzle. I first learned about data analytics out of necessity in my previous engineering roles. There are many business challenges at any organization that can be solved with cloud and automation. I've used cloud to build data pipelines and business intelligence dashboards that generate insights for other departments at my previous companies. Today, I solve problems not just for Google Cloud customers, but for our own internal processes as well. Really, the possibilities are endless when it comes to your role at a data-driven organization. I'm excited to introduce you to the final steps that will prepare you for your first cloud data analysis role. We'll start with identifying career resources that are specific to cloud data analysis. First, you'll review types of job roles that are available. Next, you'll identify why it's important to develop a portfolio project. Then, you'll get valuable tips for how to update a resume tailored to a cloud data professional role. And finally, you'll prepare for interviews. Now let's get started on what's involved in developing portfolios and share tips for completing the portfolio project. You'll then explore how to complete the portfolio project. Up next, you'll discover the best practices for how to incorporate projects into your portfolio. And finally, you'll explore how to showcase your work and claim your Google Cloud Data Analyst certificate badge. You've come a long way and you're almost done. Let's get started. Hi, I'm Christine. As a cloud architect at Google Cloud, I've worked with a variety of customers, from large enterprises to digital native startups, to help them not only envision what's possible with Google Cloud, but also to help them build it too. I use my background in data analytics to help customers solve their business challenges, wherever they may be on their journey to becoming a data-driven organization. I started out as a traditional chemical engineer in the energy industry and spent time within different departments of a huge enterprise company, learning how different teams work and interact with one another to execute on business initiatives and capital projects. Data started to become a focus of our company, who then looked for more ways to leverage our data for both internal and external use cases. I had the data domain expertise from having spent time in operations and learning the business from the ground up. Because of this, I got the opportunity to become a product manager, commercializing our software products to bring them to market. I never would have thought I'd get a chance to work for Google. And now, as a cloud architect, I feel so lucky to get to make an even broader impact by helping businesses in all industries leverage our technology to solve their greatest challenges. Time flies when you're having fun. What I love about my job is that no 2 days are ever the same, and there's always something new to learn. I work with different customers in all industries to help them figure out the best ways to leverage and build with Google Cloud. A typical day for me may include talking to customers about their future product roadmaps and figuring out which architectural pieces of Google Cloud tech will fit best for their puzzle. Other times, I'm diving deep into one of our new data services with a customer to understand how their use of it within their internal or external product workflows can be improved or optimized. I advocate for our customers and work with product teams by filing feature requests to help make our products better, as well as ensure customers are using the right tool for the right application. I also work with startups through accelerator programs to help advise them on how to build the best future-proof data platform that'll scale with them and yield the data that they need to leverage in future ML applications. I also work with a vast number of partners to scope and deliver new innovation projects for customers. A few times a year, I'll even get the opportunity to speak at some of our technical events and network with developers to help showcase new products, services, and features. My role as a cloud architect is an extremely dynamic role that I'm super grateful for. It gives me the opportunity as well as the flexibility to lean into the different parts of my job that I find most rewarding. There have been many projects that I've loved working on throughout my career, and one of my most favorite initiatives here at Google has been facilitating innovation workshops with some of our Google Cloud customers. I love working with companies to help them find more innovative ways to reach their goals and solve their challenges. In these sessions, we work hand in hand with technical teams to show them the art of the possible and brainstorm ways to solve their challenges with Google technology. More often than not, we've already solved the problem in some way or fashion. It's all about collating some of our experience and piecemealing all of our learnings together to inspire what the next solution looks like. There are so many ways we've used data and AI to approach and solve problems. And we still continue to do so each day. Whether it's working with power companies to figure out how to improve grid reliability and transparency, finding the most optimal location for geothermal wells, or synthesizing legal contracts and documents to surface meaningful insights or proactively identify gaps. Our customers are always looking to solve some of the world's most meaningful problems. Throughout my professional journey, I've received tidbits of great advice along the way that I'd like to share with you all as well. Remember that learning is a lifetime journey. Technology like this doesn't stay the same for long, but the foundational aspects you've learned will still remain relevant. This past year has been the best example of how quickly new tech emerges, which is what makes technology so exciting. Consistent practice and development is key. Practicing each day will always be more beneficial than occasional bouts of learning for hours or days at a time. Focus on the user and all else will follow. When solving data problems, or any problem really, it's important to think about what problem you're actually solving and whether people will find the insights that you surface useful. Think 10x. At Google, we pride ourselves on a healthy disregard for the impossible. We try to expand on each opportunity to find ways we can push the envelope. When brainstorming ways to solve problems, we ask everyone for all ideas and inputs. We don't hesitate to frame our solutions with an expansive yes and. Prototype and test out your ideas early before spending all of your time building the foundation. You want to ensure the problem you're solving with the data you're given is actually possible before you put in a ton of effort into cleaning and transforming data. As an example, making smaller pipelines or models to test out whether there's a strong correlation between the data you have will save you a lot of time in the long run, as opposed to building out entire ETL pipelines with data that really isn't reliable at all. Make contact with others early and often. Putting all of these concepts into practice by testing it on authentic problems and situations will give you a quick feedback loop to help iterate on your solution. It'll get better each time. Welcome! Now that you're more familiar with the world of cloud data analytics, let's explore some cloud data analyst career resources that will help you on your professional journey. You'll discover a variety of career resources and tips that will help you effectively navigate the job market to find a new role as a cloud data professional. First, you'll explore the different types of roles available and their specializations. This will enable you to focus on opportunities that will be best fit for you. You'll also uncover clues to solve the mystery of what it takes to impress hiring managers. You'll find out what hiring managers want so you can communicate your value and create a project portfolio that demonstrates that you're the right person for the job, even if you haven't had a lot of on-the-job practice yet. Next, you'll explore how to refine your resume to include your new skills and experience. And finally, you'll identify interview tips that will help you prepare for interviews and impress an interviewer team. I'm so excited for you to take this step on your journey. I'll meet you there. You've come so far. It's time to start thinking about getting the job that you want. There are some specifics about looking for a cloud data analytics job that you'll want to know. First, you'll want to identify appropriate opportunities for your ability and current skill level. Usually, these will be denoted with terms like intern, junior, or entry level. These roles are suitable for people just like you that have been practicing cloud data professional skills, completing a certificate program, and are now ready to start using these skills. Additionally, there are several different types of roles that are categorized under Cloud Data Analyst. You'll need to understand the differences between them to determine which you are most interested in. A Cloud Data Analyst is a bit like a generalist, which is a versatile role on a data team. In this role, you would likely work on a variety of different types of projects under the guidance of more senior analysts. Operations analysts work specifically on the operations aspects of the business. This can include evaluating employee and operations performance and procedures for optimal efficiency. If you're really good at math and statistics, you might be interested in a quantitative analysis role. These analysts spend a lot of time with numbers, conducting statistical analysis, and working with algorithms. If you're more interested in helping unblock strategic decision-making for a business, you might prefer a business intelligence analyst role, where you could work on projects that vary from marketing to competitive analysis to product development. Another thing to consider is that these roles will vary between different industries. If you're interested in a specific industry, then search for roles there. As a cloud data analyst, you may choose to develop skills with a specific industry focus, such as financial services to healthcare to manufacturing. For example, if you're interested in the finance industry, you could search for a junior financial analyst or an entry-level quantitative analyst role. Pro tip: use both the job titles and the industry that you're interested in when searching for jobs. This will help you find roles that are a great fit. Next, as you start reviewing job descriptions, you may find that you don't have all the skills to use the tools listed. Don't let this discourage you. First, keep in mind that those job descriptions are frequently a wish list of skills. You may be a great applicant even if you don't have every skill in the job description. And many companies are happy to find people who match their culture and are willing and able to learn the tools they use. Take some time to search for those tools online to figure out how that relates to the skills and experience you have. For example, if a company is looking for Tableau experience, you can explain in your cover letter how your experience with Looker would easily translate to Tableau. You might also consider using free versions and trials of those products so that you can get experience working with the program and add that to your resume. This should help you to get started on the search for your next cloud data analytics role. Good luck as you take those first steps to your next big professional adventure. In this next section, you'll begin working on your first cloud data analytics project. In addition to providing you with valuable experience, you can also add this project to your portfolio. A resume is generally not enough to get a data analytics job. You'll also want to demonstrate your abilities and experience with a data analyst portfolio. A data analyst portfolio is a website that showcases who you are, your skills, and the projects you've worked on. The portfolio is where you'll be able to post examples of the reports and dashboards you've created to show to prospective employers. Like a resume, it's a good idea to start your portfolio with a short biography and cover letter. You could also describe your professional goals and experience. This will provide context for your projects and help you stand out against other applicants. Most importantly, you'll include project examples. These could be any reports, dashboards, or presentations you have created and have permission to share. Make sure to include a description of the project. This description might reflect a particular job skill or requirement to best indicate your accomplishment to a potential employer or hiring manager. There are several things that hiring managers will be focused on when reviewing your portfolio. First, you'll want to demonstrate your technical skills in data analysis and cloud technology. You'll also showcase your ability to create data visualizations like reports and dashboards, and use those to tell a story and create quick insights. You'll also want to demonstrate your workplace skills too. Critical thinking and problem solving are essential skills in cloud data professional roles. So is your ability to work in a team and work independently, because you'll be doing a lot of both. Additional skills that will serve you well include adaptability, verbal communications and written communications, and the desire and ability to learn new skills and programs. Hiring managers will also want to know how you can translate learned skills into real-world applications and business problems into actionable analysis. For example, it is a problem if a retail manager has to manually aggregate sales data from hundreds of stores every Monday morning. As a data analyst, you'll be able to create a dashboard that will allow the retail manager to quickly spot category trends. And you might be familiar with one or more of the different development tools that you can use to create visualizations, like SQL, BigQuery, and Looker. Demonstrate your understanding of as many of these as you can. Once you've created your portfolio projects, you'll need to create a place to host or display those examples. There are a variety of free and inexpensive options available online to host your portfolio. Creating an online professional profile is probably the fastest and easiest way to get your professional information online, even if you also decide to build your online presence in other ways. LinkedIn is a great option because it's free, fast, and easy to post a variety of work examples. If you'd like a little more creative freedom and flexibility, you might build a website. There are online options that provide templates to quickly create websites. Platforms like Kaggle and GitHub are also great options for members of the data science and data analytics communities to host their work. You'll want to check out these platforms because they offer a variety of other benefits beyond just hosting your portfolio. Posting your portfolio online is more than just preparing you for a role in cloud data analytics. You will likely want to keep your portfolio up to date, even after you've started your next data analytics role. If you keep your portfolio current with your best and most recent work that demonstrates your skills, you can advance your career to new opportunities when you're ready. Now that you've almost completed this certificate program, you might be thinking about updating your resume with your new accomplishments. Even if you've never had a job in cloud data analytics before, you can use your resume to highlight the new skills that you've been learning. If you haven't already, add a project section to your resume. This is a great place to link to the portfolio project you'll be working on for the end of this course. When you write this section, make sure to include details about the project and workplace scenario to add context for potential employers reading your resume. This will help them understand what the project is and how it applies to the work you do in their organization. If you've completed other projects, you can include those as well. Another important section to have in your resume is skills. Here, you'll want to list out all of the technical and professional skills you've acquired throughout this program. You've learned so much that you can include in your resume. You worked with business intelligence codes and tools like SQL, BigQuery, and Looker. You can identify different data structures and the differences between data sets, data warehouses, data lakes, and data lakehouses. You're familiar with all stages of data management, including understanding, analyzing, organizing, transforming, exploring, aggregating, handling, and reporting data. You can explain self-service analytics, where users can access a dashboard to find the information they need. And you can describe how to encourage insights through visualizations, including wireframes, charts, graphs, reports, and dashboards. You know how to communicate with stakeholders, ask critical questions, and provide solutions that meet their business needs. You've learned so much in this course, it's going to be hard to fit in a page or two on your resume. Remember to also include professional skills that you've developed in other roles, in other industries where data analytics may apply. Skills like attention to detail, time management, and teamwork will be an asset to any data analytics team. Finally, you'll want to be sure to include this certificate in the education section of your resume, along with any other certificates, courses, and other educational experiences you've completed. In the work experience section, you should also make sure you highlight any relevant experience you might have, including internships. Also, match your resume to the industry by taking some time to research current resume expectations. These can change over time, and you'll want to make sure that you're conforming to current standards. It's also critical to understand the systems that hiring managers are using to filter out resumes. Incorporate precise keywords in your resume that reflect the job posting's required skills, so that you can customize your resume accordingly. Go ahead and start adding new projects, skills, tools, education, and work experience to your resume now. You've learned a lot about adding projects to your portfolio and perfecting your resume with your data analytics skills and knowledge. Be proud of your accomplishments and get ready to share them with prospective employers. If your portfolio and resume catch a hiring manager's attention, they'll contact you to set up an interview. Some people find interviews a little intimidating, but practice and planning ahead can help you feel confident. Before any interview, it's important to research the organization and role. Practice responding to common interview questions, and make sure your portfolio and resume are up to date. It's a good idea to do some research about the organization before your interview. Understanding the organization's mission, core values, and culture helps you to determine whether you and the organization are a good fit for one another. You can usually find this information on the job description, the About page on the company's website, and the company's social media. You should also research the company's products or services, the company's customers, and the news articles about the company to better understand their business. Definitely make notes of questions to ask the hiring manager. Asking the right questions helps you and the company decide if this job is a good fit. You can also prepare for the interview by doing mock interviews, which are like rehearsals. Start by finding people in your network who would be willing to give you a mock interview. Ideally, these people are data professionals who understand what employers in the field might ask during an interview. Rest assured, though, practicing with anyone will be great experience. The data analyst hiring process usually includes several stages of interviews. The first step will be a hiring manager screening, where you are introduced to the hiring manager or recruiter. Next will be a technical screening, where you'll need to prove out your technical abilities. This could be in the form of an interview by a more senior data analyst or manager, or it could be a test that you complete either on-site or at home. There may be additional calls or interviews after these screenings, depending on the role or the company you're applying to. Last is the final interview, where a team lead or manager will interview you. This is where you and they will decide whether this role is a good fit based on their team and culture and your general business knowledge. Most recruiters or hiring managers will let you know how the interview process is structured ahead of time so that you can prepare for each phase. In a cloud data analyst interview, the hiring manager will ask a variety of questions to assess your skills, experience, and aptitude. When getting ready for an interview, it's helpful to think about and prepare for common question types. Questions tend to fall into one of the four categories: behavioral, technical, situational, or subject questions. Behavioral questions ask you to describe what you did and how you handled past situations. For example, you might be asked how you would deal with a specific challenge at work. You can structure your responses to behavioral interview questions using the STAR method. S stands for situation. Describe the situation, including any context the interviewer needs to know to understand the story. T stands for task. Identify the task, the problem or the challenge you took on. A stands for action. Describe the action or actions you took to address the task. R stands for result. Finally, describe the positive results of your actions. Sometimes, even if a situation doesn't end well, you'll still have a positive result if you learned from it. Technical questions ask about the specifics of technical tools you've used. An interviewer may give you a technical problem and ask you to describe the steps you'd take to solve it. These questions are a chance for you to show off your knowledge and communication skills. When answering technical questions, it's important that you make sure you understand what the interviewer is asking. Take the opportunity to ask clarifying questions. This shows the interviewer that you value collaboration by demonstrating your curiosity and commitment to answering accurately. If the answer to a technical question has multiple steps, it's a good idea to share your thought process with the interviewer as you go. This will showcase your problem-solving skills. Situational questions ask you to explain how you would handle hypothetical situations that you may not have necessarily experienced yet. These questions are designed to find out how you apply what you know to new situations. Subject questions ask you to share what you know about specific topics related to the industry. For example, you may be asked to explain how data moves through the cloud using the stages of the data journey. If you don't know the answer to a question, remember that's not unusual in this fast-paced industry of data analytics. Just explain that you haven't learned that skill yet, but that you are committed to learning what you need to be successful in that role. Or you can try answering the question from the perspective of another skill. For example, I do not know yet how to do that in Tableau, but from what I know in Looker, here's how I would approach that problem. Be sure to remember to fit in some of those questions you prepared for the hiring manager about the company's products and services, their customers, or recent news to better understand their business. It may come up that you have follow-up questions for your interviewer as well. This is your chance to show your curiosity and demonstrate your desire to understand whether the role is a good fit for you. Interviewers may ask you about the work in your portfolio. You can give more information about your goals for each project, the tools you use, and what you learned while working on each project. You should also connect your portfolio to the skills and knowledge that would help you on the job. Pro tip: after an interview, be sure to send a quick email to each interviewer, thanking them for their time and expressing your interest in the role and sharing a positive recollection you have from the interview experience. With a little practice and preparation, you'll be interviewing for job success. Hey there! You've just discovered a variety of career resources and tips that will help you find a new role as a cloud data analyst and successfully navigate the job market. First, you've explored the different types of roles available and role specializations. This will enable you to focus on opportunities that will be best fit for you. You got tips for how to apply for roles and share your project portfolio in a way that demonstrates you're the right person for the job, even if you haven't had a lot of on-the-job practice yet. Then, you explored how to refine your resume to include your skills and experience. And finally, you've identified interview tips that will help you prepare for interviews and ensure interview success. Great job! You're one step closer to succeeding in your cloud data analyst interviews. Hey there! You're so close to completing this certificate program. I'm excited to join you for this last part of your learning journey. Right now, I've got some important details to share with you about your upcoming capstone project. First, we'll discuss what you'll do in the capstone project. I'll also share some useful tips that will help you to successfully complete the project. We'll also explore why the capstone project is important and useful for demonstrating the skills that you've learned throughout the certificate program. After that, you'll have all the necessary instructions and tools to start and finish your project. To wrap up, we'll cover how to incorporate your project into an impressive portfolio and how to confidently discuss your project with potential employers or clients. When you're ready, head over to the next video. In this video, I'll share more about why the capstone project is so important. It's more than just an assignment. Think about a time when you had to complete many small tasks to accomplish a larger goal, like moving from one place to another. For a successful move, you probably had to collect and pack your belongings in boxes, then relocate your boxes to their new location, unpack, and so on. This takes good organizational skills. Like a moving project, in your capstone, you will collect your new cloud data analytics knowledge and then package it into a new single workplace scenario. You'll discover some of the great benefits that come from successfully completing your project, like showcasing all of your accomplishments and earning a professional certificate. So let's get into it. This is an opportunity to bring everything you've learned together so far for one final project. There are 3 points of value with the capstone project. First, by completing the capstone, you'll translate all of your cloud data analytics skills, tools, and experiences in a single, all-encompassing workplace scenario. Second, the capstone will prepare you to succeed in completing a small project, should you be asked to do so as part of your interview process. This is a common way for employers to assess your job skills and how you tackled cloud data problems. Usually, you'll be given a time limit to complete a project or a case study for employers. But don't worry. It's more important to show off your thought process in addressing the problem so that interviewers can understand your approach. And third, this project will also be a preview into what an actual cloud data analytics job could be like. Now let's get into the details of what you'll gain from completing a capstone project. First, you'll be getting workplace experience. The capstone project is like training for dealing with data sets and on-the-job activities that you'll encounter in your career. It is a great opportunity to go from learning the theory and practicing with the tools to actually doing the work that cloud data professionals do every day. The second benefit is improved problem-solving skills. With this capstone project, you'll get better at working through real, complex data sets and making sense of it all. You will also be able to use your project to develop your portfolio. The capstone project is something you can proudly showcase to potential employers. It's ready to share and takes your interview to the next level, where you can not only explain what you can do, but also demonstrate what you can do as a cloud data analytics pro. The fourth benefit of completing your capstone project is highlighting your project management skills. Taking a capstone project from just a case study to a well-thought-out process that effectively addresses a problem involves juggling different tasks, data sets, tools, and a deadline. This project is also a demonstration of your proficiency and skills. Your capstone project is the ultimate proof that not only did you learn about cloud data analytics, but you can also apply what you learned to real-life scenarios. When you finish your capstone project, I hope you feel proud of all your efforts, because when you're done, you've got this impressive project you can then show off to future employers. You've taken everything you've learned so far and brought it all together in an on-the-job cloud data scenario. You're really moving on. Let's meet in the next video. Before you start your capstone project, let's discuss what you can expect so that you'll be well prepared every step of the way. To begin, you will have access to all the instructions you'll need to complete the project. You'll also have the opportunity to review an example to get a clear idea of what you'll be doing. Once you've reviewed the instructions and the example, you'll choose the project that you're most interested in. From there, you'll have access to all the information, data, and tools that you need to get started. The capstone project includes labs and interactive activities, and you're well prepared. This work will be similar to the work that you've been doing throughout the entire certificate program. And if you need a little help along the way, remember that you can always review the previous labs and activities to help guide your way. So there are many resources for you to use. The capstone project will ask you to use all the skills and knowledge that you've developed throughout the entire program. This includes what you've learned about cloud data storage and data management, cloud data processing and analysis, and cloud data visualization. You'll apply everything you've done and put your own spin on the capstone. This can be one impressive project. Once you've completed your capstone, you'll have a bespoke collection of work examples that you can proudly add to your portfolio to wow potential employers and clients. So give your capstone project your very best, and good luck. Nice work! You've completed the capstone project. This is a major accomplishment and proof of all of your hard work in this course. You've used your knowledge of cloud data analytics and data visualization to create a complete representation of your new professional skills. You can now add your capstone project to your portfolio, reference your capstone on your resume, and explain your capstone in interviews. The capstone project gave you on-the-job experience with a data challenge. And now you can share this experience and any component of the project with future employers. As you move forward in your data career, know that this capstone is just the beginning. You have many opportunities to continue your technical and professional growth. You can find mentors or join online groups to learn from others. You can search out practice projects and continuously build out your portfolio. As you decide to continue on your journey, know that anything you learn is an important part of your advancement as a cloud data professional. I'm happy to be the first one to congratulate you on completing the capstone project. Your drive and dedication to cloud data analysis has been impressive, and I can't wait for you to share this with your future employer. Congratulations! You've made it to the end of the certificate program. You maintained your commitment to the program and to yourself to build your cloud data skills. And after persistence and hard work, you've completed all of the courses in the certificate program. I'm honored to be the first to congratulate you on all you've accomplished. But there are others who are waiting to join me.
Congratulations, you completed this program. We can't wait to see what you do next.
Great work. Congratulations on this achievement.
Congratulations for completing this program. You've taken a really great next step in your career in cloud.
You did it! Woo! Congrats! That's awesome!
Awesome job. I'm proud of all your effort completing this program.
Congratulations on completing this program. What an achievement.
Congratulations on finishing your certificate. There's more work to be done.
Kudos on your success. Hope you take this moment to celebrate your hard work and perseverance.
Congratulations. Welcome. Welcome to the world of cloud. I know you're going to do great things.
Congratulations on completing the program. You did it.
Hey, congratulations on achieving that program. You did it. What an amazing achievement.
Nice going. You've learned so much throughout this program. I'm excited for you to use what you've learned on the job.
Hey, congratulations on finishing this program. Wishing you luck on your next endeavor.
You've put in a lot of work to complete this program, and now you have a solid foundation in cloud data analytics. You should be very proud. It's been a pleasure to support you on your cloud data journey. Now it's time for you to make your mark in the cloud. You've just completed this certificate. And this accomplishment demonstrates that you are committed to learning new skills and growing in your career. On behalf of all the instructors, I'd like to congratulate you on this accomplishment. As a reminder, you can share your certificate on any job search platform, like LinkedIn, Indeed, and Glassdoor. And you can add the certificate information to your resume. You can also connect directly with companies hiring cloud data analysts through Grow with Google. Throughout this program, we've discussed the incredible growth of cloud data analytics. You've gained both skills and knowledge in this program that will allow you to step right into this field. Let's review all you've learned in this program. In the first course, you started by learning the basics of data analysis practices in the cloud. You also learned some of the basics of cloud computing and the responsibilities of a cloud data analyst. Throughout the process, you learned about the data team you might work with in the future, and you reviewed the data lifecycle. Finally, you explored the architecture of Google Cloud tools, including BigQuery and Google Cloud Storage. In the second course, you learned about how data is structured and organized. You gained hands-on experience with data lakehouse architecture and Google Cloud tools. With these tools, you learned the basics of ingesting data and writing queries in BigQuery. In the third course, you explored the basics of data discovery. You also discovered profiling methods to ensure data's quality and validity. Then, you learned data mapping skills to create relationships between data sources. And lastly, you explored data governance and security best practices to learn how to keep data safe. Finally, in the fourth course, you visualized data to draw insights. You learned about data storytelling, and you honed skills in visualization development. You also learned how to wireframe interactive, cloud-native visualization tools. This gave you the know-how to build dashboards that support communication and collaboration in data analysis. You've accomplished a lot in these courses, and you're more than ready to take these skills into your cloud data career. As you move forward, be sure to stay engaged in trends in cloud tools and data analysis. You'll always be learning as a data analyst. You can keep up with new advances in data tools and current trends in presenting data. Continuously adding to your portfolio and your resume will allow you to highlight all of your accomplishments. Congratulations again! It's been a pleasure to be with you through the capstone of this program. I'm confident that you are now well prepared for a successful career as a cloud data analyst. Good luck!
Welcome to this intro to cloud.
I thought there was more coming. All right.
Move, keep the energy up or bring it down.
Okay. I was distracted by the hair in my mouth.
You know what?
Do I really have to read all that?
Very colorful.
Transforming, exploring. It's getting sticky.
I wrote this part.
Is it better to be slow or fast? I don't know. I'll jazz it up.
I did one of these.
/:/USR.
Oof. Tripped across the finish line.